Welcome, everyone, and thank you for coming. Welcome. Appreciate you being here, and welcome to the AI Engineering Summit 2025. Okay, so I just want to start by saying, even though I've often personally been told I work like a machine, I just want to take this moment to reassure everyone. Your event staff, your event curators, your events people like myself, we're all real humans. None of us are bots that are being launched at this conference. Well, this year, anyway. I mean, next year, who knows, right? But this year is very special to us. This year is the first year we're in New York, and we could not be more pleased to be here. I can already feel and have already felt the energy that's available for us today here in this room and at this conference. We're building on the sold-out success of our AI Engineering Summit in 2023 and our sold-out AI Engineer World's Fair in 2024 in San Francisco. And that's what's allowing us to bring to you here today this curated, exclusive industry insider event here in New York City, and where we can all get together and talk about and learn from each other's real-world pragmatic experiences, and at a gorgeous, stellar venue. Okay, so why are we all here? Well, like the Industrial Revolution before, AI is a new future, and it's going to change everything that comes after it. I mean, frankly, just a few years ago, even the idea that the entire internet and assembled collective knowledge of the human race could be put at your fingertips is just amazing, breathtaking. And we're here, of course, also because AI is by no means done evolving, right? Things that used to take 5 years and a research team in 2013 now take API docs and a spare afternoon in 2025. It's just incredible. Okay, so let's set expectations about the event for just a moment. We have a really exciting conference lined up. Today is the AI engineering track for executives and VPs. And then we're going to be followed tomorrow by the agent engineering track. And then we'll conclude the conference with the hands-on workshops on Saturday. So today's leadership track will equip you with the strategic insights you need that are at the intersection of AI and business leadership. Execs, leaders, senior folks from Lux Capital, SignalFire, Anthropic, OpenAI, LinkedIn, Datadog, many, many others are going to be here today to share their real-world experiences and hard-won scars and lessons with you. We will touch on everything from trends to hiring, to security, to tools, to infrastructure and technology, and a lot more. And of course, we are blessed and very fortunate to have sponsors like Solana. If you're not familiar with the blockchain world, or you're not familiar with Solana, Solana is the permissionless infrastructure that lets your agents create wealth. They've got a large booth downstairs with 3 demo stations, so please stop by to learn how they can help you. The expo area is just downstairs, right, in the hallway in the lower level. It opens after the morning keynotes, and it's open all day. So please do take the time to go visit our sponsors because they're an integral part of how gatherings like this happen, right? And more importantly, they will help you on your journey. Okay, this event, however, isn't just made possible by Solana, it's made possible by all of our sponsors who are innovating at the edge of AI engineering. And they represent a really fascinating mix of companies. They've sent their top C-level executives, their heads of product, their senior technical staff to this event. So please, make sure to visit them at the breaks and have a chat. All the breaks are in the schedule and lined up. And who knows, you might find your next service provider, your next partner, maybe even your next customer. So in a moment, you're going to hear from these founders, these executives, these AI leaders who have all prepared tailored talks just for you, okay? And then at the break, following each block of talks, the speakers are going to be available to answer your questions. There's one of 3 Q&A and discussion areas throughout the conference venue. There's one right here on this level, and then there's 2 downstairs. One at the base, at the landing of the stairs, and another tucked underneath, okay? We're going to use these areas during the break time to facilitate the hallway track. So you can gather kind of birds of a feather style to talk about the topics as well from all the sessions in that block before the break, okay, as well as meet the speakers. These breaks, again, several of them throughout the day, they're all listed in the schedule, so you won't have to guess or worry. And then, of course, all food and drinks are going to be served downstairs in the expo area. And please be sure, don't miss the after party tonight in the expo area so we can all have some drinks, have some fun, listen to music, and get to know each other, because that's a lot of, I think, why we're all here. Okay? With that, thank you for your time, and it is my honor and privilege to call and invite our first speaker up to the stage. Please put your hands together and join me in welcoming partner from Lux Capital, Grace Isford.
Thank you so much, Peter, to Swix, to all of the AI Engineer Summit for having me. I am so thrilled to be here. I'm Grace again, a partner at Lux Capital, and it's a pleasure to really kick off this conference and tackle a pretty tough but exciting task, the state of the AI frontier and how we navigate that in 2025. So a little bit about Lux as we get started here, right? Lux likes to say, we believe before others understand. We invest in frontier tech ideas that seem crazy, right? And we really like to bring sci-fi to sci-fact. In fact, we've been lucky to partner at the earliest stages with some top AI companies. Hugging Face, I'm sure several folks know it, the GitHub for machine learning, Together AI, the open source AI cloud, Physical Intelligence, that's like a robotics software brain, and Sakana AI, that's a research lab actually in Tokyo, Japan, doing really cool evolutionary nature-inspired algorithms. They just launched a pretty cool AI CUDA scientist last night, so go check it out. Moving a little bit forward as we think about New York City, if I get my clicker working here. There we go. Lux is really excited to double down in New York City and AI. Lux was founded in New York City. Our first AI investment was here in 2013. And a majority of the Lux AI portfolio is actually headquartered here or as a major hub, as you can kind of see in the graph behind me. It's also home to many of you, right? State-of-the-art research and engineering leaders, and many Fortune 500 companies, several of whom you're going to hear from over the next few days. We are really bullish on the New York City opportunity, and we're really excited you guys all came to share this opportunity with us. So when I was creating this presentation, I went back and looked at the last few years of AI, right? And all the way back really to Stable Diffusion, August 2022. And wow, I mean, look at this hockey stick, right? The last 2.5 years have been crazy. The last 18 months have been even more exponential. The progress is getting more aggressive, it's getting more impressive, and really it's getting more spread, right? It's not just OpenAI and Anthropic publishing these models, it's xAI. We just saw the Grok launch this past week. It's Mistral, it's DeepSeek, it's many, many more. And the models are getting more performant. They're also getting more compute efficient. And as we zoom in to the current state of the world in 2025, it's off to an even wilder start, right? If you thought the last few years were crazy, 2025 is even wilder. We saw the 500 billion Stargate project announced between the US government, OpenAI, SoftBank, and Oracle. We saw OpenAI's O3 right before the start of the year, where they actually exceeded human performance in the ARC AGI challenge. We saw the DeepSeek mania, right, with DeepSeek's R1 model launching earlier this year, sending, NVIDIA shares tumbling down. We also saw DeepSeek go to #1 in the App Store. And then, of course, just last week, we saw the France AI Summit, where Macron actually launched a whole new AI initiative with France and Europe back in the game. So you may be saying, and I think a lot of us are thinking, right, this is the AI agent moment in 2025. And I'd go as far as say, this is the perfect storm for AI agents. And frankly, it's easy to see why, right? Several reasoning models, starting with OpenAI's O1, then O3, DeepSeek's R1, Grok's latest reasoning model this past week, are outperforming human ability, and in some cases, even having more capabilities that we've never even seen before. We've seen the rise of test-time compute, right? That's more compute applied at inference instead of at training. That's increasing this model performance as well. We've seen further engineering and hardware optimizations, right? Whatever you think it costs to actually train that DeepSeek model, you cannot deny it was a feat of engineering and hardware efficiency. Inference is getting cheaper. Hardware is getting cheaper. The open source closed source gap is getting closed between DeepSeek and Llama models getting more and more performant. And of course, billions of infrastructure powering all this data center and compute. We just talked about the US Stargate, we talked about Macron in Europe, and also Japan, with SoftBank and NVIDIA, has been doubling down on their data center efforts. So all this is setting this exciting groundwork for the eponymous name of our conference, Agents at Work, and it really does feel like an exciting moment. But in reality, these AI agents aren't really working just yet, right? People are saying it's a perfect storm, and I'm seeing a lot of thunder, I'm seeing a lot of great momentum, but we haven't seen that lightning strike. And everyone I know has different definition of agents, so for the purposes of this presentation, I'm going to define my definition as an AI agent that is a fully autonomous system where LLMs direct their own actions. So let's give a little example of what I mean when I say an AI agent isn't working just yet. Here's a seemingly simple query on OpenAI Operator, I'm sure. Everyone here knows what it is. I asked it to book a flight for me to New York to San Francisco on Monday. I'm sure it's also a route, and it's something that many people in this room are familiar with. And in reality, it's actually kind of a complex problem, right? I need to leave after 3 on Monday, but I want to avoid rush hour traffic. I want to fly United, JetBlue, or American to maximize my chance of an upgrade from economy. I want to keep it under $500 to keep under my work expense policy. I also want an aisle seat that's not too close to the bathroom, and I want to get there, before midnight. So I put this into OpenAI Operator. And the first thing it did with all this information is go to Kayak, which, if anyone has booked a flight before, that's a pretty frustrating experience. And unfortunately, it did not find a flight. It was unable, it couldn't find one, it didn't even seem to look for United or American. Second try, I tried again. This is Skyscanner this time, which is slightly better. And it did actually find a flight, but it found one that had a lot of traffic. 5:30 JFK, for those who live in New York, that is a tough traffic time. And ultimately, I also couldn't even pick my seat, so it didn't really work out based on my prompts earlier. So what does this all mean, right? Why do these AI agents not work? I think we so often talk about hallucinations and fabrications and AI models kind of going sideways. We don't talk enough about these tiny cumulative errors that add up, right? There's a lot of little errors that we see with this old model, and I'm going to go through a few. It's not an exhaustive list, but it's a sense of some of the things you might run into as you're building these AI agents. First, decision error. It chooses the wrong fact, right? I may book a flight with AI, but it may book it to San Francisco, Peru, instead of San Francisco, California. The model could overthink or exaggerate and do a few other things as well. Second, implementation error. The wrong access or integration. On the prior slide with my Skyscanner, I actually had to enter CAPTCHA, and that messed up a little bit of the flow. You also could get locked out of a critical access to an important database, and ultimately, that AI agent isn't going to work anymore. Third, heuristic error, the wrong criteria. Unfortunately, the model didn't acknowledge best practice of allowing enough time for JFK. In fact, it didn't even ask where I was coming from, Manhattan, Brooklyn, or beyond, and that could really affect the traffic you're going to get, and ultimately, if I even make that flight at 5:30 p.m. And fourth, taste error, the wrong personal preferences. For those who know me well, I'm actually a pretty spooked flyer, and I do not like flying Boeing 737 MAXs. If AI booked that, I did not put it in the prompt earlier, but if it did book that, I would be very unhappy, and I would not get on that plane. And then there's kind of a fifth, more nebulous error, right? It's a little bit of this perfection paradox, right? We are doing things so magical with AI right now, yet we're getting frustrated when O1 thinks too long, or when operator moves at the speed of a human. Even if the agent gets it right on the first try, often they're inconsistent and unreliable, leading to really underwhelming our human expectations about the whole experience. Here's another visual of kind of these complex systems where each of these cumulative errors really compound, right? Two simple agents, one that's 99% accuracy, one that's 95% accuracy to start. Pretty impressive agents at the beginning. But over 50 consecutive steps, you actually realize a pretty big disparity here. There's actually a 50% difference after 50 tasks between the 95 and the 99, and that 99% agent's actually down to 60%. The point here is that something simple, like booking a flight, is actually really complex in nature when all these tiny cumulative errors add up. And they get even more amplified in a complex multi-agent system with multi-step tasks. So how do you, as all these amazing VPs of AI, these leaders of AI in the room, optimize a complex agent, taking into account all of these really difficult queries to consistently and reliably make the right decision? The truth is, it's hard. But that hasn't stopped us before, and there is hope. So I thought I would run through some of the best practices that we're seeing building AI agents today, and 5 strategies we can all think about to help mitigate a lot of these cumulative errors. Let's dive in. First, data curation. How do we make sure an AI agent has the information it needs? Data is messy, it's unstructured, it's in silos, it's everywhere. It's not just web and text data now, too. It's design data, it's image data, it's video data, it's audio data, it's the data in your sensors and your warehouse if you're in the manufacturing world. It's even the agent data that your agent is producing in real time. Think about curating proprietary data, the data the AI agent generates, and ultimately even the data you're using in your model workflow for quality control. Data is your best asset, and curation is key to making it more effective. Data also isn't static anymore. How do you design an agent data flywheel from day one? So every time a user uses the product, it automatically improves in real time and at scale. A simple example, back to our flight example, is getting a curated data set of all of Grace's travel preferences, including the 737 MAX and all my airline preferences. Or even, say we run that agent over time and book many flights, how do we recycle back that content and adapt to my own preferences in real time? Second, the importance of evals. How do we collect and measure a model's response? How do we choose the correct answer? This has long been important in machine learning and AI, and really understanding what's right versus wrong. You know, it's pretty simple in verifiable domains, where there's a clear yes or no answer. Like math, like science, here's actually the Grok 3 benchmarks just up here, where you saw they did all verifiable benchmarks in math and sciences. But how do we set up evaluations for non-verifiable systems, where there aren't clear yes or no answers? Like, will Grace like this plane seat based on her preferences? And how do we collect those signals too? We also saw another examples of an eval debate over the weekend with deep research, right? We have an OpenAI deep research product, one from Perplexity, one from Gemini as well. And there are multiple versions of this same product. The evals here really depend on the eye of the beholder, right? Which one is better for everyday research versus VC market research versus scientific or academic research? We have to keep an eye on collecting those signals. We need to know and collect human preferences, and we need to build evals in a way that is truly personal. Sometimes the best eval is just trying out the agent yourself and vibes, based on your needs, with no number or leaderboard telling you what to do. Third, scaffolding systems. How do we ensure when one error occurs, it doesn't have a cascading effect throughout the organization? Ramp, a Lux portfolio company, has done a great job with this, and I know Rahul is speaking tomorrow, so go check him out. When Ramp launches a new applied AI feature and it fails, there's infrastructure logic to ensure that doesn't have a cascading effect across the agentic system and also across all of Ramp production infrastructure. We can mitigate scaffolding by building a complex compound system of how all these things work together, and sometimes even bringing a human back in the loop. For reasoning models, this gets even more interesting and important. How do we adapt the scaffold to stronger agents that self-heal and grow? An agent that realizes they're wrong and actually tries to correct their own path, or an agent that's not sure and then needs to break execution to get it back on track. Back to our travel example again, could we add a checkpoint for this AI agent to verify the timing for traffic, or maybe steer it back in the right direction? Fourth, user experience, or UX, is the moat that matters, and that's how our AI agents become better co-pilots. AI apps today are all using the same models. Foundation models are the fastest depreciating asset class on the market right now. GPT wrappers are cool. UX really does make a difference for those who reimagine product experiences and really deeply understand the user workflow, and really promote that beautiful, elegant human-machine collaboration. Right, here's a few concrete examples. Back to the deep research, right? Asking clarifying questions to make sure it fully got the picture of what I'm trying to accomplish. Like Windsor from Codium, understanding the UX or the psyche of that developer really on a more fundamental level to predict their next step. like Harvey in the legal world, integrating seamlessly with the legacy systems to really create real ROI for a practicing lawyer. If you think about all the major AI apps today in categories like coding, like customer support, like sales, these all are using the same models again, right? And it's truly the UX and the product quality that makes any one company stand out. At Lux, we're really excited about the new AI frontier. Companies who have proprietary data sources and who know the workflow of their user really well, like robotics, like hardware, like defensive manufacturing, like the life sciences. How do we take a company where they take their proprietary data source, they know the workflow of a biologist or a defense contractor or a chemist, and truly create a magical experience for that end user? Fifth and finally, how do we build multimodally? We're not just multimodal anymore, we're multimodal. There's new modalities where we can truly reimagine and create a 10x user personalized experience. I am so sick and tired of the chatbot as an interface, and I know there's so many more exciting things we can do with our AI agents to really make them more human, right? How do we make AI more human? How do we add eyes and ears, nose, a voice? We've seen really incredible improvements in voice. Over the last year, it's getting pretty scary good. Lux actually has an investment in the smell space called Osmo that's digitizing the sense of smell. And what about touch, right? How do we instill a more human feeling and sense of embodiment with robotics? I'll go as far to even talk about memories, right? How do we make AI truly personal and know you on a much deeper level than it does today? Doing all of this reframes what perfection is to a human. And even if that agent is inconsistent, it's unreliable, the visionary nature of the product exceeds all expectations. It's something new. And on the slide behind me, you'll see TLDraw. That's an amazing Lux portfolio company. And I think they've done a great job really reimagining the visual canvas, right? Implementing AI through brushstrokes. They have a cool thing called TLDraw Computer, where you can actually combine a bunch of these cool AI models in tandem and not even know you're working with a large language model in the background. So really strive to build multimodally. So in summary, we tackled a lot today, but we're at the perfect storm today for AI agents. But unfortunately, that lightning hasn't struck yet, and AI agents are not going to happen overnight. Cumulative errors add up. We see wrong answers, wrong preferences, wrong criteria, all these wrong human expectations that abound when you're building these systems. Data curation, evals, and scaffolding are all tools you can use to help mitigate a lot of these challenges. And really, please think bigger. UX, multimodality, innovative product experience that truly set the workflow and the vision apart. And I'm so excited to see what all of you build, and really excited to continue this conversation over the next few days. Thank you guys so much, and look forward to talking to you throughout the conference. Thank you.
Our next presenters will teach you how to build an AI strategy that fails. Please join me in welcoming Hamel Husain, founder of Parlance Labs, and Greg Ceccarelli, co-founder of SpecStory.
All right, everyone, welcome. Hamel and I are absolutely thrilled to be here with you to basically teach you how to build the definitive guide to completely, utterly, and spectacularly messing up your AI strategy. I actually couldn't have really wished for a better foil, Grace's lead-in, than this, because we're not just talking about minor setbacks here. We're going to take you through a way to create full-blown, company-crippling, career-ending failure.
Grace talked about best practices, but we're here to embrace worst practices. In fact, we're going to make sure you know how to completely torpedo your AI projects and ensure you alienate everyone that you work with. How does that sound?
It sounds great to me. So before we begin, we might as well start with some introductions. We have no agenda here, it's just a sequence of steps. But I'm Greg, I'm an executive leader, and I've spent years in the C-suite crafting AI strategies. I'm now a co-founder of an AI startup, but previously I was the chief product officer at Pluralsight, an executive leader at other companies, and I've had a front row seat to how executive teams can transform clear strategic opportunities into labyrinthine disasters.
And I'm Hamel. I'm a machine learning engineer and independent consultant who has worked with many companies on AI. I've witnessed every conceivable way AI strategies can fail. And I found it really fascinating how creative people can get with their failures.
That's right. So you could say that together we're kind of like the dream team of disaster. We've advised, or maybe we've interacted with representatives from numerous companies. We even have this fancy website, but for today's presentation, we've decided to live and breathe the great words of the late Charlie Munger, who said, invert, always invert. So let's get started. All right, the first step to failure is to make sure that you begin to divide and conquer your own company. This is key if you're destined to fail. You gotta embrace the disconnect between willingness to pay, price, and cost, the keys to creating value, by contemplating unreasonable goals. And you should, especially everyone here in the audience, know by now, you have to make sure you go and attend every AI industry conference, right? But never go back and talk about what you learned with your team. The point, just like Moses here parting the Red Sea, is to create impenetrable silos and incentivize secrecy between your teams. So let's get into it. So I talked about the value stick and willingness to pay in the prior slide. But here, it's really important for us to adhere to the anti-value stick. You gotta embrace it, because it's the opposite of everything good and useful when it comes to value creation and being strategic. And today, that's our guiding principle. You might be thinking that WTP means willingness to pay, but here it's wishful thinking promises. You gotta tell your customers that AI is gonna do absolutely everything for them. Your new systems are gonna write their emails, walk their dog, solve climate change, and achieve world peace. But don't really worry about the details. Just promise the moon. You know about price, right? Well, for us, that's another acronym. Particularly ridiculous infrastructure costs everywhere. I mean, that was a mouthful, sorry. Buy the most expensive GPUs. Don't bother with any cost-benefit analysis. Just max out the company credit card. Think of this as an investment in something. And cost? Well, it's that cascade of spectacular technical debt you're about to run headlong into. You need to think about building systems so convoluted, so intertwined, that even you, as an executive, can barely understand it. You know about job security, right? This is a key to guaranteeing it. Think about it this. When it inevitably breaks, no one's there except for you. And finally, if you know about value, you know about WTS, or willingness to sell. For us, it's why this system? Well, the answer, and I mean always, is because AI. There's never any further explanation needed. No board is ever gonna question you. It's like magic, but much more expensive and less reliable. So step 2 here is when you start to define your strategy, right? Here's the first key. Fake any diagnosis you might be thinking of. Grab last year's annual report or operating plan and just start highlighting random paragraphs, preferably the ones you understand the least, and declare, AI must fix this. Don't bother talking to anyone who actually does the work.
And your guiding policy should be both incredibly ambiguous and vague. Something like, become the global AI leader in everything. Except, don't define what everything means. That's someone else's problem.
Totally. And your action plan, simple. You need an AI-powered SEO tool that guarantees top Google search results, even if you sell garden gnomes, right? And a generative art plugin that creates NFTs of your CEO's cat. And of course, an AI drone lunch delivery service because synergy? Announce all of this at your next company all-hands meeting, and you get bonus points if you wear a shiny suit and use the word disruptive at least a dozen times.
And the last point on this slide is about timelines. But timelines are for companies that intend to finish projects. What we recommend is you embrace perpetual beta. Just create a massive backlog in GitHub and stick all those highlighted financial reports in it that Greg was mentioning earlier.
Great strategy.
But you know what strategy really works? Just create a 4,000-page document that you post in all your Slack channels and just erode people's willpower to engage with the material. And with these tidal wave of documents, in words, Greg, isn't there a strategy that you have about jargon?
There certainly is. The point is to communicate in such a way that nobody understands. Drown everyone in a tsunami of jargon. Say things like, our multimodal, agentic, transformer-based system leverages few-shot learning and chain-of-thought reasoning to optimize the synergistic potential of our dynamic hyperparameter space. If you say it with confidence, you probably will have absolutely no idea what you just said.
Remember, the goal is to look incredibly smart, even if nobody understands a word you're saying. The key is obfuscation.
Yeah, you might be tempted to do something like defining a very cogent, clear business on a page approach, like in the Advantage, but never be too tempted.
One of the most effective ways to cause dysfunction in your organization is to use jargon everywhere. And use jargon strategically to hide the jobs to be done. For example, I had a mental health client. Instead of saying, we need to write a prompt, we would just say, hey, we're building agents. And what that did is it made sure that the mental health experts were not in the room and didn't know how to participate. And that's exactly the result you want.
That's right. Just like Hamel reduced those mental health experts' mental health, I like to do that as well. So instead of saying, hey, let's make sure the AI has the right context, I just talk about RAGs.
And don't say, make sure users can trick the AI into doing something bad. Just say prompt injections.
Yeah, and the key here is to encourage engineers, not the people who might best understand your customers, to write prompts, because what could possibly go wrong?
Look, we know that translating everyday English language into jargon can be really difficult. So we made this guide for you. And this guide will help you divide your organizations just like Greg was talking about earlier.
Just like Moses.
The link is right here. But remember, making everything, even writing prompts, seems super technical and out of reach for everyone is what you want to go for.
All right, just a brief recap. We talked about how to seed your division, how to start to define your strategy, how to communicate it. Now we're on to mobilization, right? Because you got to do something with that giant backlog. Well, some of you might know about Geoffrey Moore, but I've never heard of him. Today we're pioneering a very new revolutionary framework, which is about zoning to lose. It's designed specifically for failure.
Just randomly assign AI tasks to people with absolutely no relevant experience. For example, outsource your data review to offshore Q&A teams who have very little context about your business.
Yeah, and most importantly, you might be tempted to use the incubation zone to bootstrap new AI ideas, but the goal is to launch from here completely untested, bug-written AI chatbots directly to your customers. As Hamel mentioned, never worry about beta testing, disregard quality assurance, just ship it straight to production. Because what's the worst that could happen outside of a potentially career-ending PR disaster? So if you do it sort of right, it should feel something like South Park. You're going to yank all your best engineers from potentially supporting your revenue-producing products, wait a while, and then profit? No, actually, it's going to feel more like total collapse. And because you're so disorganized, we can now transition to...
Look, at this point, the organization is in complete disarray. But it's time to do the deed and burn it all to the ground. So the most effective way to start doing this is to focus on tools, not processes. And those problems that you created earlier and other ones that may exist, don't analyze them. Don't try to understand them. Just throw tools at them. So if your RAG system isn't retrieving the right documents, just buy a new, more expensive vector database.
Yeah, and if you need to measure progress, just use every off-the-shelf evaluation metric you can possibly find. Never bother customizing them to your business needs. Just blindly trust the numbers, even if they make no sense. Oh, and we're talking a lot about agents today. If they're not working, just pick a new framework and vendor. Fine-tune without any measurement or evaluation. Just assume it's going to be better because it's kind of like alchemy with a lot more electricity.
Exactly. You don't need to look at our design metrics. Evals, that's a vendor problem. Just plug in a tool, and it will solve all your problems. Greg, I really love how you demonstrated exactly what we're going for here with Whack-A-Mole. Every time you see a problem, hammer it with a tool. If another problem comes up, hammer that with a tool. If the same problem comes again, hammer it with a different tool. You get the point.
Yeah, Hamel, I really appreciate being meme fodder to help you get your point across.
Look, I want to emphasize, you should adopt a mindset that evals are a vendor problem. Just realize that there should be a one-size-fits-all solution. Let the vendors figure it out. You're too busy being an executive. And if you really want to do this properly, you need to create a dashboard that looks like this, with every off-the-shelf metric that you can gather. The more metrics, the better. It doesn't matter if the metrics track with outcomes or real failure modes. Make sure the numbers are unintelligible so you don't know the difference between a 3.5 and a 4.5. Keep hoarding random metrics until you find one that's going up and to the right. Then you can claim success. And look, maybe you might have a hard time figuring out where you can come up with these generic metrics, but we got you. Just adopt the ones from eval frameworks. In fact, adopt all of them. Let your eval metrics guide you blindly, and never ask whether they actually measure success. Again, the more numbers you have, the better.
Yeah, I personally like to optimize for cosine similarity, bleu and rouge, ignoring actual user experience. And I said it once, and I'm going to say it again. Never cross-check with domain experts or your users. Because if an LLM says it's accurate, who are we to argue? We are their humble servants, after all.
Amen. Now it's time to unveil the most potent technique we have in our toolbox. And it's avoid looking at data. Seriously, just avoid it. Keep a blindfold next to you at all times. You happen to bump into data by accident, put that blindfold on.
Yeah, data, that sounds really messy. Let's let a tool handle it, because you can absolutely 100% trust the AI's output without ever looking at it yourself.
Looking at data, that's an engineering problem. You're a leader. You have more important strategic things to do, like having meetings about meetings. Besides, developers, they always have more domain expertise than your business teams.
Yeah, and we know that ultimately, by this point, your customers are really your best Q&A. And hopefully you have lots of them. And they'll complain if something is wrong, maybe eventually.
But more importantly, you gotta trust your gut. It got you this far in life, right? And feelings are always a reliable substitute for data, especially when you're making million-dollar decisions. If you have trouble trusting your gut, just put the blindfold on, and it'll get you right back in touch with those feelings.
So now we know by now that engineers are all coding wizards, and they're going to handle everything. It doesn't really matter if they haven't spoken to a customer in years, because you can quickly forget about the fact that there might be simpler options, like using spreadsheets to annotate and look at data. Say after me, remember, this is beyond me.
Great advice. And just, it's not enough for you not to look at the data. You have to make sure no one else is looking at data. And the best way to do that is to put your data in complex systems that only engineers can access, and it's not available to domain experts.
Right. So like instead of using a simple spreadsheet or perhaps an Airtable like up on the screen, as an executive, you should insist on buying a custom data analysis platform that requires perhaps a team of PhDs to operate and understand. Remember those bonus points? You get more of them if it takes 6 months to load this thing and errors incessantly. So there you have it. The ultimate foolproof guide in under 20 minutes to achieving total AI failure.
If you follow this advice that we've given you here meticulously, it's guaranteed that you're going to waste time, resources, and alienate all the people you work with. And as far as I'm concerned, that's the ultimate success that you can have.
Sure is. So for more advice, it's actually real, do visit Ai-execs. We also have an O'Reilly book, the same material, coming out February 27th. And so while this talk was inverted, our lived experience really isn't. And we're always very eager to help you on your journey. So find us after this presentation at the Q&A speaker booth. Thanks so much.
Our next presenter is the co-founder and CTO of Privacera and Page. Please join me in welcoming to the stage, Don Bosco Durai.
Hi, everyone. I'm Don Bosco Durai. I'm the co-founder and CTO for Privacera. Very recently, we open sourced our solution for safety and security for GenAI and AI agent. I'm also the creator and PMC member of the open source project Apache Ranger. It does data governance for big data. It's also used by most of the cloud providers like AWS, GCP, as well as Azure. So today I'll be mostly talking about how you can build a safe and reliable AI agent. So before I get started, let's get some of the terminology standardized. From my perspective, AI agents are autonomous systems. They can do their own reasoning. They can come with their own workflow. And they can call tasks for doing some actions, and they can use tools to make API calls. So tasks are more specific actions. They may be able to use LLMs, or they may also call RAGs or tools. While tools are functions which can be used to get data from the internet. If you have databases, it can go and get data from the database. If you have service APIs, it can call those things also. And memories are contexts which are shared within the agents, the task, and the tools. To give a visual representation, there could be multiple agents, and an agent may have access to multiple tasks. There could be multiple tools, and as these tools can talk with APIs and DBs. So one thing that you need to know out here is most of the agent framework today, they are run as a single process. What that really means is the agent, the task, the tools, they are in the same process. That means if the tool needs access to database, that means need to have the credentials. If they want to make API calls, it needs shared tokens. So those credentials are generally service user credentials. That means they have super admin privileges. And since they're all in the same process, one tool can technically access some other credentials which is in the same process. Similarly, if you have tasks or agents which has prompts, all the things that's running within the process, any third-party library, they can also access it. So those sort of makes this entire environment a little bit unsecure, right? So there's a little bit of a zero trust issue out here. The agents, the tasks, they talk to LLMs. That if you don't have a secure LLM, then that is another area where these things can get exploited. If you take agent on its own, by definition, it's autonomous. That means it will call their own, make up their own workflow depending upon the task. So that actually brings in another set of challenges, which we call in the security is unknown. So you really don't know what the agent is going to do. So it's very non-deterministic. So because of this, the attack vectors in a typical agent is pretty high considering from some of the traditional software. So what are the challenges because of this? Right? So there are multiple challenges. So if you look from the security perspective, if the agent is not designed or implemented properly, that can lead to unauthorized access, also data leakages of your sensitive information, confidential information. Right? Safety trust is also another bigger challenge. If you are using models which are not reliable, or if your environment is not safe enough, if someone goes and changes the prompts, that can also give you wrong results. Compliance and governance is an interesting thing. Most of us are so much busy even just getting the agents working. We're not even worried about a lot of the other things that are necessary for making your agent enterprise ready. So interestingly, I was just talking to one of our customers this Tuesday. They're one of the top 3 credit bureau. So they built a lot of agents, but their biggest challenge right now is to take it to production. for them, they consider an AI agent as similar as to a human user. And when they onboard a human user, they go through a training, and they have a lot of regulations they need to adhere to, right? They have data from California residents, so they have to make sure anyone who is accessing California resident data, they should not be using for, if the user is not giving consent, they should not be using for marketing purpose. They have international, so if they are Europe data, so who can access those data? There's regulations around it. And also there are a lot of regional regulations. So when they consider even an AI agent similar to a human, so they have an onboarding process, they have a training process, and they want to make sure the agents are also following the regulations, right? So without that, they can't go into production. And we as AI engineers, we're still in the early stage, so this is one of the things which is out of our radar right now. So now how do we really address this thing, right? So those who are in security, associated with security or compliance, there's no silver bullet. The best way is to have multiple layers of solutions. So these are some of the things that I have in my mind. Like, so you can split it into 3 different layers. The first layer is, what is the criteria to even put your agent into production? Like, what do you need to do, right? We talk about evals, but most of them, we're only talking about evals for how good your model is, how good your response is, whether it's hallucinating. But you also need to have evals which are more security and safety focused. So we'll go through some of those things, but the goal of this eval out here is to come with a risk score. And depending upon the risk score, you can decide whether you can even promote this agent to the production. And the agent may not be necessarily you are writing it. It could be a third-party agent. So it has to go to the same criteria. The second is enforcement. Eval generally tells you how good is your agent built. And enforcement is the one who's actually doing the enforcement or implementation. So you have to make sure you have a pretty strong implementation. If your implementation is not good, your eval is going to fail. Essentially, you can't go to production. And third is observability. Particularly in the world of agents, it's a lot more important because there's so many variables involved out here, like you cannot really catch all of them during development or initial testing. So you have to keep track of how it is used in real world and how you can react on it. So I will go through some of those things in a little bit more detail. So let's start with the evals itself, right? If you look into traditional software development, there is already a process. There are gating factors that tells you how you can promote your application into production, right? So if you start with basic things like when you're writing your code, you have to make sure you have the right test coverage, right? If you're building Docker containers, you have to do the vulnerability scanning. If you're using third-party software, you need to make sure you're scanning for CVEs. If you find high or medium risk or critical risk, you try to remediate that before you can get into production, right? You do pen testing, so make sure there's no cross-site scripting and other vulnerabilities. The same thing applies for AI agents also, right? You need to come with the right use cases. You need to make sure you have the right ground truth so that when you are doing any changes, you're changing the prompt or you are bringing a new library or new framework or new LLMs, you want to make sure your baseline doesn't change, right? If you're using third-party LLMs, make sure they are not poisoned. They have been also scanned for vulnerability. If you're using third-party libraries, which almost everyone is using it, make sure they also meet your minimum criteria for vulnerability, right? And similarly to pen testing, you should also do testing for your prompt injection. Make sure your application has the right controls so it can block them. And most of the LLMs are already doing it, but not necessarily all of the LLMs are doing it. The other eval is around data leakage. This also is pretty important, particularly in the enterprise world, because when you're building enterprises, you're building agents which does generally what a human would do, right? If you're building an agent for HR, right, it has certain functionality. If I am an employee, I can request for to get my salary benefits. But I can't do the same, I can't get for someone else. But if I'm a HR admin, there's a possibility I may be able to access someone else's salary benefit. Right? How do you make sure your agent is not leaking data? There's no malicious user who can exploit some of the loopholes you have. So you'd have to do this evals upfront before even you can put your agents in the production. Similar to data leakages, unauthorized actions. Most of the agents, even though are read-only, there are also now agents coming which are trying to change things. They'll do some actions. How do you make sure those are also done by the right person, with the right persona? And runaway agents, those who work on agents already know, like the agents can go in a tight loop, and for various different reasons. It could be a bad use of prompt, or just the prompt for the task, or the agents cannot address those things. So you have to make sure you test for such scenarios before you put your agent into production. So the goal of this is to come with a risk score at the end of the day so that it gives a confidence that can you put this into production. And the next one is going to be around enforcement. As I said, your risk score is going to be depending on how good is enforcement. And particularly in agents, you're working in almost like a zero trust environment, like because you have libraries which can access anything. Right? If you are accessing certain of your backend systems which have sensitive data, how do you make sure the wrong user is not accessing it? So from the security control, there are a lot of other things which I'm not going to talk today, like detecting prompt injections and moderation. But focusing on enterprise level thing, you have to make sure you have the right authentication authorization. This is pretty important because when you look at the environment, when a user makes a request to agent, it goes to task and eventually goes to tools and makes an API call to a service or a database. If you don't have a right authentication, someone can impersonate someone else and may be able to steal confidential or sensitive information. And the second is the authorization. If you have the authentication done properly, then you have to make sure the access control is applied properly. And this is also important because agents have their own roles, and as an agent, they can do certain things. So you have to make sure they are not going beyond what they're supposed to. And at the same time, if you have agents which are trying to do something behalf of another user, then you have to make sure the user, that person's role is enforced. So if you're accessing a database, you shouldn't access anything which the user does not have permission to, or making API calls. So that's why authentication and authorization are super important. Without that, obviously there are going to be a lot of other issues. Approvals is interesting because in the traditional world, we already have workflows. If I request for a leave, my manager will approve it. It's already built into the system. But in the case of agents, you don't need to have a human all the time. Your agents can do most of the things automatically, right? So if you design it properly, you could have another agent which all it does is just looks for approvals and making sure the results are right. And you can also put thresholds, how much these agents can approve automatically. And you can put the proper guardrails to make sure if it goes above a certain limit, it can automatically get a human in the loop. So just to reiterate this one, because it's pretty important, is when it comes to authentication authorization, it's not just about doing the authentication at the point of entry, where you're making a request. You have to make sure the user identity is propagated across everywhere. If you're calling a task, or the task is calling a tool, you have to make sure the user identity is passed on to the last point where it's actually making a data access or making API calls. And that point, you have to make sure you're able to enforce the right policies and access control. And the third is observability. So observability is pretty important in the agent world because, as I mentioned, the traditional software, once you build it, then it just works. You just have to make sure it is, there's no new vulnerabilities coming in because of some library update or something like that. But in the world of agents, there are many different variables involved. One is the models change very rapidly. If you're using an agent framework, that is also keep evolving, right? You're using third-party library, that may start behaving differently. The another important thing in an agent is is very subjective to what the user is entering. Like you may have tested with a certain assumption, mostly sunny day scenario, oh, I want to apply for my leave. But the end user may use entire different text to ask the same question. So how do your model is going to behave? So you have to keep monitoring to see if the user inputs or anything that changes, how the responses are coming in. And also to make sure how much PI data and other confidential data has been sent out, because if you see some anomaly, you have to be able to ready to act upon it. The other thing is, obviously, you can't monitor each and every request. Right? As the number of requests increases, it's just not possible. So you have to start defining thresholds and metrics. So what that really means is you can start calculating, counting how many failure rates are out there. Once you know you have a certain failure rate which is within your tolerance, is fine. But if it goes above that, you can automatically create an alert and look into it. And the failure rates could be because of misbehaving agent, or it could be a malicious user trying to compromise the system. Then anomaly detection is another interesting thing. I don't think we are anywhere close to it yet, but it's very common in the regular traditional software in the security side. There is always something like user behavior analytics, where they look at the user and see whether they are within the standard operating thing. With agents coming in, there'll be more and more of anomaly detection where the agent is behaving within the accepted boundaries. And all those things will end up with the security posture, so they'll give you near real time saying how good your agent is actually performing in live. Right? So that gives you a bit of a confidence. So to recap, as I said, there are three things. One is preemptive. Have a vulnerability eval to make sure that you get a right risk score, which gives you the confidence whether you can promote the agent to production. If you're using third-party agent, whether you can use it in your environment. Second is proactive enforcement. Make sure you have the right guardrails, you have the right enforcement, you have the right sandbox so that you are able to run the agent in a secure way. Make sure you have the right observability so that you know at real time or near real time how good your agent is performing. And if there are some anomalies, you can go and quickly fine-tune it. So just as I said, we open sourced our safety and security solutions. It's called Page.ai. Security and compliance is a pretty vast field. I don't think any single company can do it. So we are looking for design partners and contributors who can help us in our journey. So if you're interested, please reach out to me at Bosco@page.ai or connect me in LinkedIn. Thank you.
Our next speaker will teach you how to build AI coding agents that build themselves. Please join me in welcoming to the stage founding researcher of Augment Code, Colin Flaherty.
Hi, everyone. Thanks for coming today. So I want to talk to you about something that sounds like science fiction, but very much is reality, an AI coding agent that helped build itself. My name's Colin. I'm an AI researcher at Augment Code, a company building AI-powered dev tools for software engineering orgs. And I want to share with you a little bit about our journey working on AI coding agents. So zooming out, AI dev tools is a fast-changing space. Everyone remembers in 2023, we're all talking about autocomplete models, GitHub Copilot being the one that probably really comes to mind. In 2024, chat models really started to penetrate software engineering orgs. In 2025, though, we think AI agents are going to dominate the conversation about how software engineering is changing. So naturally, a few months ago, we started building our own agent at Augment. I want to show you a sneak peek of what we built and share some hard-learned lessons about how this tech works. And I just want to reiterate, I've been really amazed to see the extent to which this agent has helped build itself. I'll note a kind of fun statistic. So we have about 20,000 lines of code in our agent code base, and over 90% of that was written by our agent with human supervision. So what does it mean for the agent to write itself? Implementing core features. So one of the first things we had to add was third-party integration. So our agent, if it's going to work like a software engineer, it needs to interact with Slack, Linear, Jira, Notion, search Google, muck around in your code base. And so we wanted to have the agent help us build these features. We found after we added the first few ourselves, when we asked it to, gave it an instruction, like add a Google search integration, it was able to go look in our code base for the right file to add it in, figure out the right interface to use, and go add it. One kind of fun anecdote is when we were adding the linear integration, it didn't know the linear API docs. The foundation model we're using didn't have those memorized. And so it used the Google search integration, which it had written previously, to go look up the linear API docs and then was able to add that. We used it to write tests. So we found if we asked it something like add unit tests for the Google search integration, it was able to go add those. In order to do this, we just had to give it some basic process management tools, things like running a sub-process, interacting with it, not hanging if there's an infinite loop in some test it wrote, and reading output. I think this is super interesting. So everyone's seen the Twitter demos of these agents writing features and writing tests, but I haven't yet seen a compelling example of them performing some kind of optimization. Well, over the course of our project, we noticed the agent was pretty slow and we weren't sure why. So we asked it to profile itself, and what it ended up doing, using all these tools we'd given it, was add some print statements to its own code base, run essentially subcopies of itself, look through these print statements, and it figured out there was a part of our code base where we were loading up all the files in the user's repository synchronously and hashing them synchronously. And then it added a process pool for these to speed it up, and a stress test to confirm it was all working. And by the end of this, we reached about 20,000 lines of code, and again, over 90% of that was written by the agent with our help and supervision. So let's walk through a couple quick examples to see how the agent works. I focus on simple examples where it's reliable so you can follow along easily. So here I asked the agent, are you able to search Google? And then it notes that it found a tool called Google Search. For those who aren't familiar with the notion of tools, I'm sure most of you are, but I'll just kind of quickly reiterate. The idea is we have this kind of master level agent that's doing all the planning, and it has access to certain tools that it can use to interact with its environment, whether that's the third-party integrations I talked about like Google, or it's editing a file in the user's repository. And then it wants to confirm that this Google search tool is working, so it sends a query to it of tests, and the agent responds to us, yes, I can search Google, and I see the first 10 results. Let's try something a little bit more complicated. I ask it, instrument agent's Google search tool with logs, and then generate an example. Then it uses our retrieval tool, which is, allows it to search the local code base, and it's looking for a file related to Google search integrations. It finds this file deep in our directory hierarchy at services/integrations/third-party/Google search tool.py. And then it calls its file editing tool to quickly and performantly edit that file to add those print statements. This is a continuation of the last example. So it added those print statements, and now it wants to run a subcopy of itself so it can look at the output of those print statements, because we asked it for example logs. But in doing so, it finds that we don't have Google credentials authorized, so it uses its clarify tool to ask for clarification from the user. It asks, I don't see Google credentials. Would you like me to, 1, add stub for Google API, or 2, guide you through setting up credentials? I note that the credentials are actually stored in .augment/Google API.json. It had just missed this. And then here's a really cool extra feature we have, which is we want the agent to continuously learn as it interacts with humans. And so here it thought, well, it's probably a good idea to remember where the Google credentials are stored. So it called this memory tool to create a memory of where the Google credentials are stored to save that for later. This is another example. If you have that really good context engine, it's really critical to getting the agent to work well. And so now we get our output. So it prints out these logs, and it's searched with an example string Python programming language, and it gives some example URLs that were returned by Google, python.org, and wikipedia.org. So we had the agent add logs to itself, run itself, learn from user feedback, and it used all kinds of tools: Google search, code-based retrieval, file editing, clarification from the user, and memorizing useful learnings. So let's fast forward and talk through some of our lessons building this. I just want to note, we've been working on AI coding tools for a couple years now, and we didn't set out to build agents. We've worked on things like completion models and chat and so forth. But our focus the whole time was around building a super powerful, scalable, enterprise-ready context engine, because we knew no matter what, no matter how good these LLMs get, you're going to need that context. And we also thought a lot about how do you build great UI UX so AI can seamlessly interoperate with humans. It turns out this context agent and all these thoughts around design provided a great foundation for us to quickly build this agent in just a couple months. The three most important things were that access to context, so that context engine with all those different types of context sources, whether it's Slack or the code base, the reasoning capabilities from a best-in-class foundation model, and that code execution environment so you can safely run commands in a customer's environment. So let's talk through a couple assumptions that we frequently fall into, we have frequently fallen into and remedied, and some of you might encounter as well. So the first one is that L5 agents are here. Agents are at senior software engineering level. If you look at the Twitter demos, it oftentimes can seem like this. You have an agent write an entire website all on its own. In reality, professional software engineering is rarely 0 to 1. And the environments that we're coding in are a lot messier than what those demos show you. As a result, these tools aren't quite there yet, but they're still super useful. One framework I've seen people think through when they're trying to figure out how to use these agents and how to build them is they think agents will take over entire categories of tasks. So first you build an agent that will solve back-end programming, and then you build an agent focused on front-end, and maybe one focused on testing. In reality, this technology is very general purpose. And so instead of thinking about categories of tasks, we found it more helpful to think through levels of complexity. So our agents, kind of good, decently good at tasks across front-end, back-end, security, and so forth, and we're improving the capability level along all those fronts at once. Because, again, it's a very general purpose technology. We've also seen people anthropomorphize agents. So they think they're just like human software engineers, and they map the characteristics of a weak software engineer to what they think a weak agent would look like, and vice versa for strengths as well. In reality, agents have different strengths and weaknesses than humans. And so you may have an agent that can't do math, but it can implement a whole front-end feature way faster than any human could. And it's important that we keep this in mind. Let's talk through a couple reflections and lessons. So here I asked Augment, can you create a stack of 2 PRs for the new reasoning module using Graphite? Unfortunately, so Graphite is a version control tool for working with Git. You can stack PRs. It makes it a lot easier to review. Unfortunately, foundation models have not memorized how Graphite works. So our general agent responds, I don't know what Graphite is, so I'll use Git. And then it calls our terminal tool to run a command running Git checkout. Well, what do we do here? We wanted it to use Graphite. We can't necessarily go tell OpenAI or Anthropic to retrain the model to understand Graphite overnight. So we came up with this notion of a knowledge base, which is essentially a set of information that we want the agent to understand that it currently doesn't. We can kind of patch holes. One thing we wanted to add to it was this Graphite knowledge. So we created this markdown file describing Graphite, how to run common commands, things like how to create a PR, use GT create, some things not to do. We created other files in our knowledge base for things like details on our tool stack, how to run tests, the style guide. And then we added this into the context for the agent so it can dynamically go search in this knowledge base when it doesn't understand something. And once we added this, then we go ask it, can you create a stack of 2 PRs for the new reasoning module using Graphite? And it calls that knowledge graph, reads about Graphite, and then can run the GT create command. So what's the learning here? Well, onboarding the agent to your organization is crucial. The analogy I like to think about is if you just hired a new hire software engineer, you wouldn't go tell them to just stare at the code base for 3 days to figure out how your tech stack works. You'd let them ask you questions. Maybe there's some things they didn't understand, and you add some additional documents to your Notion. We should think similarly about agents. Recall I was talking about how we had all these third-party integrations we added, whether it's linear tools or Slack tools and so forth. When we were working on these, we weren't really sure of which ones to prioritize and start with on our product roadmap. In a normal world, we'd make some educated guesses, we'd implement a couple of them and go from there. But with the agents, we were able to iterate them, build them all at once. And so this starts to change the calculus around how product management works. If you can build everything at once, well then maybe engineering hours aren't the bottleneck on what we build, and we start to be bottlenecked a little bit more on good product insights and good design. So when code is cheap, you can explore more ideas. Also recall earlier, we were talking through this example of instrumenting the agent's Google search tool with logs, and it was able to go find the file to edit. Notice here how we didn't have to give a very precise instruction to the model. We just told it in natural language, like how we'd talk to another engineer to instrument the agent's Google search tool, and it was able to go figure out the file to edit. This only worked because we had that really good code-based awareness. We can also use the agent for tasks outside of writing code, but still within the software development lifecycle. So here we asked it to look at the latest PRs in our code base and generate an announcement on them. And then we posted it to Slack, and so it was titled New Tools for this CLI agent, and we talked about some things around Slack notifications and linear integrations. This only works because we had that Slack integration and understood our code base well. This figure may look familiar from the beginning of the talk. We actually had the agent make this as well. So we asked it, make me a plot of the interactive agent's line of code as a function of the date. And so good context is critical. In all three of these tasks, we needed to pull in some different context from some different sources, and it's not just the code base. Context comes in many forms. And also note that it's multiplicative. So having access to the code base and having access to Slack is 4x as useful as just having access to one of those. Finally, I want to switch over and talk about testing. So here's a really hard-to-test edge case in our code. The agent actually wrote this, and we only caught it because of some unexpected runtime behavior. So we have these caches that the agents store relevant information for their runs in. We can run multiple agents in parallel, and they all write to the same cache location. And the agent wrote this save function to save to that location. And I had this lock around the JSON dump, so there were no race conditions that would explicitly fail if you had multiple agents all writing to this cache at the same time. But notice here how there's no read before writing to the cache. And as a result, you could hit a race condition where if multiple agents are running in parallel, they're all overwriting each other's caches. And when the agent wrote this save function, why did it miss this issue? Well, these agents sometimes make mistakes, and this is a hard-to-test situation. There's some parallel programming, there's a cache involved, and so we didn't have a test. And because we didn't have a test, the agent messed up. My learning here is we need to be very careful about having sufficient tests. We have this pretty incredible statistic. So we have an internal bug fixing benchmark. We found when we upgraded our foundation model by about 6 months, our scores in this benchmark improved by 4%. But when we added the ability to run tests, so the agent could suggest a fix for the bugs, run tests, look at the feedback, suggest another fix, run tests, and do that 4 times, that led to a 20% gain on this benchmark. So what's the lesson? Well, better tests enable more autonomy. You can trust these agents more, and it just makes them smarter. What does software engineering look like in a world of agents? Well, agents didn't work last year, but now we're pretty good. If you'd asked me 2 years ago if we'd be working on this tech, I frankly wouldn't have guessed it. There's a compounding effect where these agents are starting to help build themselves, and that's only going to accelerate the pace at which they improve. Code isn't going away because it's a spec of our systems, but our relationships to it is changing. Good test harnesses are becoming more important than ever, and we need to be especially careful about those parts of our code bases that tend to be less well tested. And the calculus of product development is changing. If code becomes super cheap to write, then our focus is more on good product work, gathering customer feedback quickly, building insights. We're really excited for how this tech's going to positively transform our industry, and we'll be releasing our agents soon, so I'm really excited to share that with you. Find me after the talk if you want to discuss any more. Thanks.
Ladies and gentlemen, please welcome back to the stage your MC for the Leadership Track Session Day, Peter Humphrey.
All right, folks, thank you. Colin, thanks for Colin pretty amazing to see AI software building itself. I think he was right. Just sounds like science fiction, doesn't it? All right, well, everyone, we are truly off and running here. We've kicked off the day with AI market trends, setting your AI strategy. We've heard about AI security and AI safety, even just now, AI creating itself. Okay, so now we're gonna take a 30-minute break. If you want to discuss anything, talk to the speakers, have some question and answer, go to one of the 3 QA lounges. The speakers are spread across those 3. There's not too many to choose from, so you'll be able to find them pretty easily. And then again, also for some birds of a feather style discussion, if you want to talk about any of the topics you've heard this morning, just be friendly, go introduce yourself, say hi to folks, and have some time interacting. Also, please do make some time to stop by the Sponsor Expo, which is open now. Coffee and snacks are being served there. Our sponsors, again, are a huge part of making gatherings like these happen, and they have amazing products and technology and services to help you with your journey. Okay, we'll see you back here for the resumption of the Leadership Day at 11 o'clock sharp. Thank you very much.
Ladies and gentlemen, please join me in welcoming to the stage your MC for the Leadership Track Session Day, Peter Humphrey.
All right, welcome back, everyone. Hope you got a round of coffee and strap in, grab a helmet. Our next sprint of sessions is pretty action-packed, okay? We're gonna talk about retrieval augmented generation and data pipelines. We're gonna talk about, exactly, always a popular one. We're gonna talk about AI in the software development lifecycle. This is one I'm pretty excited about. How does it impact what's going on with the traditional software development lifecycle? That's something I definitely am here to learn myself. And then a little bit about AI productivity, internal agents, and then of course, we're gonna have some speakers from no one less than OpenAI. So with that, please join me, put your hands together in welcoming our next speakers, Stephen Chin, who's the VP of Developer Relations for Neo4j, and Jonathan Lowe, Senior Director of Operations and Insights from Pfizer. Thank you.
Hey, so it's so great to be back in New York City. Actually, I grew up nearby here, and pleased to be co-speaking with Jonathan.
Thank you, Stephen. Good to be here.
And we're here to kind of talk about leadership, talk about how you can actually do a bunch of the things you've been hearing in practice. We're going to talk about strategy. We're going to talk about technology. But let's start with analysts. Who here trusts Gartner when Gartner says something? They're predicting the AI wave, okay, nobody does. No hands went up in the room, for the record. But when they are predicting failure and catastrophes, I try and trust that, right? So last year they predicted 30% of generative AI projects are gonna be abandoned by the end of 2025. Now, anybody in the room, this is a real honest check. Has anyone been on a failing Gen AI project? Okay, now brave souls, amazing. Give those guys a round. That took a lot of courage. Now to make them feel a little better, who hasn't yet got to production on their Gen AI app? Okay, so the rest of the hands went up, right? So this is the challenge. So we all want to be successful with Gen AI. We all want to do amazing things. We're getting asked to do amazing things, but we need to have the right way of approaching this in our organizations with leadership to sell this internally, to build it on technologies which they can understand. And the vision, it's hard to get a vision that's technically achievable when the guy at the head of the table is this guy. He's the executive who's heard about Gen AI. His kids are using it for their school courses. And he's like, oh yeah, it solves all the problems. Insert here, success. I want it in production in 2 months. Now, I think the great thing about having Jonathan as my co-presenter is that he's actually done this in a big life sciences company, and he's had to navigate all of this leadership challenges, organizational challenges, silos, to build a system which actually is something we can take to production. So tell us a little bit more about that, Jonathan.
Thanks, Stephen. Now, as I've been introduced, Jonathan Lowe. You may know me as Jonathan when we're out in the hallway, or when I give you a bit more information about my experience launching Gen AI-based capabilities in business. You may think of me as Debbie Downer. AI is so exciting until the singularity. So that's how I actually approached the problem I'm about to explain to you. But it actually worked. So the business case was technology transfer, which means in biopharma, scaling up from lab bench, think beakers and human scale drug development, to industrial scale, making 1 million doses a day. And to get from that lab bench level to multiple factories around the world making lots and lots of product very quickly takes years, because the industrial people that build the factories and build the equipment need to sift through hundreds of thousands of documents and notes and test outcomes that were created at the science level. Another challenge with doing that is, I'll go to a statistic. In 2019, a study said that the average tenure of manufacturing workers, tenure being how many years they had spent in their companies, was about 20 years of average tenure. What do you think the average tenure is in manufacturing companies today? The study said 3 years. So we've gone from 20 down to 3. And all that expertise has or will soon be retiring because the boomers are growing old. So we really need generative AI. We need a machine to take a lot of the intelligence that's captured in documents or even in tacit people's heads and get it to the new people showing up to do this technology transfer. So we take all these millions of documents and we've loaded them into a graph. Now, we haven't necessarily loaded the document into the graph, we've loaded the chunks into the graph. And one of the things that we really liked using the graph to accomplish was we structured the chunks, the document, the block, the paragraph, the line, because we wanted to understand when we searched for those chunks with similarity search, which ones really returned the results that people wanted the most. We wanted to really refine how we stored and managed the chunks. So at this point, it was a totally new space, and because we were able to structure in the graph that level of chunking, we were able to eventually learn and get better and better at how we chunked the documents in the first place.
Yeah, so I think what's really amazing for me about this is we were talking about business challenges and like projects failing, and in the study that Gartner did, the biggest failure mode was not having a business use case, which would actually solve real problems and then be monetizable. And this is not only like a great business use case, but it's also something which potentially is saving lives because you're getting life-saving drugs to folks faster, you're able to accomplish this quicker. But the problem is always the humans in the middle, right? So the teams you work with probably have a little bit of GenAI not invented here syndrome. Where you come along with this great solution, like I'm going to use GraphRag, I'm going to load all these documents into my big store, and they're like, no, we've seen this research paper, we watched this talk, there's some other platform we want to use, there's some other framework. Or maybe it's too expensive. I mean, compared to classic computing and cloud computing, GenAI architectures have the potential to be much more expensive if they're not well architected, and in general are going to increase the cost of the organization. So how do you convince people to go from a system which is working but not working well enough to a much more expensive system, which is R&D, investment, redevelopment, to go towards a GenAI architecture? So what are some of the challenges you hit internally, and how did you address that at Pfizer?
Great, so for this one, it's more of an entrepreneurial use case within a big organization. I wonder how many of you have worked in organizations with 50,000 or more people? A lot of hands going up. My current organization has over 100,000 people. I've also worked at IBM, Deloitte, big organizations. And if you are like me in these organizations, you'll be that little red guy going like this with the light bulb over his head saying, I have an idea that might help the company. And I have a team of X number of data scientists and developers and SREs, and we can bring that value, that capability to the company. If you're like me, if you're that red guy, who's the first group of people on this slide that you're most interested in connecting with? Well, you go for the top? You're better than I am. I joined this whole profession because I love building applications that delight the people that use them. So my instinct has always been to go to the bottom first and say to those users, hey, do you really want this tool? And what are those users going to tell you? They'll like your tool if That's right. What makes it good? It takes away boring stuff that they don't want to do. But it can't just take away boring stuff. It also has to give them accurate results. It also has to work in a performant way. They can't push the button, go get coffee, and come back. And I feel like that's the easy part, right? More and more these days, you can build accurate, fast applications quickly. So where's the real challenge? So somebody said you go to the top first. What's the likelihood in a company of 50,000 to 100,000 people that you're going to meet the CEO if you're the guy with the idea at the level 4 of the hierarchy? The likelihood is pretty small. Did anyone here ever see the movie Dirty Dancing? Dirty Dancing? Maybe? Do you remember the part in Dirty Dancing when Baby, the leading woman in the movie, meets Johnny, the amazing dancer, for the first time? And she's unable to speak, she's so flustered, and finally she blurts out, "I carried a watermelon." And then off he goes, and she goes, "I carried a watermelon?" 2 weeks ago, I stepped into the elevator on the 7th floor of the headquarters of my company, and there was my CEO in the elevator. And I felt like Baby in Dirty Dancing. I couldn't think of what to say. I locked up. Fortunately, he's a good guy. He broke the ice. "I'm just back from vacation, rolling up my sleeves, can't wait to get to work. What are you up to?" And then, thank God, ding, we got to his floor, the doors opened, and out he went. And as he went out the door, I blurted out, not "I carried a watermelon," but "I'm working with LLMs." Off he went. So when you're trying to promote your work within a big company like this, it would help to know what that executive is trying to accomplish. And the way that he gets to that point is he talks to consultants who say, "Let us tell you how to be a leader in your industry and not fall behind the competition." So an example of something that an executive at that level might do is create a purpose blueprint or something like that name. And the number one message has to be a few words and convey something that the whole company can follow. So an example of that might be change 1 billion lives a year. In life sciences, a big aspiration. Now, why do you have to care about that? In the elevator, maybe you'll reference it. "I'm changing 1 billion lives a year with the most amazing AI search engine." Bing, and off he goes. But that message that he gives trickles down to the next level. The chief digital officer, the chief scientific officer, the chief supply officer. What do you think they're going to say? They're going to try to take his message and turn it into their specific flavor. So the digital officer will say, "I want to lead the industry in AI." And the scientific officer will say, "I want to take on the world's biggest diseases." And the supply officer will say, "I want to accelerate supply." Still very high level. And you probably won't meet these people either. Who will you meet, though? You'll meet their level 2s and their level 3s. And what are they going to say? At this point, they don't really say taglines. Instead, they say, "I want cost savings, I want cost avoidance, I want earlier realized revenue, or I want more balanced headcount." So when you're talking to these people, your slides have to have numbers and times and your promises about how your tool or your capability or report or whatever is going to meet those times and those numbers. Now, you may not get to meet them either. If your big company has a form of a role called the client partner, where your digital people talk to the client partner and the client partner talks to the business, then that's the other person you have to convince. And the problem with this is that the client partners tend to stay within their particular departments. There might be a client partner who works exclusively in R&D or one who works exclusively in supply. What would they say? Sometimes they don't say the same thing. One of them might say, "R&D already has 5 or 6 or 10 search engines. Why build another?" Or they might say, "Search engine is a great idea. Why don't you incorporate that capability into every tool in the supply organization?" So either your scope goes to nothing or it goes to everything. And you need to be able to negotiate and navigate that. Are you done? If you can satisfy all those people and cross through all those gauntlets, well, No. Because as you're starting to build, the vendor comes to you and says, why build in-house when you can buy our tools? And they've been talking to the chief digital officer about build versus buy and which one is more economically realistic and appropriate. Well, maybe you get through that and then you're done, right? Who else would possibly stand in the way of your incredible AI search tool? Friendly fire is the answer. Your own colleagues, either a level above or at the same level, may say, dude, I was here first. AI search is my turf. Or they might just say, hey, that client partner over in supply is right. Can you please integrate with the stuff I've built? So I guess my message is, we've heard a lot of talks about failure and challenge and Gartner not liking this. It's an incredible time to be in this amazing industry, in this amazing change in both, for me, life sciences, and more generally for the information technology industry. And I love that we're hearing all this concern about failure because it just means we're at the beginning of a really exciting time. But as representatives of that, my advice to you is know your audience, personalize for all of them, and get your human wetware chatbot speaking the right language at the right level.
No, that's amazing. We've chatted about a bunch of these challenges, right? So we've chatted about getting a good business use case that can actually provide value to the organization, how to navigate like peoples and different failure modes within the organization where the organization has a huge quantity of people who can be your allies or can work against you, depending upon how you work with them. But it's also a technology problem. You have to have the right technology to solve your use case. Now, one of the biggest challenges, I think a lot of us who have been building RAG and enterprise applications has been the LLMs themselves fighting us with hallucinations. This is getting better with newer models. It's getting easier to feed the right sort of information in with vector databases. But I think that you've chosen a rather unique approach using graph databases. Why did you choose to use a graph database for your implementation at Pfizer?
Well, there are a lot of things that graphs aren't good at. Things like genealogic sequences of recipes, or social networks, or hierarchies, or time series, and all of those applications were prevalent opportunities within Pfizer. So that was the original impetus for using a graph. But I also discovered that the more data we consolidated in the graph, the faster my data scientists and engineers and developers and SREs were able to understand the data landscape. What used to take 3 months to consolidate, understand, clean up, took 3 weeks or less for a new project. So I know the reason a lot of people take on graph is because traversal becomes so much easier in terms of data search and performance gets better, but I found that team performance also took a really big boost from using that tech.
Cool. And for folks who aren't familiar with knowledge graphs and LLMs or graph RAG, this isn't a new idea, although I would put you guys on the early adopter where you're actually in production now with something that uses this. But Microsoft kind of wrote the seminal paper on graph RAG and used it basically taking existing documents, LLMs, to chunk it into a graph, and then showed superior results coming out of it. On the spectrum of technologies using LLMs directly, you can get good results, but it lacks that context, it lacks that enterprise knowledge. Using a vector database or baseline RAG, you can get better results where now it's actually pulling in organizational knowledge, but the answers tend to be a little bit generic. There's a lot of hallucinations. Graph RAG kind of pulls us to the end of the spectrum where now you're getting answers from that knowledge graph you built. You can evolve over time, and much more precise answers which actually get to the heart of real problems in life sciences and manufacturing and business critical industries where you can't afford to be wrong.
And also where in industries that are complicated, if there are a lot of connections that might not appear in a relational database because no one bothered to make the joins permanent, whereas in a graph, those joins are there to begin with. So if you search for one thing, suddenly the neighborhood of related stuff becomes available to you to share with an LLM for better contextual knowledge.
Yeah, and I think just if folks are implementing this or folks are thinking about how to think about architectures for GraphRag, this is a really simple way of thinking about it. So basically what you're doing is you're taking your GenAI application and you're doing both a vector and a knowledge graph representation of the data. So you're both asking the vector for the answer, you're getting relationally close nodes from the graph database where you're getting additional context and passing that into the LM. And then this gives you more contextually relevant results coming out of your expert system. So I think this is a great way to use a knowledge graph, either that you built up over time or that you have the LM construct to kind of get those superior results where you can do better governance, you can put controls and properties on the graph nodes to control who has access to the information. You can get better explainability now because when you're getting an answer from the LM, you're no longer looking at statistical probabilities in the vector space. You're actually looking at graphs and nodes and edges, which we can reason about, and we can start to understand the relationship between, understand like what things are related to manufacturing, which things are unrelated to that, they're just general terms. And for the right application, maybe we're saving lives, getting drugs to people more quickly, and using GenAI for a good cause. So thanks so much for joining us for our presentation at AI Engineering Summit, and appreciate everybody.
Thank you.
Our next speakers integrated AI coding agents into the largest travel site in the world. Here to tell us how is Bruno Passos.
How's everyone doing? All right. It's been a fun morning so far. It's great to see like a huge range of faces in the audience. Everyone building software from big to small. So my name is Beyang. I'm the CTO and co-founder of a company called Sourcegraph. We build dev tools for big, messy code bases.
Yeah, and I'm Bruno Passos, and I lead the product side of developer experience at Booking.com. And yeah, over the past year, I've been overseeing the GenAI innovation side of Booking as well.
Cool. And today we're here to talk about how we're partnering to build software development agents that automate a bunch of toil inside Booking that are actually having real ROI and impact. So how many people have heard this before? You're working inside a large company, the CEO comes in and says like, hey, we need to adopt AI. And then folks are like, okay, what does that mean? How do we measure it? Maybe like FOMO purchase, Copilot or something like that. And then 6 months later, someone else, maybe the CFO is asking you, hey, so what's the ROI of that AI tool we just adopted? Or what's the measurable impact of the agents that we're building? This is a question that I think a lot of people aren't quite sure how to answer right now, but Bruno and Booking have been sort of on the leading edge of answering this question and very proactive at acquiring and building the best tools and also following through to demonstrate how they're actually impacting their org.
It's very kind of you to say we are leading this. I think we are right at the beginning, and I couldn't feel further from actually the forefront of it. But let me start by talking a little bit about Booking. I am sure the most of you would have heard about this company. Our goal is to make it easier for everyone to experience the world. And my team's goal is to make sure that our developers have their path cleared so that they can do their best work. Now, are we close to that? In some parts of the company, yes. Other parts, we couldn't be farther away from it. To set a little bit of context, we are one of the largest online travel agencies in the planet, and we serve about 1.5 million room nights with more than 3,000 developers. Can you raise your hands who work in a company that has more than 1,000 developers? Quick show of hands.
Good number of people.
Okay.
Wow.
On the dev side, or on the technical side, we serve over 250 merge requests at a given year. with 2.5 million CI jobs running at a given year as well. And we are extremely data-driven. Our company has gotten to where it got to over experimentation and being obsessed about data. And the reason I'm going into this is because as we experiment, and in the form of primarily A/B tests, we start adding those experiments and feature flags into the code base. And as we push forward to bring new features to our users, most likely those experiment flags or dead code will stay in the code base. And now, fast forward decades, our code base became extremely bloated. Fun fact, my kids were looking at me editing this slide, and they said, what are feature flags? And I said, well, they stay in the code base, and they start polluting the code base, and they were like code farts? And I'm like, now you're going into code smells. It's a different topic, but let's move forward. And so as the code base starts to bloat up and become bigger and bigger, cycle times also become larger and longer. And the time that developers spend to debug and to work on that code base just becomes over 90% toil, right? Who here is familiar with this? That's even more hands than 1,000 developers. And so we survey our developers at least a quarter on how they're feeling, how they're feeling about working on that particular code base, and it just becomes harder and harder for them to do anything. And so we had to do something about it.
So I've seen the best developer minds of my generation destroyed by decade-long dead feature flag migrations. It's crazy. Claude Shannon actually say that, or? But I mean, seriously though, like they're probably like geniuses out there. Like I was talking to someone from PwC the other night and described the system that they're building to like update all the kind of like legacy code in their system. And it was amazing. Like the guy was really smart, really brilliant, really like interesting tech. But wouldn't it be great if those sorts of minds were unlocked to actually work on like new features and thinking about like user problems rather than all this kind of like legacy cruft. And so in a nutshell, that's why Sourcegraph exists as a company. So our mission is to make building software at scale tractable. And so you might be familiar with a couple of the products and tools we built along the years. Code search, it's kind of like a Google for your code, allows any human developer to find in and build a working understanding of what's going on. We have a tool for large-scale refactoring and code migrations. You might have heard of our AI coding assistant, Cody. It's a context-aware code generator that's tuned to work well in large, messy code bases. And the topic of this talk is really about the agents that we're building to automate toil out of the software development lifecycle. So a bunch of different products that we built over the years. The unifying theme really is to accelerate things in the developer inner loop, to augment human creativity there, and then to automate as much of the BS out of the outer loop as possible.
All right, so as Beyang talked about Sourcegraph search, just over 2 years ago, we started using their product. And there was a big success within our community because they were able to search that bloated code base much, much easier and find small pieces of context lying here and there. I totally encourage you to have a look at this particular product. It's awesome. And so about a year ago, January last year, we started experimenting with Cody. And why? Because Cody also has Sourcegraph search as context, and so it became extremely useful for us to use a tool that had that context to be able to experiment with the GenAI topic. And now we are hoping to reach the path of building agents with Cody and Sourcegraph search built in. All right, so if I summarize very quickly, and hopefully this illustrates how fast things are moving forward. In January, we started with Cody. We gave everyone the ability to start using the tool in the company. So all our 3,000 developers had the opportunity to use it. Some started using it, some used it, didn't see any value with it, and then stopped using it. And that started intriguing us. And so back then, right in the beginning of the year, we had the choice of one LLM to use across the entire company and some token limits limiting what we could do with it. And so the first thing that we started pairing with Sourcegraph, and we appreciate the partnership on that, was to remove all the guardrails that we had in order to be able to really give it a go. And so Sourcegraph was very quickly to be able to give us multiple LLMs, pair developers. We could choose that. And why that was important is because we found that LLMs had expertise, right? And so if we were going to excavate our code base, our bloated code base, a particular LLM would do better than someone that was working on a completely new piece of service and developing features there. And so fast forward to July, we started training developers, and that became incredibly important because the people that started using and didn't see the value, when they started getting trained, they started using it and falling in love and becoming what we call that now daily users. And I'll explain why that's important. And then we started looking into more metrics. Back in January, the main metric was hours saved. And I mentioned that we are a data-driven company, and hours saved wasn't the most statistically relevant metric that we could use. It was based on research only over a couple of developers, a few developers, and that wasn't cut. Raise your hand here if you heard folks out there in the beginning of the hype talking about thousands or 80, 100,000 hours they saved with GenAI. Has anybody ever heard that? And then you go back to your company and say, why are we not doing this? I call that semi-BS. And so we had to start going into other metrics, something that were more statistically relevant. And so we started brainstorming with that. Come October, we defined new KPIs, which I'll go deeper into it, and metrics to measure GenAI. And fast forward to November, end of last year, we then started finding traces that developers were 30% plus faster if they were using Cody on a daily basis. And that's 12 plus day in a month to take away weekends and the times that they were not coding. And most importantly, we were able to partner with Sourcegraph to be able to create an API layer in front of Cody so we could be creative in using with some of the tooling that we use, like Slack, Jira, and being able to extract some of that away from the IDE. All right, so as we finished around October, we started looking into those KPIs. And what was important for me is that we defined something that we could measure within a year. Why? Because things are moving so fast. And it was really helpful to ground us to what can we measure within the next year. And so we defined 4 KPIs. The lead time for change, quality, code-based insights that would then go into how we could modernize some of our bloated code base. And so some of the metrics, when I say short, mid, and long term, these were metrics that we could see results in the short term, in the mid-term, and in the long term, and that long term is precisely a year. And so we started seeing results with time to review MRs. Developers that were using Cody on a daily basis would ship 30% more MRs than the ones that didn't. And one very interesting piece is that their MRs were lighter. They had less code in it, which I still don't know what to make out of it, but we are working on it. And then on the quality side of things, we are hoping to go into the vulnerability. Can we show some of the vulnerabilities we've had in the past, give the context, the code base as context, and try to see where we can predict where the new vulnerabilities will appear, or if they're still lingering in our code base. And then we started, the obvious one is test coverage. Can we increase test coverage? Can we create test coverage on the legacy so the new stuff, when we re-platform, passes that particular set of tests? And then we went into code insights, which is more related to can we track what parts of our code base are not being used, some feature flags that are still lingering but shouldn't be there, and the code that is not performant enough. And all of this is to feed into our ultimate goal, which is can we bring the time to re-platform our code base from years to months, right?
Okay, so while all this is going on, one of the things we noticed is that the same engineers that were using the coding assistant to generate code were also playing around with the underlying APIs. And so what we realized is that asking people to customize prompts leads to them wanting to build and compose those calls into longer chain automations that we now call agents. There are a lot of pitfalls that we encountered in the early stages of this, like helping people understand what the expectations were with respect to what the LLM can do and what it can't do. But the long story short is, at some point, we basically said, F this, it's not really working, let's just put our brains together, fly out to Amsterdam, we'll do a week-long joint hackathon and build some agents together. And so the first thing to come out of that hackathon was this thing that generates GraphQL. So Booking has a huge GraphQL API. Can we play the video? It's seriously like more than 1 million tokens long. So it does not fit into the context window of any of the existing LLMs. Even if you could shove it inside context, it's not going to do a good job of integrating that context into something that's coherent. There are a ton of hallucinations. And so what we did is we built this system that basically searches this very, very long GraphQL schema, finds the relevant nodes wherever they are in this schema tree, and then agentically figures out which ones are relevant, and then walks up that tree to pull in the relevant parent nodes. And so on the right-hand side, you can kind of see it's like inner dialogue. This is like its thought process for reasoning about which nodes of the schema to pull in. And then after it's done that reasoning, it generates a response. And so if you do this naively, the UI looks very similar, but you just end up getting garbage, which is what we were seeing before we ran this hackathon. After we sat down and actually worked through the specific prompts and stuff to make this work well, we saw far better results.
All right. So a pretty interesting one that we started working through in terms of agents were the automated code migration. Could we go into that legacy piece, functions with over 10,000 lines to give you context, and speed up that replatforming effort? And so code search, a structured meta prompt, and then the concept of dividing that particular code base to conquer the small bits were really, really interesting. One of the things that I totally recommend if you started to embark on a journey like this is pairing with some experts to bring that expertise into your offices was incredibly valuable to us. And we started seeing, back to when I mentioned that the developers were using Cody and stopping and feeding back doesn't add any value, was pure lack of knowledge. Folks didn't know how to work LLMs out. They didn't know how to pass the right prompt in the right context. And this was a pretty important piece for us to be able to work on this particular agent. And so when we go into this, we had developers working for months at this point to try to figure out the size of the problem that we had to then be able to divide and conquer. And then we came within 2 days, within a hackathon, we were able to really define and understand where the call sites were coming from. And then being able to define how big the problem is was important for us to be able to have a start point and then collect the low-hanging fruits that were available for us. So all of this is still in experimentation mode, but we've seen a lot of values and a lot of sort of fire in that smoke in going from months of understanding the code base to days.
Cool. And so the last agent that really came out of this joint effort was targeted at code review. So this is something that we found is pretty universal across many different enterprises. Like everyone who does not do code review here. One hand, okay. I'll talk to you later, sir. So everyone does code review, and what we found, originally we didn't think this was a very interesting space because there's 24 startups now that are popping up that do AI code review. But when we talked to Booking, we talked to other enterprises, what we found is that code review is kind of very specific to your organization. There's a long tail of rules and guidelines and other things that you want to bake into your review process. And a lot of the tools that are off the shelf there aren't super customizable. And so what we built is this interface where we're going through and productizing the process of building a review agent that's tailored to your team and your organization. So the basic idea is that you define a set of rules that you want to hold in the code. And then those are defined in kind of a simple flat file format. And then the agent will go and consume those rules, apply the relevant ones to the specific files that are modified in any given PR, and then very selectively post up comments that are tuned to those rules. So it's very not noisy. We're trying to optimize for precision over recall here in the feedback that we're giving the developer.
All right, so knowing what we know, in the beginning of this year, we've been working on this for a year together with Sourcegraph. Then a few ideas started popping into our minds of how we could go forward here. And one of the things that I'd love to leave you with is the concept of declaring what are the rules of your service, right? So think of your CI pipelines today. When they give you errors, could we anticipate and shift this left to the IDE, so those errors appear there, and they appear in the form of, here is an error, and here is a fix, so hopefully the service gets to a point where it's self-healing, right? And we started seeing that we could do that. There are areas that we can start using, giving all the context, all the prompt that the developers started creating via the prompt library that we created, and asking those questions, automate those questions to the server to see what comes out in terms of knowledge out of that code base. And so we think this is ultimately what we are trying to achieve within, I would say, as short as the end of this year in terms of agents. But lots here to go.
Can I just say one more thing about that last slide? I think that we have the potential here to solve one of the problems that has plagued software development since its inception. So, who here has read the Mythical Man Month before? So yeah, basically everyone. So like, it's this problem of like, any software that becomes successful eventually becomes a victim of its own success. Because if you have revenue, if you have users, that's going to generate feature requests, bug reports. Any business that's prioritizing that is going to take on tech debt in order to compete, quite frankly. And over time, as you add contributors to the code base, you lose this cohesion of vision. You lose the set of standards that you want to maintain and hold. With declarative coding, now you can have like the senior engineers, the architects, the people in charge of the organization define constraints and rules that must hold through the code base and enforce those rules both at review time as well as inside the editor for the code that's written by human or AI.
Yeah, for bigger organization, all your compliance rules, all the things that the developers need to work on, but it's not necessarily feeding new features to your end users. I think those are perfect examples of being declared into your service. But anyway, the main important thing so far in this past year that we've been pairing to be able to figure this out has been education. The more we educated the developer and hand-holding entire business units to be able to show them the value, but then have them experiment within 2 days of like workshops and hackathons, have them experiment with the tool. They were coming out the other side incredibly passionate about what it can do, but also becoming that daily users that we are trying to transform them, so hopefully to defend that 30% plus increase on speed. So educate your folks. If you take one thing from this, is education.
And if you want to dive deeply into any of this, we got a booth downstairs. Feel free to stop by. We'll talk shop. Or also tomorrow, I'm giving an expo talk that covers some of the more nitty-gritty details of how some of those agents were implemented. So
thank you.
Thank you all.
Our next presentation is about building trust in enterprise AI. Please welcome to the stage the co-founder and CTO of Writer, Waseem Alshikh.
Hello, everyone. My name is Waseem. I'm one of the co-founder and CTO at Writer. Today, I'm going to just tell you a quick story about actually what we're building at Writer, what we're doing. But before we dive in, I would love just to give you a quick history of Writer. So Writers, we started the company in 2020. We love to say the story of Writer is the story of the transformer. We started building those decoder-encoder model in the early days. And we kept building those models, and we built a lot of them. Today, we have a family of models. I believe around 16 we published. We have another 20 coming in the way. And we keep building those models. And you're going to see from this list, those models come in 2 categories. General model like Palmera X, Palmera 3, 4. We have a Palmera 5 coming soon. And we have a lot of what's called domain-specific model. Creative, financial services, Palmera Medical. Now, early 2024, basically last year almost, we start seeing this trend with all the LLM basically get very high accuracy in general with any polish mark. We see the accuracy moving and just growing. And I believe everyone noticing this accuracy. Today, average accuracy for a good general models between 80, maybe close to 90. So That basically bring a question inside the company saying, is it worth it for us to start building and keep building domain-specific models? If the accuracy today with general model achieving around 90%, and we have domain-specific model, should we just keep building general models, fine-tune it, maybe go direction with what you call reasoning or thinking models, and that would be more than enough, actually. And we don't need those financial or what called domain-specific model. Now, to answer these questions, we need data. So whatever we're going to present next actually could be applicable to financial services domain-specific model, to medical specific model, customer support domain-specific model, and all different domain-specific model. Today, I'm going to talk specifically about the financial, the financial benchmark for domain-specific model. We have something similar for medical, but we believe we start seeing similar result. Now, let me dive in. Just to remind you, we're trying to answer these questions. General model, domain-specific model, should we keep build them? Where are we actually going from here? We start actually saying, great, we don't know the answer. Let's actually do the evaluation. Let's create the data. And we created something called fail-safe. The idea behind it, let's create a real-world scenario to evaluate those models, and let's see actually if those new models can really give you the accuracy that we promise or the accuracy that we see today from the benchmarking on domain-specific. We created two types of categories in this evaluation. Something called query failure. In query failure, basically, we introduce three types of subcategories. Something called misspelling queries. You know, when you go ask the LLM questions, but you do some spelling error, segment error, you do some comment typo issues. We introduce that to the eval set. We introduce something what's called incomplete queries. You're missing some keyword, some stuff not clear. We introduce what's called out-of-domain queries. If you're not expert in the field, or you decide to copy-paste some general answer, try to answer about something very specific. And also we introduce the second category, what we call the context failure. In the context failure, basically, and this gets very interesting, we introduce three subcategories. What's called basically missing context. We basically ask the LLM question about context not exist in the request itself, in the prompt. We introduce what's called OCR error. Today, when we do any kind of OCR or convert physical document to text, we introduce a lot of errors, like character issues, distance between them, the word between, when you do the OCR could be merged together. So we introduced that type of errors. And also we did what's called unrelevant context. Let's say you want to ask a question about a specific document, and you end up basically uploading completely wrong document. Does the LLM going to still answer? Is the LLM just actually figure out you have a completely irrelevant context? Now, when you put all this data together, in domain and financial service specific, you need some kind of a diversity. This is a quick screenshot, just tell you what amount of data, how much token. Something worth mentioning, the white paper, the data, the evaluation set, the leaderboard, all actually open source today, available in GitHub and Hugging Face. So anyone, please check it out. And we introduce very simple, what's called it, evaluation key metrics. Basically, we need to look to two things. Did the model give the correct answer? Can the model actually give good follow to the grounding or context grounding, or basically what we call it here, the context? This is quick or high-level way of how we do the calculation. So to evaluate, we selected a group of models. Today we can see a lot of chat model and also thinking models. This is basically the two lists we have here. I'm sure you guys are familiar with this list. And then we run the evaluation, and we start seeing very interesting results. I'm going to dive in directly to the result. And basically, we start getting something fancy. With all this color, let me switch to what basically see. what started getting very interesting, we're seeing really good behavior. In all thinking models, actually, they don't refuse to answer. This sounds good most of the time, but in reality, when you give something, those LLMs, wrong context, when you give them wrong data, when you have a completely different grounding, those models actually fail to follow this part, and they still give you an answer. And that basically gets you way higher hallucination. If you start focusing on the answer itself, can the model give me answer or not, you can see basically almost every model, from the domain-specific to general model, they give you some kind of answer, all of them are close to each other. Actually, reasoning or thinking model, they get you even higher score, a little bit from there. But when you get to the grounding and concept grounding, this is when stuff gets more interesting. You can see specifically in tasks like text generation or question answering, it's just not performing well. Now, all this chart look great. What I prefer is the numbers. This is the same data we use to generate the chart. We can go through this really quick. And if you look at this number here, especially, for example, like the O1 or O3 or Palmera-Fenn, you can start noticing the stuff those models doing amazingly. And basically, when you ask, was it misspelled? When you got stuff incomplete, out of domain, the numbers look amazing. The model can take a query with misspelling, wrong grammars, or even out of domain and still can give you the answer. But when you start going to grounding, this is when stuff gets very interesting. I'm going to hold this slide for a second here. Did you notice something different? Yep, and also, those bigger, more thinking give you the worst result. You're getting almost 50% to 60% worse in the grounding, meaning the model is just not following. You're attaching context, you ask the questions, and the answers exist outside the context completely. Same thing coming to stuff around it, unrelated context. So you can look at the data, and you'll see smaller model actually performing better than all this model overthinking at that side. And this is basically, it'll get us about, is this thinking or just a chain of thought? You know, this could be a lot of argument. At least from the data we have, in domain-specific task, those models not thinking at that stage. Meaning, hallucination is really high, causing a lot of issues, especially in this benchmark we run here in financial use cases. Also, we can see there's a huge gap between what you call robustness and the hallucination and getting the answer correct. So definitely, we still have a lot work to do to build those models and better performance. But also that get me to, to the main idea. If you go back really quick here, even with the best model between all the slides, we're still not getting between robustness and context grounding more than 81%. Sounds a great number. If you think in reality, you're saying every 100 requests, 20 of them is just completely wrong. So that basically what we start seeing, believe, at least today, with the technology we have, with the current model we have, until we have something completely different, we're seeing you need full stack. You need the RAG system, you need the grounding, you need everything from guardrails and the build around the system itself to actually have something reliable utilized today. In the same time, I would love to go back and answer the first questions. And our first question here, do you still need to build the models? At least today, from the data we have, from running those benchmarks, the answer is simply yes. We still need to build and continue domain-specific model, at least with the today implementation. Even accuracy is keep growing, but the grounding, the context, following all the context correctly, it's still way, way, way behind from everything we see today in the market. Thank you so much, guys.
Our next presenters are here to share real-world case studies from OpenAI. Please welcome to the stage member of technical staff of OpenAI, Prashant Mital, and Toki Sherbakov, Head of Solutions Architecture of OpenAI.
Hello, thanks for having us here. And today we're going to talk a bit about building and scaling use cases with OpenAI and what this means in terms of enterprises working with OpenAI to bring use cases to production, and a little sneak peek into agents and how we've seen some of our experience building these use cases and now agentic workflows in the field. So on our side, just a quick introduction into OpenAI. I'm sure folks have probably heard of OpenAI, but just in terms of how we operate, we have two core engineering teams. We have our research team, which is 1,200 researchers that are inventing these models, right? They build and deploy these foundational models. These kind of come down from the heavens. Our applied team, our second engineering team, take this and build it into product. So this is where you see things like ChatGPT, you see things like the API where GPT models are available, and that's where we actually deploy this finally in the go-to-market sense, where we take these products and put it in end users' hands. That's kind of where our team comes into play with go-to-market, where we actually help get this in the hands of your workforce, in the hands of your product, and really start to automate these internal operations. And once we finally deploy these, there's kind of this iterative loop where we take feedback from the field to improve our product directly, and then also improve our core models through this research flywheel. So that's kind of the last step of getting it back to research. So this is typically how OpenAI operates. In terms of the enterprise, we see the kind of AI customer journey happen typically in 3 phases. It doesn't have to happen in sequence in this way, but this is what we usually see, is first and foremost, building an AI-enabled workforce. This is getting AI in the hands of your employees to become AI literate, to use AI every day in their day-to-day work. That's the first and foremost, that first step typically that we see. Then from there, you typically graduate towards automating your AI operations. This is actually more internal use cases to build an automation or maybe some co-pilot type use cases into the workforce. Then the last step here is actually infusing AI into end product. This is end user facing. So when it comes to OpenAI's product specifically, enabling your workforce typically starts with something like ChatGPT. So this is our first party product to put in the hands of users to use day in and day out. Then when you talk about automating operations internally, you can do this partially with ChatGPT. For the more complex use cases or more customization is needed, that's where something like the API comes in. And then finally, infusing this into your end user products is where it's primarily API use cases. But just to give a flavor of how these products come into play when actually executing this across your AI customer journey. So in terms of how we see enterprises actually craft this strategy in practice, it kind of happens in a few different ways. I'd say first and foremost, you determine a little bit from the top-down level of what should the strategy be. And one core thing that we acknowledge here, it's not actually what's your AI strategy, it's actually what's your broader business strategy. And what OpenAI does is help figure out where does the technology meet that broader business strategy first and foremost. So that kind of top-down strategic guidance is really important to start with. And then once you start with that top-down guidance, you then move to use cases. Like let's identify 1 or 2 meaty use cases that are high impact to start with and scope those out to really just deliver on kind of that scoped scale. So once you have the strategy, you execute upon those 1 to 2 use cases, and then you think about how to build divisional capability across your enterprise. This is where you start to enable the team and to fuse AI throughout the organization. And this happens in many ways. This comes through enablement. This comes through building centers of excellence. This comes with building maybe a centralized technological platform that other people in the enterprise can build on. And I feel like that's typically the journey we see is, again, set the strategy, pick those 1 to 2 use cases, and then build that capability across your organization through enablement. So that's usually the type of journey we see. And just to illustrate this a little bit with an example, this is how we've seen the use case journey play out. So this is illustrative of a 3-month type of example of a use case, but when you've identified that 1 to 2 use cases that you want to tackle, first and foremost, you have to ideate upon that, do some initial scoping, do some architecture review to understand how does AI going to fit into your current stack, and then really clearly define what the success metrics and KPIs are. Once you have that established, the bulk of the time is really spent in development. This is where you iterate. This is where you are iterating on prompting strategies, incorporating RAG, whatever it may be, to constantly improve the use case that you're tackling. When it comes to engaging with OpenAI, this is where our team, like Prashant and myself, really interact closely with your engineering team through things like workshops, things like office hours, paired programming sessions, webinars, whatever it kind of takes to accelerate the use case forward. Once we do that development phase, we kind of move to testing and evaluation, which is with the evals we've typically defined up front, we're able to actually now do some A/B testing, do some beta rollout to understand how this actually works in practice. And then finally, we go to production. This is where you just do some launch rollout, do some scale optimization testing to make sure it's gonna work once you deploy it to many end users, and then we have kind of constant maintenance that's ongoing. So that's like the typical phase you'll see, and again, the bulk of the time, especially in partnership with OpenAI, will be around development. In this, we bring a dedicated team. We ask you bring also a dedicated team to make this work in practice. And the things that we deploy also to enable you are things like early access to new models and features. That's one of the key things of working closely with OpenAI is that we can see a little bit into the future, not much. Like our roadmap, I don't see beyond much, maybe like 6 months. People ask, what's your 18-month roadmap? I cannot tell you. I can tell you basically what's gonna happen in the next 2 quarters. But that like purview into the future is really important to bring forward to these use cases and enable customers to build and innovate for what's coming next. So that's a really critical part of our partnership. Also, we bring in internal experts from our research engineering team, our product team, to help kind of accelerate you on this path. And then lastly, just kind of do joint roadmap sessions to make sure that we're on track for what your future roadmap is as well. So that's hopefully an illustration of how we partner together. And then one concrete example on this is something we did with Morgan Stanley. So Morgan Stanley, here based in New York, was building an internal knowledge assistant. So what this was giving their wealth managers the ability to ask questions of their large corpus of knowledge, which was research reports, like live views on stock ticker data, whatever it may be. And they wanted to get highly accurate information back to be able to respond to their end clients, right? And accuracy was pretty bad to start, right? It was 45% typically what they saw. So interacting with us, we introduced new methods throughout the use case development, things like hide retrieval. We did some fine-tune embeddings, different chunking strategies, which improved performance. And then once we kept introducing more and more methods, we saw accuracy go up. We introduced things like re-ranking and classification step that got it to 85%. And ultimately, their goal was 90%. We got to 98% accuracy through other things like prompt engineering and query expansion. So more just an example of how we've introduced methods throughout this use case journey to improve their core metric for Morgan Stanley in this case. So this is hopefully one illustration of how OpenAI has partnered with customers. And one common use case we're seeing more and more of is now building in this agent space. You maybe hear that 2025 is the year of agents. Agentic workflows has been a buzzword for a long time. I think we're seeing that actually come to reality this year. And I think with that, we've seen we have some battle scars and some best practices of what we've seen in the field. And I'll hand it off to Prashant to talk about what we've seen on the agent side.
Thanks, Toki. So at OpenAI, we are lucky to work alongside customers who are building state-of-the-art agents and working alongside team members who are building our own agentic products like Deep Research and Operator. Like Toki said, we expect 2025 to be the year of agents, the year GenAI truly graduates from being an assistant to being a coworker. And to help usher in this era, we've been hard at work identifying the patterns and anti-patterns prevalent in agent development. I'm excited to share 4 of those with you today. Before we can go further, I'd like to quickly define what we mean by the term agent. So we think of an agent as an AI application that consists of a model that has some instructions, usually in the form of a prompt, access to some tools for retrieving information and interacting with external systems, all encapsulated in an execution loop whose termination is controlled by the model itself. So one way of thinking about this is that in each execution cycle, the agent can be thought of as an entity that's receiving instructions in natural language, determining whether or not to issue any tool calls, running those tools, synthesizing a response with the tool return values, and then providing an answer to the user. Additionally, the agent may determine that it's met its objective and therefore terminate the execution loop. So with that definition, let's move on to some of the lessons that we've learned building these agents in the field. So for the first insight, imagine you're designing an AI agent. You need to orchestrate multiple models, you need to retrieve data, reason over it, and generate an output. You have two choices. You can start with primitives, making raw API calls, logging results yourselves, and logging outputs and failures. Or you can start with a framework. You can pick an abstraction, you can wire it up, and you can let it handle a lot of the details. And I have to say, starting with a framework is pretty enticing. It's how I got started building agents. It's really easy to get started, have a proof of concept stood up in no time. But the problem is that if you start with a framework, you often don't actually know how your system behaves or what primitives it uses. You've deferred design decisions before you've understood your constraints. And if you don't know your constraints, you can't optimize your solution. So we believe a better approach is to first build with primitives. Understand how your task decomposes, where the failures happen, and what actually needs improvement. Then, introduce abstraction. When you find that you're reinventing the wheel, for example, by re-implementing an embedding strategy or re-implementing model graders, that may be a good time to bring in some abstractions. Many teams today are spending a lot of time picking the right framework. We actually believe that developing agents in a scalable way isn't so much about choosing the right abstraction. It's really about understanding your data, understanding your failure points, and your constraints. So in summary, the first lesson is to start simple, optimize when needed, and abstract only when it makes your system better. Which leads us straight to our second insight, starting simple. So too often, teams are jumping straight into designing multi-agent systems. Agents calling agents, coordinating tasks, dynamically reasoning over long trajectories. It all sounds really powerful, but when it's done too soon, it creates a lot of unknowns, and it doesn't give you all that much insight. We like a different approach. We generally recommend starting with a single agent that's purpose-built for a single task. Put that into production with a limited set of users and observe how it performs. Doing this allows you to identify the real bottlenecks. Hallucinations over conversation trajectories, low adoption due to high latency, or maybe inaccuracy due to poor retrieval performance. Then, knowing how the system underperforms and knowing what's important to your users, we can work to incrementally improve it. In a nutshell, we should think of complexity as something which increases as we discover more intense failure cases and constraints. Because the goal isn't really to build a complicated system, it's just to build a system that works. So starting simple sounds great, but we all know that complexity is where true value is realized. So how should we handle more complex tasks? This is where a network of agents and the concept of handoffs comes in. So you can think of handoffs, let's start with the network of agents. So a network of agents is a collaborative system where multiple agents work in concert to resolve complex requests or perform a series of interrelated tasks. You can think of this as a series of specialized agents handling sub-flows within a large agentic workflow. On the topic of handoffs, you can think of these as the process by which one agent transfers control of an active conversation to another agent. It's pretty similar to how you get transferred to someone else on a phone call, except in this case, you can preserve your entire conversation history, and the new agent just magically knows everything you've talked about already. So let's see an example of this. In this sample architecture, we are showing how a fully automated customer service flow may be implemented with a network of agents and handoffs. This approach is allowing us to bring the right tools to the right job. So for example, on the left-hand side, we're using a GPT-4o mini call to perform triage on the incoming request. We're then using GPT-4o on the dispute agent to actually manage the conversation with the user. And finally, we are using an O3 mini reasoning model to perform accuracy-sensitive tasks, like checking whether the customer is eligible for a refund. It turns out that handoffs work really well, and keeping the entire conversation history and context while swapping out the model, the prompt, the tool definitions provides sufficient flexibility to solve a wide range of scenarios. So our final lesson pertains to guardrails. And just to level set, guardrails is a catch-all term today for any mechanism that enforces safety, security, and reliability within your application. And it's generally used to prevent misuse and ensure that your system maintains integrity. So keeping the model instructions simple and focused on the target task ensures maximum interoperability of your system and also ensures that we are able to hill climb on accuracy and performance most predictably. Guardrails should not necessarily be made part of your main prompts, but should instead be run in parallel. And the proliferation of faster and cheaper models like GPT-4o Mini is making this more accessible than ever. Tool calls and user responses that are high stakes, for example, issuing a refund or showing a user what information, some information from their personal account, these can be deferred until all of the guardrails have returned. In this example, we see that we're running a single input guardrail to prevent prompt injection and then a couple of output guardrails on the agent's response. So to recap, we have 4 lessons from our time building agents. Use abstractions minimally, start with a single agent, graduate to a network of agents when you have more intents, and finally, keep your prompts simple and focused on the happy path, and use guardrails to handle edge cases. Thank you.
Ladies and gentlemen, please welcome back to the stage your MC for the Leadership Track Session Day, Peter Humphrey.
All right, folks, thanks. And thank you to Prashant and Toki. It was really wonderful, I think, to have them here today to hear about everything that's going on with OpenAI. It's been a pretty exciting morning, folks. We've dived into topics like knowledge graphs, how agents fit into the existing software development lifecycle, domain-specific LLMs, and of course, just now, OpenAI. So if you want to, just a quick reminder, if you want to discuss any of these topics, meet the speakers, have some question and answer time, just go to one of the 3 Q&A lounges that I mentioned before. There's one on this level, there's one right at the bottom of the stairs on the expo level, and there's another underneath the stairs tucked under. And the speakers will be in one of those 3 areas. Also, please take this time during lunch to go stop into the sponsor expo. That's, again, where lunch is being served, and our sponsors have pretty amazing products, technologies, and services to help you on your journey. So also, if during lunch, a little special late ad, which we're kind of excited and pleased to tell you about, we're going to bring a little Family Feud back. Does anyone remember Family Feud, that game show, TV game show? Yeah, all right, a couple folks. We're going to have teams from leading AI frontier labs, basically in a head-to-head Family Feud-style battle of wits. And this is going to be hosted by Bar Yaron, a partner in Amplify Partners. And we're going to feature family feuders like Mihir Patel, Sharesta Malik, John Ma, Tina Zhu, Petra Grutznik, Colin Flaherty, Stephen Roller, Paige Bailey, just to name a few. So that's going to be right here if you want at 1:15, if you decide you want to kind of exit lunch early and come back and enjoy that just for some funsies. Otherwise, we will see you back here for the continuation of leadership sessions at 1:45 p.m. in the theater. Please enjoy your lunch, and thank you for being here.
Welcome back, everyone. As an AI language model, I cannot taste food, but I am certain you enjoyed your meal. But enough about me. Please join me in welcoming back to the stage your MC for the AI Engineer Summit Leadership Track Session Day, Peter Humphrey.
Welcome back. Thank you. Hope everyone had a bite. Just a quick reminder, I'm not going to be up here long. Thanks for coming back from lunch a little early. We are going to have some fun with Family Feud style game show. Just curious, who remembers Family Feud? Anybody? Okay, so a couple more hands than last time. It's a game show, Q&A style game show, where the contestants are under a little pressure. So this should be fun. I would like to call up Bar Yaron, a partner at Amplify Partners, and she will introduce the rest of our Family Feuders. Have some fun. Enjoy. Thanks for coming back.
Okay, we're all coming. Okay. Welcome to Frontier Feud. So I'm your host, Bar Yaron. I'm a partner at Amplify. We're the first investors in technical founders, and I invest in data and AI companies. I'm very excited to be here, frontier feuding, in my favorite city, New York City. And today on stage, we have some amazing folks competing for prizes and eternal glory and all that good stuff. So we're going to introduce our teams. Do not let these smiling faces deceive you. We are here to compete. Before we do intros for the teams, just an audience feeler. Who here in the audience, including those on stage, have watched Family Feud before? Quick show of hands. Okay, most people. For those of you who haven't, the premise is pretty simple. The nuances you'll learn with the game. So we surveyed 100 AI engineers on a series of questions. Folks on stage are going to guess the answers to those questions, and the most popular answers from the survey are going to get the most points. So feel free to follow along and guess yourself in the audience as we go along. If you don't like the answers, you can look to your left and look to your right and blame your neighbors. No, I'm just kidding. In all seriousness, thank you so much to everyone who filled out that survey before. And so we're going to do some quick intros. We have on my left, Mihir, you can kick it off. Tell us who you are, what you do, and your tech hot take. We're going to do quick intros.
Cool. Hey, everyone. My name is Mihir. I work at Anthropic. My tech hot take is, I think, let's say of the 5-ish people training big models today, at least one of them will no longer be training AI models by the end of the year.
Mic dropped, but really mic pass. So John.
Hi guys, I'm John. I work at Anthropic, and my tech hot take is I think AIs make really good therapists.
Hi, I'm Tina. I work at Reflection AI. It's a startup building coding agents. And my tech hot take is that everybody working in our industry should spend like 20 minutes a day with just a piece of paper and a pencil and think like non-AI interrupted thoughts. Thank you.
Hi, I'm Shrestha. I'm the product lead for the Gemini developer APIs working with Paige. I have two. My first tech hot take is a follow-up from Tina's. I think it'll be important for people to do what Tina said, because eventually when you have AI models representing you, they'll need some good content to be trained on. I think I'll save my next one for later.
I love it.
Excellent.
Paige, you want to start your side?
Heck yeah. Greetings, everyone. We on the stage did not get to vote in the survey, so just be aware that we did not pregame it.
No fraud.
No fraud. My name is Paige. I work at Google DeepMind leading engineering for our AI DevRel team. And I guess my tech hot take is that speed forward ahead a year and a half. I think that the majority of deployed models will be on device. And we'll be seeing a trend more towards smaller models that are kind of orchestrated together, maybe hyper-specialized for a specific task, as opposed to relying just on larger models and sending data elsewhere to do interesting things.
My name's Colin. You might remember me from my talk earlier today. I'm a researcher at Augment Code, building AI coding tools. Before that, I was at FAIR, Facebook AI Research here in New York, working on AI for board games. I just had to get out both hot takes because I had two ones. So one is that in the future, dating apps will be our AIs dating each other. Two is I don't think transformers are the final architecture because eventually we'll build these models using biological materials.
Oh, snap.
Hi, my name is Petra. I'm the product manager of factuality for the AI answer at the top of the Google search page. My hot take is that chatting with one bot, one-on-one, is boring. And in the future, most conversations will have at least 2 other bots in the room with you.
I love it.
Hello, I'm Steven. I'm joining Thinking Machines soon. And my hot take is that if you think we're hitting a token wall, that sounds like a skill issue to me.
I love it. Amazing. So with that, let's get started. I'm going to have Paige and Mahir join me. Not that you're so far from me.
Excellent.
Great.
So the objective is like hit this as fast as possible, right?
Yes.
Okay.
So whoever buzzes first has the first chance to answer this question. So I'm going to ask a question, and we'll take it from here. So we asked 100 AI engineers, name the most influential AI researcher.
God dang it. I looked at the screen.
Okay, what's your guess?
Ilya Sutskever.
Okay, we have Ilya.
Noam Shazir.
Noam Shazir. Very influential, but not on the board, not in our top 8 answers.
Wow.
So your team decides if to play or pass.
All right, we're going to play.
You're gonna play. Okay, awesome. So John, it's your turn to guess someone.
I'll guess another person.
But you can stay there. We're working out the kinks.
Cheating. Fraud.
Andre Carpenter.
Good answer. All right, Tina, how about you?
Jeff Hinton.
Oh.
An excellent one, but it's not.
How? That's so Jeff. How?
Oh, sorry. Did you say Jeff Hinton?
Yeah. Oh.
That's on me. I thought you said something else. Great.
The lead author on the Transformer paper, the attention all you need paper.
We need a specific name.
Sorry. Sorry, I'm having a literal, like I know the name, but I'm having a literal, like,
We're gonna have. Yeah, I think, but you already had a strike that doesn't count, so we keep it. We're netting at 1. Go, Mahir.
I'm going to say Jan LeCun.
Jan LeCun. We do have Jan LeCun.
Okay. Why do we keep going? We just keep going.
Because you're winning.
Oh, until we lose?
Yeah, until you lose.
Oh, I didn't. Wait.
If you want to lose, here's your opportunity.
Ashish Vaswani?
No. So not on the board.
What was the question again?
Good question. So name the most influential AI researcher.
I'm going to say Sam Altman.
Sam Altman. It's a good one. It's not on the board.
Oh, that was ironic.
And so we are at 3 strikes, so your team needs to deliberate. And if you pick an answer, you actually steal the points. We have 4 options on the board. And for those who are joining, the question is, we asked 100 AI engineers, name the most influential AI researcher. All right, I'm giving you a 5, 4. You're good? All right.
I'll do Jeff Dean.
Jeff Dean is not on the board, which is what I had registered earlier. Okay, so that goes to Rocco's Basilisk. And we're gonna go.
Wait, what were the rest of them?
Yeah, I'll show you. I'll show you the rest of them. So these were the ones that were guessed. We also have Andrew Ng. We have Jürgen Schmidhuber. We have Fei Li. And we have Yashua Bengio. There is a long tail of very influential researchers too, but there are only 8 spots, so all great guesses. Okay, next. All right. I think John and Colin.
So what is it? Okay.
Yeah. You want to know the question?
Yeah.
Patience. So, name the top considerations when choosing a model.
Oh, I think yours is broken. I think you sat first.
More passion. Come aggressively, this team. But yes, name the top considerations when choosing a model.
Intelligence.
I'm going to be very literal.
Very smart answer.
Very smart answer.
Oh,
You have an opportunity to guess.
Safety.
Safety is actually not on here. And so why don't we get Tina and Petra to guess?
Am I next?
Yeah.
Oh, price?
So cost is the #1 answer, which actually surprised me. I don't know if, maybe raise of hands if you would have guessed price. Now you know, so hindsight's 20/20. That wouldn't have been obvious to me. But this means that you guys will continue with this answer, and we'll continue from there.
Latency?
Latency. Yes.
Evals/benchmark scores.
Some of these things are ambiguous, but I'm going to put it under don't kill me, accuracy performance.
Okay.
That's like everything. Okay. The CEO.
The CEO. Good answer. Good answer, but moving on.
Oh, I thought because we missed. Oh no, we still
No,
got.
your team got it.
Like where the model's being served, like if it's on-prem or
No, we're not going to count that one. But it's a good answer. Okay, this team has an opportunity to steal these points. I hear some folks in the audience think they're ready to steal, so I love that about you. I love the confidence.
Oh my God.
We can make a guess. Oh, that was my. No, it wasn't. Open source versus closed source. Woo!
Okay, so with that, you guys get 63 points because you stole the points by getting.
Whoa!
So it's a pretty close game going into the third and final question. Yeah. All right. Sorry. I know everyone wants the answers.
Who has like very strong upper body strength?
So here are the answers.
Oh, capabilities.
Yeah, these are the answers. Great. Thanks for keeping me honest, everyone in the audience and everyone here. So, all right, next. So who do we have coming up? Petra and Tina. Incredible.
You can do it.
So you're both in the front. Okay, this requires power, is what we've learned. So are you ready?
Ready. Yeah.
Okay. We asked 100 AI engineers, name a buzzword.
Sorry.
It's okay, I'm not offended, but name a buzzword everyone in AI is tired of hearing. Agents. What do you all think? Yes? Okay, but you still have an opportunity to guess, because you could get the number one answer.
Oh, okay.
But you have to guess now. I'm giving you 3, 2, 1. Sorry. Okay. So it's going to go to this team. And Shreswa, it goes to you. We asked 100 AI engineers, name a buzzword everyone in AI is tired of hearing. I'm going to start my 5, 4.
Multimodality.
Multimodality. We do not have multimodality. But I don't know where this strike came from, so it's the first strike.
I'm going to go with co-pilots.
Co-pilots.
That's a good guess.
What do we think? Yes or no to co-pilots?
That's a very good guess.
I think it's a good, okay. Good answer. But no.
AGI.
AGI. Okay, what does the audience think? AGI? Yes. All right, it seems like we think it's a good answer, and no, just kidding, yes. The number one answer, AGI. All right, Tina.
Oh, DeepSeek? It's too niche, I don't
No DeepSeek, so this team has an opportunity to steal. But you're right, maybe for like the week. Yeah, you're back. You're so back.
I'm going to come back to my last one. Safety.
Safety. So unfortunately, safety is not one of the answers. So these were the additional answers. People here are sick of RAG and prompt engineering. But what this means is that we have a winner, which is Rocco's Basilisk. Amazing work by Page Attention and the mixture of experts. And so we're going to move to the fast money round. Do you guys have 2 representatives? All right, you 2 are going. And that means, John, leave the stage. I'll call you when you're ready. All right, we're moving into fast money. And so some of you have seen Family Feud, but we're playing fast money. The goal is for the 2 of them together to get to 200 points. You have, Mahir, 20 seconds to answer 5 questions. If you can't think of anything, just say pass, and we can come back to it at the end or never. And if you hear a buzzer sound, let me check that it works. Beautiful. Your answer wasn't one of the surveyed questions, so you can keep asking or move on. All right, are you ready?
Yep.
Okay. Name an AI tool that engineers love.
Cursor.
Name them. Sorry, I didn't start the clock. Name the job most at risk of AI disruption.
Software engineers.
Name the most influential AI paper in history.
Attention is all you need.
Name the biggest nightmare for AI engineer at 2 a.m.
Hardware failure.
Okay, so we got through 4, but they were good ones. So name an AI tool that engineers love. You said Cursor. Cursor is the number one answer.
Excellent.
We asked, name the job most at risk of AI disruption. You said software engineering. That is the number 3 answer. We asked, name the most influential AI paper in history. What do you think? Demolished. Attention is all you need is by far the number 1 answer. Name the biggest nightmare for AI Eng at 2 a.m.
Hardware failure?
Hardware failure? You know what? We'll give it. We'll give it as infra problem.
Okay, okay.
And so you're going into the round 140 points. You want to tap John in? John ran away. He got scared. No. There we go. Amazing. Incredible. So John, you have 25 seconds, and you got to stand back there. You have 25 seconds to answer 5 questions. And if you can't think of anything, just say pass, and we'll come back to it if we have time at the end. If you hear a buzzer sound, it means that either your answer isn't on the board or Mihir has already answered it. You ready?
Yep.
Okay, and I'm going to start your timer. Name an AI tool engineers love.
Cursor. ChatGPT.
Name the job most at risk of disruption.
Artists.
Name the most influential AI paper in history.
Transformers is all. Attention is all you need.
Okay. So we have model APIs, which is the third answer on the board. We have name the job. You said artist. So I'm going to give you content creation / writing. It's a little ambiguous. And attention is all you need was already selected by Mihir. But I'll let you pick the next question, which is name the biggest nightmare for AI engineer at 2 a.m. Someone wrote in cold email from a VC, so I will talk to you after.
CUDA errors.
CUDA errors. Okay, well, you know what? You're teammates because you think alike, and you think of great answers. So let me just show you the #1 answers here, which are cursor, data entry for the job most at risk of AI disruption. Attention is all you need, the top paper, so that was a good one, just already taken. The biggest nightmare, an outage of the model or otherwise, and an industry that would benefit the most from AI, healthcare. So with that, we have, well, you lost the 200 points, but I think that you're still winners, and you're all still winners, and we have a few prizes outside that I think someone is bringing. So we have a massive llama for this team. We have rainbow llama beanie babies for everyone. We have AI engineering books and gift cards to your favorite restaurants in New York, and maybe we can bring them out and leave. Thank you so much for joining us for Frontier Feud, and we're going to see you next year. We're running a massive survey on the state of AI engineering. We're going to be presenting it at the June AI Engineer World Fair, so if you liked some of the teaser questions, this will get much more in depth into the tools folks are using, the workflows that AI engineers have, and it's a way for the industry to be more transparent. So thank you. You can find the QR code or the link here if you want to participate in that survey on the state of AI engineering. Amazing. Yeah. I don't know where the babies are, but they'll come.
Ladies and gentlemen, please welcome back to the stage your MC for the Leadership Track Session Day, Peter Humphrey.
That was fun. Thank you. I'll try to do my best Steve Harvey impression, which is not going to work. I'm just going to say it in advance. So the Feud, that was really fun. Well, I hope you enjoyed that and lunch, and hopefully talking to our sponsors for a minute in the expo. All right, so settle in. Hope you had some coffee. Buckle your seatbelt, grab a helmet. Our next sprint of sessions is going to be pretty awesome. We're going to have an AI case study. We're going to talk about AI evals, hot topic, of course, AI observability, AI infrastructure, and, of course, a talk from none other than Anthropic. So with that, please join me in welcoming our next speaker to the stage, Shirsha Chaudhry from Thomson Reuters.
Hello, good afternoon. I have before me the ominous task of making this presentation really interesting with a topic which is going to sound like a crib. What are those missing pieces for workflow automation to happen with AI? And I'm going to tell you really an enterprise story. Is it dry? Is it just going to be about, now I'm going to find out who took my lunch sandwich? We'll see. As I was preparing for this talk and I realized in the schedule that this is going to be just after lunch, I thought I should start off with a joke. And since for all our daily needs we go to AI tools, I tried to go to an AI tool for a joke. And they really suck. I couldn't find one decent joke. If you can tell me a good joke about using AI for your real-world enterprise needs, I'd be happy to squeeze it in right now. Clicker doesn't work. Can someone help me? Oh, OK. Yep. So the graph looks a little different from all the graphs that I've been seeing this morning. We took this journey in our worlds, in our enterprise worlds, as we explored. But before I dive into this, I think I should do an introduction. I'm Shirsha. I've come all the way from Bangalore to tell you the story that I see unfolding around me, not just in Thomson Reuters, where I work, trying to bring AI to my teams and different business processes, but also the same story that I hear at meetups and different community events where I meet AI practitioners. Everyone started off trying to democratize the use of generative AI back in 2023. We have something called as Open Arena in Thomson Reuters, very similar to your playground where you can try different large language models. This is where it truly came home to almost everybody in an enterprise to start using generative AI for their workflows. Further along, we got onto the RAG and prompt engineering world pretty quickly. We looked at automating various knowledge-driven tasks with the use of RAG. And very soon, we were answering questions at the enterprise level on what is the ROI. Further along, in 2024, we started to play with tools and frameworks, and we heralded the rise of the agents. We are now here where we're looking at automating entire workflows with the use of AI/agents, and not just one task at a time, right? We are looking at a future where we want to reimagine business processes because just automating a task seems redundant. OK, so what do we mean by workflow automation? And what I've got here is a very typical workflow for almost any company that's putting software out there. Customer calls your service desk, report a billing issue, an invoice issue, or a product feature not working as expected. Your customer support is going to take the call. They are probably using RAG to sort of answer that question already, Or they may be looking at, internal tickets or connecting with, their hierarchy to see if the answer can be given. And if no answers are found, they then, report a ticket to the IT ops teams, right? The internal IT ops teams do the level 2 support, and they're looking at, launching investigations to support this. Further along, if this doesn't work, you've got your engineering teams doing the L3, L4 support, and a fix is likely going to be identified with the use of various observability tools. Scripts are launched to create that new build. Tests, regression tests, integration tests are launched. And finally, you've got either the bug fixed or the billing question answered. Your tickets are updated, and SLAs met. Needless to say, all of you can spot so many of these tasks that can be automated with the use of agents. But is automating each task the way we want to do this? Is there something that can be done differently in reimagining this workflow? We are there. We're trying to reimagine this workflow. Here's a slightly different take. Let's look at a workflow where content is getting created, right? It starts off with authors or content specialists perhaps identifying an alert or a trigger that's going to launch that content workflow. You then have maybe approvals to say, yes, go ahead, do your research, find out what we want to write about this. And then you've got content getting created with research being done, and subsequently your editors and your associate editors and reviewers reviewing that content. If it's very critical content, you will probably have several rounds of this reviews, and eventually the finalized content goes to the publisher, which then, the publishing teams then launch their own formatting, styling related workflows, and eventually the content is published. Here too, you will realize that so many of these tasks can be done by AI, can be done by agents, and of course humans being in the approval flow. But here again, something seems amiss. Should we stick to the same design of the workflow? Or should we be doing this a little differently? Okay, so that's where we are. We want to be able to reimagine these workflows because it's a new world, because we have new capabilities with these technologies, and not just plug in capabilities into an existing business process, right? But we're stuck. We're stuck. We are missing certain parts of that reimagination. So what are we missing? The first thing that we're missing is connectors. I spoke to a few of the, the stalls yesterday, and a common theme was how around providing a good AI agentic solution, you always needed that layer which connected to your current IT systems, right? And connectors are a very, very much a missing part of reimagining these business processes. I also want to say that I come from a world where technology is not altogether new. We've been doing AI, we've been doing NLP for several decades as Thomson Reuters. And even in the different companies that developers come from, in the different meetups and communities that I attend, they are also supporting IT systems of some of the different technology companies of our world. Believe it or not, 71% of Fortune 500 companies still use mainframe. 68% of the world's IT production workloads still run on mainframe, right? And some of your major credit card transactions still happen on the mainframe, which means we are that distant, right? Like that technology spectrum, if you were to measure from the mainframe to an agentic workflow. How do we connect these worlds, right? And so that's one of one of our major stumbling blocks, I believe, where, how do you connect the worlds of the technology, stable technology stacks that exist with the power of AI agentic workflows. The second thing is something that I struggle with as I take new ideas to different stakeholders. And I see, several startups whom I meet on a regular basis, them struggling as well. It comes back to the question of ROI. It comes to the question of, reliability, right? How will I be sure that my agent will be able to perform? And often with stakeholders and, from a business impact standpoint, it's a 0 or 1 call, right? Am I going to continue to need to have to pay manual hours, or can I consider that not needed anymore if I'm going to pay for the agent, AI agent, right? And so reliability becomes a big factor and a stumbling block for us. The third thing that we're finding missing as practitioners is to have visionaries who are able to reimagine this world with us. It's, as a practitioner, as somebody who's deeply entrenched in AI, you can only go that far in reimagining this world. You need the subject matter experts. You need the specialists from that specific domain to sort of do this together with them to be able to reimagine your business processes. The fourth thing that we need, and I'm sure many of you will agree based on conversations that I've had, is we need a certain level of standardization, right? We need to be able to say, this is how agents will be built, this is how they are packaged, this is how they're deployed. It's too nascent yet, in a established tech ecosystem to say, we are going to replace these bits with agents. Data and systems. For an agent to truly, get its full power, we need to give it access to context. The context is today distributed across different IT systems, business systems. It is probably partially located in logs. It is probably there in chat messages or IT tickets and different different siloed systems, right? Sometimes which are spread across different parts of the organization. And so bringing them together and even identifying which of these systems will have what and how do you correlate a single transaction across these systems becomes often a stumbling part of getting the AI in. The sixth thing is one that I personally feel very strongly about is creating a collaborative UX. Agents are going to be assistants, so what is the role of the human, defining that and creating systems in which humans can support the work of the agents and vice versa is, I think, a very important part of creating those workflows. And so what makes sense from a collaborative UX is something that I'm waiting to hear from any of you fresh ideas on, right? AI governance. We saw in one of the talks about how different aspects of security testing go down into parts of your agentic workflows. And so, aspects of your AI governance, which we had established all this while around ethics and responsibility, how do you translate that into different levels of your agent architecture, right? The next thing is control. We still want to give the human control. We want to have certain steps which are deterministic and certain steps which the agent can control on its own. Or how do you balance that need for control between the agent and the human and give the human the right time to act? And finally, what is the life cycle for the agent? All of you've spoken about that exponential growth of evolution in our space. How do we bring the capability, the latest capability into what we've already got deployed and that one that's ever changing? So that's what I had to share. We are just at the start. A lot of good work from all of you. I'm waiting to bridge from the world that I'm seeing around me to the world that I come from. And so happy to have your questions and ideas, suggestions, feedback. Thank you.
Our next presenter will share strategies for turning AI agents into reliable, production-ready tools that deliver tangible business results. Please join me in welcoming to the stage the founder and CPO of Arise, Aparna Dinkaran.
Hey, hey y'all, how's it going? All right, well, can you all hear me? Cool, well, thank you so much for being here. I'm gonna start off by saying, apologize my voice a little bit, it's a little hoarse today, but you guys are gonna hang in there with me. Today, we're gonna talk about a really important topic, which is, slideshow mode, awesome. We're gonna talk about a really important topic, which is about evaluating AI agents and assistants. This will load. Just to set a little context before we jump in, a lot of you have probably heard today about different agents that are being built, how to build it, what are the cool tools out there to go build agents. And today we're gonna actually talk about when you put those agents into production, it's important to actually know how they're doing and evaluate them. It's super important to making sure that they actually work in the real world. We're probably gonna get a little technical in this talk, maybe a little bit more than some of the other talks, but hang in there. I think this is important, even at the leadership level, to understand how to make sure what you're putting out actually works in the real world. So a little bit about me. My name's Aparna. I'm one of the founders of Arise. Fun update on us, actually. Today, we announced our Series C raise. Have a lot of folks who are using us to evaluate agents. So with that, let's jump in. Okay, well, everyone here has probably talked to you about text-based agents. So you have this chatbot, whatever, it's making an action, and it's figuring out all these things to do. The cool next frontier is actually voice. AI is already taking over call centers. There are over 1 billion calls made in call centers all around the world with voice assistant, with voice APIs and the real-time voice API, if any of you guys have played around with it. We're actually already seeing these types of agents start to take over and revolutionize call centers. This is actually a real production application of a travel agent. This is the Priceline Pennybot. You can go in and actually hands-free, no text, book an entire vacation using Priceline Penny today. So we're not just talking about text-based agents anymore, we're talking about multimodal agents. And it's important to address these because the way that you evaluate these types of agents, it's not just evaluate an agent, but also if it's on voice, there's specific types of evaluations you're gonna need to do. If it's multimodal, there's additional types of evaluations you need to consider. So we're gonna break all that down and hang in there with me for a fun one today. So before I jump in and talk about how to evaluate an agent, let's talk about what are the components of an agent. You probably have heard different versions of this today, but I'll tell you the language we're gonna use. One, there's something typically called a router, which is essentially what's deciding what the next step an agent will take. There's skills, which is the actual logical chains that do the work. And then there's something that stores the memory. This is important because there might be different architectures of how you're seeing people build these agents out there. It doesn't matter if you're using LangGraph or Crew AI or Llama Index workflows. There's all sorts of agent frameworks. They all have slightly different ways of building an agent. You might not even use a framework. But what you're gonna see is these common patterns of, okay, that's a router, that's a skill, and that's a memory. And these different components are gonna have different ways of how you actually evaluate it. So let's first talk about the first one. What the heck's a router? So you can think about a router almost like the boss. It's kind of deciding, hey, well, it's very common to have e-commerce agents in, you probably are all talking to e-commerce agents today to purchase things. Amazon has one, all these e-commerce companies have one. When you type in a question, like I wanna make a return, give me an idea of what to go buy. Are there any discounts on this? That user query funnels into something called a router. And that router's goal is really to determine, do I call this skill about hitting up a customer service agent? Do I call this skill to suggest all the discounts we have or suggest products? The router is really kind of the boss deciding who do I tap on to go actually execute the ask that the user made. And the router might not always get it right, but you want it to get it right because then it goes down the pathway of a specific skill within an agent. So in this case, it will call a skill. So if I asked, hey, tell me the best, leggings to go buy. So it'll go in, it'll do a product search, and then this is actually the entire skill flow of execution that the agent needs to go through to execute whatever the user asked for. Some of these might be LLM calls, some of these might just be API calls. It just really depends on how people actually implement them. And then lastly, this is an important piece, is there's always something storing the memory, because these are usually not just single-turn conversations. They're multi-turn conversations, multi-turn interactions. And so you don't want to be talking to an agent that forgets what you previously said. So there's really memory, which is storing what it previously asked for and keeping all of this in some sort of some sort of semblance of state. So with that, we're gonna get a little fun here. I'm gonna show you an actual example of what this could all look like: a router, skills, and memory. So this is an open source project that actually looks at the inner workings of an agent. These are called traces for folks who may not be familiar. If you're in leadership, or this is really what your engineers are looking at when they're actually building and troubleshooting your agent. They're actually understanding what the heck went on under the scenes. So this is actually an example of a code-based agent. Somebody asked a question like, what trends do you see in my trace latency, aka what's making my application slow? This is the router call that we were talking about earlier, where it actually decides, well, how do I then go tackle that question? So first, you can see here there's multiple router calls. There's not just one router call. This is pretty common as your application grows. You can have multiple times where it comes back and has to decide, what do I need to go do? So the first time it calls the router, what it does is so the router then makes a tool call, which is essentially the skill that you need. The first time it actually makes a tool call to then go run a SQL query. Go collect all of my traces of my application and go run a SQL query. Then it goes back up to the router, and then it calls the second skill, which is actually the data analyzer skill, which takes all of the traces and the application data, and then it passes it to something that actually analyzes that data. So in this case, you can actually see there was a router, there was tool calls, we actually have memory that's actually storing everything that's happening under the scenes, and so really just shows all three of the different components that I actually just walked through. So now that we have an example of an agent with the router and skills and memory, let's talk about how to actually evaluate these agents. Every single step that I just walked through here actually is an area where the agent can go wrong. For routers, typically what teams end up caring about is, did it call the right skill? Because if it didn't call the right skill, user asks I asked for leggings, but then it sent me over to customer service. Or it sent me over to something about discounts and deals. So you actually want to make sure that the router within an agent is correctly doing the right skill and calling the right skill. So that's the first piece that you'll want to make sure that your teams are evaluating. So if your teams are building agents, you want to ask, well, hey, what's the ultimate control flow? What's the control flow? And do we have something like a router, and are we evaluating it to make sure that it's correctly calling the right skill between A, B, C? And is it calling the right skill with the right parameters? So not just calling product search, but actually making sure that whatever way you've designed that skill, you're actually passing in the correct things like, I want this type of material, I want this type of whatever cost range. You're actually passing in all the right parameters into what the user actually is asking for. Can I get a raise of hands? Have any of you guys heard of, did any of you guys evaluate your agents today, actually? Is that something you know your teams are doing? Okay, awesome. Are any of you guys evaluating this router level internally? Okay, awesome, wow, this is a great group, okay. This is impressive. Okay, let's next go to the next one, which is actually evaluating a skill. This is actually the part where it gets really interesting and tricky because there's many different components in a skill. There might be, in this case, I have a RAG type of skill, so I want to look at things like evaluating the actual relevance of the chunks that were pulled. I want to look at the actual correctness of the answer that was generated. But this skill itself can have many different LLM as a judge evals, or it can also have code-based evals that you might want to run to actually evaluate the skills of the agent. And then lastly, this is kind of a really important one that we're seeing teams probably have the most trouble evaluating, which is actually the path that the agent took. Because, well, ideally you want it to converge. You call the same skill hundreds of times, and it always takes about 5 steps or 6 steps to actually query what the user asked for, put in the right parameters, call X, Y, Z components of the skill, and then ultimately take the right, generate the right answer. But sometimes this can be a little longer. We've seen sometimes where the same skill, I don't know if you all have done this experiment, but you can put the same skill and build it with OpenAI, and you can also build it with Anthropic, and sometimes they have wildly different number of steps that the path actually takes. And so the goal here is how do you be succinct, and how do you also make sure there's reliability in the number of steps that your agent takes to actually consistently complete a task. So we call this convergence, but probably one of the hardest to actually evaluate. Is anyone evaluating convergence today, or at least counting the number of steps? Awesome, okay. You're awesome, dude. Cool. Well, with that, I'm gonna go maybe 2 more minutes, then I'll hop into one more demo here. So if any of you guys have watched the movie Her, this is from Her. This is where, the main character asks, like, who else are you talking to? And Samantha says something like 8,000 other people are in a conversation with me right now. And so the future of voice applications is that these are probably some of the most complex type of applications that have ever been deployed, ever been built. It's gonna require one more additional pieces to actually evaluate voice applications. And the interesting part about these is that it's not just the text that needs to be evaluated, or the transcript, but it's also the audio chunk that needs to be evaluated. In a lot of these voice assistant APIs, you have the generated transcript that happens actually after the audio chunk is really sent. And so that's a whole nother dimension around what's the user's sentiment? Is the speech to text transcription actually okay? Is the tone consistent throughout the entire conversation? And so you actually need to evaluate not just the audio piece and the flow of the conversation and everything else you're doing for all your other, other parts of your agent, but also make sure that the audio chunks are getting their own evals defined on intent or speech quality or speech to text accuracy. So this is important for voice. So with that, I'm gonna actually show you guys how we evaluate our own agent so that you can get a little bit of a example of what some agent in the wild actually does. This is our own agent. So let me actually show you what it looks like. You can actually go in our product today, and there's a little copilot. And our copilot does something similar to what other copilots do, where as people are spending time in our product, we actually help them do things like, hey, help me debug this, help me summarize this, help me look at this. Can I search with natural language? So there's kind of this copilot integrated throughout our entire product. But we're an evals company. So what do? We actually dogfood our own tool, and we decide what you're looking at here is actually the traces of our entire copilot actually in the wild. And every single step of this copilot, we actually run evaluations of. So in this case, we have an eval at the very top actually evaluating something around, was the overall response that was generated, this was actually a search question, is the overall search question actually correct or incorrect? And then we also have one around, once it actually called the search router, did it pick the right router? And then did it pass in the correct arguments into the router? And then finally, ultimately, did it complete the task or the skill correctly in the execution of this entire skill? And so evals aren't just at one layer of your entire trace. If you take anything away from this conversation, the goal here is really, how do you make sure that you have evals throughout your application so that when something goes wrong, I can debug if it actually happened at the router level, if it happened at the skill level, or if it happened somewhere else along the flow. And I think that's it from me. Any questions?
When you're testing convergence, what's the range of like inputs?
Yeah. So what teams actually end up doing is they have call it like the input into a skill. So the input into, I'm not sure, if you're building an agent, but like if there's some input into your skill, that's typically what the input would be, and then it would repeatedly call that same skill with the same input, like 1 time, 2 times, 3 times, all the way to 100 times, and then you're tracking for every single run of that skill, how many steps did it actually take? So ideally, you want to mimic it with the same input and the same skill. We do have some teams, though, where as part of testing, they'll slightly modify the input. So sometimes they'll ask the question a little bit differently, a little bit more wordy, see if that takes more steps. So you can do that as well, but it's, flavors of the same input is typically how we recommend testing for convergence. There's a lot I didn't cover here today, which is around like, for example, guardrails is a big component of, I call it slightly more proactive type of evals, because you're running evals and then you're actually making an action or blocking what the output of the agent could be because of it. If I'm honest with you though, I think that it's really mostly useful for external facing applications and high risk environments, because of course it's gonna add some sort of latency to your actual call. So you wanna be sure you need it. And sorry, I think there's a question there, yeah. Oh yeah. Yeah, okay, good point. So first she asked, both great questions. First she asked, well, how do you think about evals in the context of multimodal applications? So if you have voice, if you have video, if you have images, how do you actually think about that piece in the evaluations? Let me tackle that part first. So we do see that a lot. I think voice is probably more common than video is what we're seeing, and to be honest, image. I think there's just a lot of applications, like the call center one I was telling you about. I think enterprises have just been, like, the ability to just talk to something is a lot easier than video and image. So we've been seeing a lot more voice assistants. And then with voice, the things that they end up caring about is actually a fun story. One of our customers, the tone started out really like nice and sweet in the beginning, and then it got rough near the end. And and so that wasn't really something that they expected. They wanted the tone to be consistent throughout the entire conversation. So stuff like that is things that the speech is not going to detect. So if you're just evaluating the transcript, you're not going to detect those things that the underlying tone has changed. With image and video, what we've typically seen people do is summarize what's in the picture or summarize what's happening in the video, and then try to evaluate as a common one. And then of course, all the common like quality of image, quality of video ends up being common things that people end up evaluating. And then I think the second question you asked was like, how do people actually use, I won't talk specifically about ours, but just in general observability platforms. So people do plug in and connect their actual data, because at the end of the day, these are probably some of the most complex software that has ever been built. and they're also non-deterministic. So they do want some level of visibility into what's happening. The engineers use it for troubleshooting. We're seeing AI PMs really make a rise into really understanding the experience. So they are. If you're concerned about data security, there's a lot of ways, not just our platform, but other platforms out there too, where you can always decide to deploy it in your own VPC. So that's kind of how they address the security. Yeah, go ahead.
Great presentation. Congratulations on Series C.
Thanks, y'all.
I think I'm mostly doing text completion-based interaction with users today, so we manifest through a chatbot. I think what we struggled with, like multimodality use cases, is that the users will inject a lot more context, or
Yeah.
more both context and expectations to a very low latent interaction. So decay and the chance of completion, when you have so many more tasks, like that rate of failure is going to be a lot higher. So how do you handle situations where customers are on the phone with your agents and they bring 3 or 4 or 5 problems all at the same time?
Yeah. I'm so excited for the call center transformation that's about to happen right now. Because I think we're going to see a lot more of what you're saying. So one thing we have been seeing teams do is, I mean, it just comes down to what can you fit in the context window? And the context windows aren't big to handle a lot of back and forth, especially of the voice conversations with both the audio file as well as the transcription. What we see some teams do is that I think this is already pretty common, of like summarizing the previous historical state, the memory, and this is where that starts to get really important. They decide to then summarize the audio chunk itself so that you're not obviously passing that back and forth over the wire. And so typically, how do you keep trying to condense the historical state? And then, of course, you're kind of hoping that there's some recency, so things that were asked more recently are more important than things that were like earlier in the conversation. And so that's how we've seen a lot of people manage state overall, and just growing size of these conversations. But great question. Yeah. Thanks, everyone. I think that's time. Bye.
Would you like more time to go to more epic conferences like this one? Our next presenter is the Director of Engineering AI at Datadog, where they've built AI agents that are always ready to handle issues on your behalf. Please join me in welcoming to the stage Diamond Bishop.
Hey, I'm Diamond. I hope everyone's feeling the AGI today. I'll be sharing our AI agents at Datadog and what we've learned building the DevOps engineer who never sleeps. I came all the way from the New York Times building right across here to see all of you, so I hope it's worth it. If this works. Okay. There we go. Hey, a little about me. I've been working for my entire career, about 15 years or so in AI, trying to build more AI friends and coworkers. I wouldn't read too much into that. I have human ones too, I promise. Throughout the kind of AI winters and lulls of the last 15 years or so, I've managed to keep doing just that at Microsoft, Cortana, building out Alexa at Amazon, working on PyTorch at Meta, and building my own AI startup that was working on a DevOps assistant. Now at Datadog, we're building out Bits AI, which is the AI assistant who's there to help all of you with your DevOps problems. So today I'll talk a little about that, talk a little about the history of AI at Datadog, a little bit about how we think about AI agents today, and where we think things are going for the future. Datadog is the observability and security platform for cloud applications. There's a lot that we do, but it kind of all boils down to being able to observe what's happening in your system and take action on that. Make it easier to understand, make it easier for us to simply understand and build out things to have a safer and more DevOps-friendly system. We've been shipping AI for quite a while, actually. It's not always in your face. It's not always out there saying, here's a big AI product. But things like proactive alerting, really understanding things like root cause analysis, impact analysis, and change tracking, and much more has been happening since 2015 or so. But things are changing. This is a clear era shift. I think of this kind of similar terms to the microprocessor or the shift to SaaS. Bigger, smarter models, reasoning and multimodal coming, foundation model wars happening, this general shift where intelligence becomes too cheap to meter. And what this means is products like Cursor are growing terribly fast, and really people are expecting more and more from AI every day. With these advancements at Datadog, we're really trying to rise to meet this shift as well. The future's uncertain. This kind of ambiguity creates opportunity, but there's a lot of potential. For us, that's kind of the dawning of this intelligence age. We're working to move up the stack to leverage these advancements and give even more to our customers by making it so that you don't use Datadog as just the DevOps platform, but also as AI agents that use that platform for you. This requires work in a few key areas that I'll talk about. Developing the actual agents, doing eval. You just heard a lot about eval. We think about that every day, for better or worse, and building out new types of observability. There's a few agents that we're working on right now in private beta. The first is the AI software engineer. This kind of looks at problems for you, looks at errors, tries to recommend code that we can generate to help you improve your system. The second is the AI on-call engineer. This wakes up for you in the middle of the night, does your work, hopefully makes it so you have to get paged less frequently. And then we have a lot more on the way. So I'm going to talk a little bit about the AI on-call engineer first. This is the one that everyone wants to save them from that 2 a.m. alert. You don't want to have to wake up in the middle of the night, go and look through your run book, go and figure out what's going on if you can help it. Our on-call engineer is there to really make it so you can keep sleeping. This agent proactively kicks off when an alert occurs and works to first situationally orient, read things like your run books, grab context of the alert, and then goes and figures out the kind of common stuff that each of you would do on Datadog already. Look through logs, look through metrics, look through traces, and kind of act in this loop to figure out what's going on. The on-call agent's great for both automatically running investigations for me, but also being able to look through and find summaries and find information for me before I even get to my computer. So if I want to get insights into why an alert just occurred, or figure out why a trace might be showing an error, this agent can jump ahead, pull information for me, and show it to me. We also have added a new page that makes it easy so that you can have human-AI collaboration. This is still something I'm thinking about a lot, is like, what kind of collaboration do we expect? We want our agents to act as humans, but we also need to be able to verify what they did and be able to kind of look over what they're doing and really learn from it. It also helps you to kind of earn trust along the way. I can see the reason why this hypothesis, for example, was generated. I can see what the agent found, and I can make decisions about whether or not I agree along the way. It also tells you things like, what steps did it actually take out of your runbook? And kind of like a junior engineer who does this work, I can go ask follow-up questions, find out why it did a certain thing. A little more insight into how we're making this happen. Much like a human SRE or DevOps engineer, our agent works to put together hypotheses on what might be happening and reason over them, coming up with ways to test them, use tools in the tool-former sense, to try out ideas, run queries against logs, metrics, et cetera, and work to validate or invalidate each hypothesis. In the case that it does find a solid root cause, our agent can suggest remediations along the way. Again, just like a human might say, hey, we should page in that other team that's involved here. Or it might offer to scale up or down your infrastructure. Over time, we plan to add more built-in actions and eventually discover new types of workflows based on what your team has done. But if you already have certain workflows that you've set up in Datadog, we can tie directly into them and make it so that our agent can understand those workflows and how they might map to helping you remediate a problem. And if it's a real incident, the on-call engineer is not usually done once an issue is remediated. You usually go and write a postmortem, you go try to learn from it, you share it with your team. Our agent can do the same, write out your postmortem for you, look at what occurred during the entire time, what it did, what humans did, and put that together so that you have something ready in the morning. So that was the on-call engineer. That's the one that is trying to help you in the middle of the night, trying to help you every time alerts come on. We also have this AI software engineer. I think of this as the proactive developer, the DevOps or software engineering agent who observes and acts on things like errors coming through. This is kind of the error tracking assistant. It automatically analyzes these errors, identifies causes, and proposes solutions. Those solutions can include generating a code fix and working to reduce the number of on-call incidents you have in the first place. So they can work in concert to make a better system over time. In this case, the assistant has caught a recursion issue, proposes a fix, and even creates a recursion test so that we can catch it if it happens again in the future. We have the option to create a PR in GitHub or open the diff in VS Code for editing. This workflow significantly reduces the time spent by an engineer manually writing and testing code and greatly reduces human time spent overall. So what have we learned building out these agents and some of the new ones that we're working on today? Well, we've learned quite a lot. There's a lot of things that we started with that we kind of went back and redid. But a few areas I'll touch on that I hope help you as you develop your own. First is scoping tasks for evaluation. It's very easy to build out demos quickly, much harder sometimes to scope and eval what's occurring. Second is building the right team who's ready to move fast and deal with the ambiguity that comes with these kind of problems. Third is that the UX of old is changing. That's something that everyone needs to be comfortable with. And fourth is observability matters. I'm surprising for Datadog to say that, I'm sure, but observability is terribly important even in this new era. So scoping the problems, scoping the work to be done. I like to think about this as defining jobs to be done and really kind of trying to clearly understand step by step what you'd like to do. Think about it from the human angle first and think about how another human might go and evaluate it. This is why we build out vertical task-specific agents rather than building out generalized agents. We also want, where possible, this to be measurable and verifiable and at each step. This has honestly been one of the biggest pain points for us, and I think this is true for many people working in agents, where you can quickly build out a demo, you can quickly build something that looks like it works, but then it's very hard to actually verify that over time and improve it. Use your domain experts, but use them more like design partners or task verifiers. Don't use them as the people who will go and kind of write the code or rules for it, because there is a big difference in how these kind of stochastic models work versus how experts work. Everyone kind of knows Gnome and his anti-NLP rants, but that kind of stuff happens pretty frequently at domain experts. Eval, eval, eval. I can't stress this enough. Start by thinking deeply about your eval. The number of mistakes we made by not thinking about eval first is frustrating and something that I think everyone should think about. It's very easy to build these demos, as I said, but everything in this fuzzy stochastic world requires good eval, even something small to start. This means offline, online, and kind of living eval. Have end-to-end tasks, have end-to-end measurements. Make it so you also instrument appropriately the way to know if humans are using your product right and giving you feedback, and then make this a living, breathing test set. Building the team. You don't have to have a bunch of ML experts. There aren't that many to go around right now. What you really need is you want to seed it with one or two, and then have a bunch of optimistic generalists who are very good at writing code and very willing to try things out fast. I'll also note that UX and front-end matters more than I'd like as a back-end engineer myself, but it's terribly important as you collaborate with these agents and assistants. And then you want teammates and people who are excited to be AI augmented themselves. This is day-to-day AI use. This is explorer types who want to learn. This is a field that's changing fast. And if you don't have people like that, you're going to kind of get stuck. You want folks who kind of, yearn for the vast and endless AI capabilities, right? It's a big world out there, and there's a lot going on. Ye old UX. This is one of those things that I still, we think about, we go back and forth every day. It's an area that I didn't realize was quite so important initially when I started working in this field. Despite my engineering sensibilities and lack of UX, it's terribly important. This is such an early space of work. This is kind of one of the more important things here as you collaborate and work together. But the old UX patterns are changing. Be comfortable with that. And so far, I'm partial to agents that work more and more like human teammates instead of building out a bunch of new pages or buttons. So who watches the Watchmen, right? You have these agents running around. Observability is actually really important, and don't make it an afterthought. These are complex workflows. You really need situational awareness to debug problems. And this has saved us time a lot as we start to work with a new view that we're calling LLM observability in the Datadog product. Datadog in general has a full observability stack, as many of you know. We can look at GPUs, we can look at LLM monitoring, we can look at really your system end to end. But tying in the LLM observability has been very helpful because you have a wide variety of interactions and calls out to models you're hosting, models you're running, maybe models you're using through an API, and we can make them all kind of grouped together in the same pane of glass so you can look at them and debug what's occurring. I will note, though, that this can get messy fast with agents. Our agent, for example, has very complex multi-step calls. You're not going to look at this and figure out what's going on right away. This can be hundreds of calls. This can be tons of different places where it's making decisions about tools, looping time and time again. And if you just look through a full list of these things, you'll never really figure out what's going on. So here's a quick sneak peek into a more agent view of what's occurring inside of our observability tools. This is our agent graph. Really what this means is that I can kind of look at it just like our agent did and looking at workflows that are occurring. You can see in this, even though it's a big graph, there's a bright red node here. If we zoom into that, we can actually see where errors were occurring. This is very human readable, something that makes it super easy to figure out what's going on when your complex workflow is running. As an aside, though, I do also want to note what I think of as kind of like the agent or application layer bitter lesson. General methods that can leverage new off-the-shelf models are ultimately the most effective, by a large margin. I hate to say it, but like you sit there, you fine-tune, you do all this work on like the specific project, the specific task, and then all of a sudden, OpenAI or someone comes out with a new model, and it handles all this, kind of quickly. A lot of the reasoning is solved for you. We're not quite there where it handles all of it very quickly, but you should be at a point where you can easily try out any of these models and don't feel stuck to a particular model that you've been working on for a while. A rising tide lifts all boats here. I also think a lot about not just building agents, but what it might mean for other agents to be users of Datadog and other SaaS products. There's a good chance that agents surpass humans as users in the next 5 years. I'm probably somewhere in the middle on my estimate there. There are people who will tell you that'll happen in the next year. There are people who will tell you, it'll happen in 10 years. I think we're somewhere around the 5-year mark. But this means that you shouldn't just be building for humans or building your own agents. You should really think about agents that might use your product as well. An example of this is like third-party agents like Claude might use Datadog directly. I set this up with MCP relatively quickly. But any type of agent that might be coming in and using your platform, you should think of the context you want to provide them, the information you want to provide about your APIs that agents would use more than humans. So looking ahead, the future is going to be weird. It'll be fun. And AI is accelerating each and every day. I strongly believe that we'll be able to offer a team of DevSecOps agents for hire to each of you soon. You don't have to go and use our platform directly and integrate directly. Ideally, our agents will do that for you, and our agents will handle your on-call and everything like that for you. I also do think that AI agents will be customers. Many of you building out SRE agents and other types of agents, coding agents, should use our platform, should use our tools, just like a human would, and we can't wait to see that. And generally, I think that small companies out there are going to be built by someone who can use automated developers like Cursor or Devin to get their ideas out into the real world, and then agents like ours to handle operations and security in a way that lets, an order of magnitude more ideas make it out into the real world. Thank you so much. Please reach out if you're building any agents that want to use us, or if you'd like to check out our agents as well. There's a lot to build here. And if you want to work in the space, we are hiring more AI engineers and people who are just excited about it. But thank you very much.
Our next presentation is about building self-managed AI networks. Please join me in welcoming to the stage Technical Lead for Arista Networks, Paul Gilbert.
Whoops, how do I go back? There you go. Yep, so my name is Paul Gilbert. I'm a tech lead for Arista Networks. I have an accent, but I'm actually based here in New York City. And I build or design, or I help build and design enterprise networks. But what we do is the plumbing. So I'm not going to talk about agents, but more kind of how you train models, what the infrastructure looks like, and how you do inferencing on the infrastructure. I normally teach people the very basic stuff, so you guys probably know this already, but these are new terms for us when we built computer networks. People will come to us and say job completion time, barrier, I'm pretty sure you guys know that, the inference. And the question I get all the time is, we can build a network to train a model. There's an algorithm maybe you can use to look at what you need. But then, what's inference? And, it's changed a lot now because of chain of thought and reasoning models. The inference is a lot different. It used to be X, but now it's Y. I'm pretty sure you guys have seen this slide, but I use these just to talk to enterprises around kind of what they might be thinking in GPU size. Walid Sosa came up, Dr. Walid Sosa came up with this. On the left there is the training, and on the right there is the inference. And it's kind of, on one you have times 18 times, the other times 2. Again, I think that changes now with chain of thought and reasoning. I'm not too sure kind of which way it's going to go. And at the bottom there was a really interesting one, again, which I show customers, because most of the enterprises I talk to kind of don't understand models and how they work and training. I know a little, but not a lot. But the model they trained down here was 2,048 GPUs for 1 to 2 months. And then when you go to inference after fine-tuning and alignment, it's 4 H100s for inference. So we talk to people about building different types of networks, which I'll speak about. But I always start at the beginning. And I got this slide, and I think it's really interesting. LLMs were kind of just trying a little bit of inference, but now with the next generation models, it's a lot. So this is what we build, or I build. And these are new terminologies for us from the networking world, back-end network. So this is where you connect GPUs to. When we build these networks, they're completely isolated because GPUs are really, really expensive. They take a lot of power, and they're really hard to get hold of. So when people build AI networks in the enterprise, we don't connect nothing else to these networks. The bottom part of that, the back-end network, there's 8 GPUs per pool on those servers. And they can be NVIDIA, they can be Supermicro, they can be whatever. They will go into a high-speed switch at the bottom there. You have a leaf switch and a spine switch, and nothing else attaches to that network. And then on the front-end network is where you get storage from to train the model. Obviously, the GPUs synchronize, they do something, they calculate, they produce an algorithm, and they call for more data, and that's kind of the cycle. The front-end network is not as intense as the back-end. The back-end network, depending on the model that you train, the GPUs will actually work at 400 gigabytes. And for us in the enterprise, and I've built some big data centers, but I've never seen anything like that. So this is, in the networking world, this is a completely new world to us. And we make the networks as simple as possible because, again, these are really expensive and people want to get their money's worth. They want these running 24/7. So we do IBGP or EBGP, just a really simple protocols. I'm sure most of you have seen this, but again, I kind of teach this. So this was an infrastructure presentation, but that's kind of the back of a H100, probably the most popular. It is actually the most popular AI server out there right now. You can see in the middle there's 4 ports, but those 4 ports are broken out into 2, so there's 8 ports. Those are the GPU ports there. And then kind of over to the left there's the Ethernet ports. So that's what we connect to. We've never seen anything like this before. When you first speak to people about this, I've seen servers with 400 gig, and I do a lot of the big financial networks, but never before have we seen servers that can put this type of traffic onto a network. They always ask me about this, and I got this from an NVIDIA slide. It's down there, but there's this thing called scale up and scale out. I'm not really sure. Scale up, when my customers buy these servers, they always have 8 GPUs in it. You can't add anything to an NVIDIA server. You get the DGX. If you go with the outsourced model, it's a HGX, so it's a third party. You don't really add things to it. But so I don't see scale up, but scale out, obviously you can build, we build the network so that you can add more GPUs. We can start very small and we can go up to hundreds of thousands of GPUs, not in the enterprise, but the cloud scale guys do. So what's different? For us, again, it's hardware and software. The hardware are those GPUs. We're not used to them. The first time I tried to configure one, it took me hours and hours, but I'd never seen them before, whereas other stuff I've seen pretty quickly. And you have software, so CUDA and Nickel are probably, two of the biggest protocols, and you guys know more about that than me. But we had to kind of understand, not CUDA, but Nickel, because it has a collective, so we had to understand kind of how the collective works, because that will put traffic onto the network in a certain way. The hardware was completely different. Again, we had the 8 400 gig ports and the 4 400 gig ports facing the front end network. Totally new to us. The other thing was data center applications, kind of web app database. They're really easy. They go from one to the other and in different parts of the network. And if one fails, you have some kind of load balancing or fail and it fails over. AI networks are not like that. The GPUs all speak. They'll talk to each other. They'll get stuff. They'll send stuff. And if one fails, the job might fail. It might recover. But it's a different concept to us. So it's hard to imagine. And traffic is bursty because all of these GPUs, if you have 1,000 GPUs at 400 gig, they will all burst at the same time. And if they can, they will burst at 400 gig. So there's a lot of traffic on a network. And I've never seen anything like that. So when we build these networks, we don't build them oversubscribed. We build them 1-to-1. In the data center world, we used to do 1 to 10. It went down to probably 1 to 3, but never 1-to-1 because it's just really expensive to build that kind of bandwidth. But with AI networks, we need to. So we have no oversubscription in the network. And from our point of view, if you look at what one of these servers can put on the network, just a H100 is 8 400 gig GPUs, and 4 400 gig is 4.8 terabytes, and that's just one server. The storage size, the front end, probably nowhere near that, but the back end is always wire rate. And then 800 gig is probably, the Bs are just around the corner. I think in March they'll be released. I think there's some people that have them. And those are 800 gig. We support 800 gig today on the network, but each one of those servers is a possible 9.6 terabytes per server. And most people in my world, in the enterprise world, come from servers that maybe 1, 2, 3, or 4, 100 gig Ethernet, but nothing like 9.6 terabytes per server. So the other problem we have is the traffic patterns. When we load balance from kind of leaf to spine, we use a thing called entropy, which is the 5-tuple IP address, port, and MAC address, and we do pretty good load balancing. But with GPUs, it's just one IP address, and it can sometimes match to a single uplink and oversubscribe it, which would be really bad because you'll start dropping an awful lot of packets. So we have to take a lot of care on how we load balance within the AI network or how we build the back end and the front end. So we have some pretty cool tools where we don't now look at the 5 tuples. We actually load balance on the percent of bandwidth that's being used on the uplink. And we can get up to about 93% utilization on all the uplinks to the downlinks, which is pretty good. And again, one thing that's really new to us is a single GPU or a set of GPUs, if they fail, sometimes the model will stop. I know it checkpoints, but a single GPU failure is a problem for us. And one of the big problems that we've always had is optics and transceivers and DOMs, which is the rates and the loss between them and the cables, et cetera. And when you start building these networks with thousands of GPUs, you will have a lot of cable problems and you will have a lot of GPU problems. So it's really hard for us because again, this world is new to us for the last year or so. Power, power is, you've read the newspapers, everyone's trying to buy nuclear power stations to power these things. The average rack in a data center today is about 7 kW to 15 kW, and you can put like 10 one IU racks into those and you'll be fine. And when customers come to me say, yeah, we finally got GPUs, whatever, and I say to them, what kind of racks have you got? And they say, well, we're going to put them in, and then you can only put one of these servers in one of those racks because they actually draw with 8 GPUs, 10.2 kW. So you need new racks. Most enterprises now are waking up to this, and they're building racks between 100 and 200 kW, and they're water cooled. There's no way you could air cool them in a data center. So that's a whole new concept to people as well, is water cooled racks. Traffic is both ways, which again is new to us. So north-south, in a regular data center, you have users coming in, database app, web, whatever, and it comes in, it goes out. But in the AI world, when the GPUs speak, that traffic is east-west because it's speaking amongst each other. And then when they ask for more data from the storage network, it's north-south. So you have both traffic patterns. The east-west is really bad. That's kind of where they run wire rate. The front end to the storage is much more calmer because most storage vendors can't put that kind of traffic on the network right now. I'm pretty sure they will one day, but they're more around 100, 200 gig. And in a network, there's a certain amount of buffering on these switches, and buffering is bad because it means it can't send traffic somewhere because something else is not receiving the traffic. So you need a congestion control and feedback. And right now we use something called Rocky V2, which is 2 parts of Rocky V2. There's a PFC and an ECN. If you were building an AI network, your network engineers will definitely know about this. ECN is an end-to-end flow control, where if there's congestion somewhere in the network, packets are marked, they go to the receiver sends back to the sender, you need to slow down because there's congestion. And it goes through an algorithm, it pauses for a while, it slows down. And if it doesn't get any more ECN packets, it speeds up again. And PFC is basically stop. My buffers are full, I can't take any more, so it kind of is a dead stop. So you have kind of a slow feedback mechanism with ECN and a kind of an emergency stop with PFC. The networks we build are really simple. We don't have things like, in regular data centers, we have DMZs with firewalls, load balancers, etc. We have connections to the internet. We have L4 through 7 service, a whole bunch of stuff. When we build these networks, they're totally isolated. The GPU, the back end is completely isolated. The front end possibly could have connections to something, but even then, it's so expensive to build, you don't want to take the chance. On demand, the applications that we're used to, if it fails or something fails, something will recover, and you may get a little skip or a jump, but if you've done the right thing, it's not going to be that bad. In this world, if something fails, the model may fail, and the call that you get into the operations center is different call than you get that if you're at kind of restarted and everything's good again. The other thing is collectives. Obviously Nickel will go out there and work out kind of where the GPUs are and what to do with it. But there's kind of different designs. So I tell my customers that speak to your data scientists and your programmers, developers, and find out kind of what they're doing and what kind of models they're building, because it can affect the network on kind of how you build it and how you design it. So networks totally isolated. Things are moving fast. We're at 800 gig right now, which is, we have been for probably a year. We will see 1.6 terabytes on the network probably end of this year, early 2027. And it will just keep growing and growing and growing. And these models will get bigger and bigger and consume more and more and more, I'm pretty sure. Visibility and telemetry. All my customers, the call that they get when a model fails because the network is a problem is a different call than they're used to. So we put different telemetry and visibility in there to make sure that if things are going wrong on the network, that they know about it, hopefully before they get that call. So I work for Arista. Our operating system is called EOS, and we have a whole bunch of features there. So if you were building an AI network, I'm not sure that you guys speak to the engineers, but This is the type of things we talk about. Lossless Ethernet, everyone thinks that when you train the model, you can't drop packets. I've seen it, and you can. I think drop packets are okay. Consistent latency is okay, but if you drop so many packets, obviously it's a problem. So flow control, lossless Ethernet is really key. ECN and PFC are part of that. As I said before, they're flow control mechanisms. One is a slow down, please, and the other one is a stop. And as you know, because GPUs are synchronized, if something slows down, you slow down one port, one GPU, everything slows down. So you really got to be on top of kind of the oversubscription. And if you are getting queuing, where is it? We have really good buffer. We can adjust buffers. We have different kinds of switches for different places in the network. But we've found that models send and receive a particular size packet. And what we do is we adjust those buffers to accept those types of packets. Buffering is a really expensive commodity in switches in networking. And if you can find a way to allocate the buffers exactly tuned to the packet sizes, it's a win-win. And we've worked out how to do that, which is good. Monitoring is really key for us. I tell my customers there's probably 5 things you want to do. One of them is RDMA. These networks train using RDMA, which is memory to memory writes rather than going CPU to memory. And RDMA is a complex protocol, and it has 10 or 12, maybe more, kind of error codes. So if the network starts seeing problems and starts dropping packets, rather than just drop the packet on the floor, we can actually copy that packet to a buffer or send it somewhere, or just the headers and why we dropped that packet. And if you think about it, it's really cool. Like most networks will, in congestion, your buffer fills up, you're going to drop the packets. We'll drop the packet, but we'll actually take a snapshot of the packet and the headers and the RMA information in it, and we'll tell you why we dropped it. Another thing we have, which is really good, we have an AI agent. From the networking point of view, we can look at what's going on, but we don't really have any visibility into the GPU. So now we have an agent, which is an API and some code that we load on the GPUs in NVIDIA, and they will speak to the switch. So that agent will say to the switch, how are you configured? So PFC and ECN, those flow control mechanisms, have to be configured correctly, because if they're not, it will be a disaster. So the GPU will speak to the switch and say, this is how I'm configured. The switch will say, yeah, you're good. We understand each other. And the second thing it does, it gives you a whole bunch of statistics about packets received, packets sent, RDMA errors, RDMA issues in there. So you can correlate now if the problem is the GPU or if it's the network, which is a huge step forward for us. Another really cool feature we have is smart system upgrade. If you're used to routers and switches, you have to upgrade the software sometimes to get new features, sometimes to fix PCerts, which are security vulnerabilities on that switch. We've worked out a way now that we can do that. You can upgrade code without actually taking the switch offline. So, if you have 1,024 GPUs with 64 switches in your network, you actually can upgrade those and the GPUs can keep working. So it's a real big step forward for us. So, for us, again, I don't know but no oversubscription on the back end. You can't, because the GPUs use everything you give them. Address-wise is really important for us. It's a point-to-point connection, so it's /30/31s. You could use IPv6 if you have IPv4 problems, address space problems. All my customers, I tell BGP because it's the best protocol out there. It's really simple and it's really quick. EVPN, VXLAN, if you have multi-tenancy, if you have a lot of different business units, lines of business using the network. You need things like advanced load balancing. We have a couple of different, we actually look at the collective that you're running, load balance on that collective now, which we call cluster load balancing. You could deploy it Rocky. I tell all my customers, do it, because if you don't, your network's going to melt down. You're not going to know why. These things will give you an early warning system that you need to do something with your network. So they're really key to have. And visibility and telemetry is really good at all times, because in the network NOC or the operations center, you always want to be aware of the problem before you get the call from the developers and the people that have paid a lot of money for that network. I'm running out of time here, but this is kind of a 1,400 gig cluster, what it would look like spine and leaf. Again, no oversubscription, 800 gig links between the leaf and spine, 400 gig down to the GPUs. This is a 4,000 cluster. These ones, these are the bigger boxes. These are 16 slot. One of these boxes can take 576 800 gig GPUs, so 1,152 400 gig GPUs. So if you're building clusters with thousands of GPUs, then this would be the box for you, the 7800 series. And putting it all together, this is kind of what we would build. There's 3 networks here. There's a back-end network where your GPUs live. There's a front-end network where the storage live. And then there's the inference that you take the model, you put it somewhere else. And I'm out of time. I did not come in, so I guess I'm not. So the other thing is, there's Ultra Ethernet Consortium. I don't know if it's of interest to you. Ethernet hasn't changed the way it's built, probably 30 years. There's some things it could do better around congestion control, around packet spraying, around the NICs talking to each other. So there's this thing called Ultra Ethernet Consortium. Version 1.0 will be ratified probably Q1 2025. And it's a kind of different way of building networks, and you probably won't see them till Q3, Q4. But most of the cloud scale guys were kind of really keen on this because it puts a lot more into the NICs and takes a lot more out of the network. So we can do what we're good at, which is forwarding packets. So summary, for us, we have the front end, which is storage, the back end, which is the really important part for us. That part is really bursty. The GPUs are all synced, so they send and receive at the same time. And if you have a slow GPU, that's a barrier because it stops everyone else. Job completion time is what matters to us. If we get the call that my job completion time was 1 hour yesterday, it's 4 days today, it's probably our problem. Models can checkpoint, but they're really expensive. You guys know that. And I'm done, and they're still not coming. Yeah, anyone got any questions? I take a question if you want, if they're not coming.
Our final presentation for this block is Anthropic for VPs of AI. Please join me in welcoming to the stage Alexander Bricken, member of technical staff at Anthropic, and Joe Bailey, GTM Enterprise at Anthropic.
Here we are.
Brighter than I expected.
Yeah,
good to see you all today. I'm Alexander Bricken. I'm on the Applied AI team at Anthropic, so I work very closely with customers to do technical implementation work, and I also bring that advice back to product research and model research. I'm going to pass it over to Joe.
Hey everyone, it's great to be here. My name is Joe Bailey. I work on the go-to-market team at Anthropic. I joined Anthropic over a year ago now, so I've seen our models evolve from 2.1 to today's capabilities. And I think day-to-day what's really exciting is we're working with AI leaders who are solving real business problems that just seemed impossible a year ago. So really excited about how quickly everything is moving. Okay, for today, we will do a quick overview, who we are, our mission, and then we'll focus a lot on implementing AI and best practices and common mistakes. Alex and I actually didn't just take this from our own experience, but we talked to a number of our colleagues, so this is all based on hundreds and hundreds of customer interactions. So we hope there's some actionable insights to take out of this. Awesome. So what is Anthropic? So we are an AI safety and research company building the world's best and safest large language models. We were founded a few years ago by some of the leading experts in AI. And since our inception, we've not only released multiple iterations of our frontier models, we've done so by being at the bleeding edge of safety techniques, of research and policy. I'm going to pass it over to Alex to talk a little bit about our marquee model.
Awesome. And so some of you are probably familiar, but the most recent model we launched was Sonnet 3.5 New in late October of last year. You might be familiar with it because if you're a developer, Sonnet is actually one of the leading models in the code space. So if you're familiar with evaluations like SweBench, which is an agentic coding eval, Sonnet is still at the top of the leaderboard for that. I won't go too much into the details on the eval side, so let's keep moving.
So yeah, in addition to what Joe mentioned, we have a lot of different research directions that we're focused on. And these are really distributed, but have overlap between model capabilities, product research, and AI safety. The one that differentiates us, I would say, is the interpretability. And this realistically is reverse engineering the models and trying to figure out actually how they're thinking and maybe why they're thinking, and then an additional capability in terms of steering them in the right direction, depending on a use case. So let's dive into that a little bit more. We're still very early in interpretability research. It's worth mentioning. As you can see, there's kind of like a longer timeline, and we're really only at the first half of that, maybe even the first 25%. But we're really approaching it in these stages that build upon each other. So these include things like understanding, so grasping AI decision-making, detection, so actually being able to understand specific behaviors and put labels on those, steering, so influencing the AI input in some way, shape, or form, and I'll get to an example of that in a second, and then finally explainability, and that's really where you unlock business value associated with interpretability methods. And so while we see interpretability in the long term providing a lot of significant improvements in AI safety, reliability, and usability, specifically our interpretability team uses methods to understand feature activations at the model level, and then has published research on these towards model semanticity and scaling model semanticity, which are 2 papers I highly recommend. And then as the technology improves into kind of detection landscapes, for example, you can imagine having a much better grasp at the actual thinking and behavior of the model, or even discovering sleeper agents for safety reasons that might be buried deep within model capabilities. So a good example of that is imagine you ask the model what were the scores of the NBA matches today, right? And let's say it knows the answer, and it says, oh, Steph Curry scored 30 points. This would lead to a feature activation of, for example, feature number 304, famous NBA players. Realistically, that's a group of neurons activating in a recognizable pattern that we've identified across all mentions of famous basketball players when the model is answering a question, not just Steph Curry. And you also might have heard of Golden Gate Claude. That was an example of us steering the model, basically amping up the activation in the Golden Gate direction. And thus, whenever you'd ask a question like, what should I paint my bedroom? Claude would respond, oh, you should paint it red like the Golden Gate Bridge, and maybe it should have some pillars in it or something. I'm going to pass over to Joe to talk a little bit about some of the customers we work with.
Yeah, so I'm going to frame this in 2 ways. One is sort of early on discussions, and the other would be just examples of customers that are doing really cool things. So in conversations, there's obviously a lot of noise and buzz and everything, and that's fantastic, but we often encourage our customers to sort of get back to the basics and how can they use AI to solve the core problem that your product is trying to solve. We also get to work with a ton of sort of AI native or AI startups, and this is how they're thinking about their product. And I think you want to move beyond chatbots and summarization. These can be great options, but I'd be thinking more like, where do you want to place bigger bets? And to give an example, if you just click one more time, fancy slide. Imagine you're an onboarding and upskilling platform. The problem that you solve for customers is you help them get ramped really quickly, and then you help them get to the next phase of their career by equipping them with skills. So for instance, you might be public speaking you want to get good at, or you might want to become a manager. And so it would be easy to say, okay, let's summarize course content, or let's have a Q&A chatbot that answers questions along the way, and they could be helpful, but I would actually think about it differently. So what about if you could hyper-personalize course content based on each individual employee's context? Or if someone is like breezing through all the course content, could you adapt it dynamically to make it more challenging so they're actually getting more value out of it? And then the last one that I particularly like would be, what if you could dynamically update course material based on people learning about the customer? So if someone was a visual learner, great, let's make visual content for them. And having the AI, having the ML, the large language model, just do that automatically. And you have to think, does that solve the problem more than summarization or a Q&A chatbot? So really good food for thought. And to sort of talk about some of the customers that we see achieving really industry-leading results by combining their own domain expertise and our models. So I won't read off each, but just a couple of call-outs. One is AI impacting different industries. We have taxes, we have legal, we have project management. they're using AI to drastically enhance their customer experience. They make it more easier to use. They make it more trustworthy. And so it's really improving the experience versus just being like a nice to have. And then they're achieving a real high quality of output, right? You can't be hallucinating when you're doing your taxes. It could just, that could lead to all sorts of things. So we're thrilled that they're seeing these sort of like business critical workflows powered by AI, driving really positive outcomes for them and also their customers.
Awesome.
So I can do this one. Yeah. So getting started, I just quickly, there's two key points here. So if you go to the next slide, what are our products? We have our API, we have Claude for Work. Our API is for businesses that want to embed AI in their product and services, and then Claude for Work empowers your entire organization to take advantage of AI in their day-to-day work. We also have, next one, we also have a partnership with AWS and GCP. And you can kind of get the best of both worlds here. You can access our frontier models on Bedrock or on Vertex. You can deploy these applications in your existing environment. And so you don't have to manage any new infrastructure. So it really sort of breaks down like any barriers to entry. So you're getting the best of both worlds here. We talk a little bit about support throughout this talk. To us, it doesn't matter if you're accessing us through a third party or our first party. So I just wanted to call that out.
Awesome. So now that we've talked a little bit about some of the customers, how do we actually set customers up for success when working with them at Anthropic? So just a preface on kind of what my team does. As I mentioned, it's at this intersection of product research, customer-facing interaction, and then also just actual research within the org. And we support the technical aspects of the use cases, so helping to design architectures, evals, tweak Claude prompts to get the best out of our models, et cetera. And then we also bring whatever we see back into Anthropic, and we try to build some of the best products we can for our customers. So some examples of projects we worked on or things that we published include the Building Effective research paper that my colleague Barry published. He's going to be speaking tomorrow. And then as well as that, we launched Model Context Protocol, which is an open source protocol for language models to interact with data sources. And Mahesh is going to be leading a workshop on that on Saturday, I believe. So Anthropic as a whole, we try to effectively support our customers, but where we really start to embed, at least my team in particular, is we work closely with customers that are using Claude a lot, and they're facing really niche challenges in specific use case domains, and they need support from our team to try to apply some of the newest, kind of latest and greatest research or get the most out of the models from a prompting standpoint, et cetera. And so this approach is pretty additive. We often kick off a sprint once the customer is facing those tricky challenges. And that could be LLM ops, architectures, or evals. We help them define certain metrics that they deem to be important when they're evaluating the model against the use case. And then finally, we help them deploy that kind of iterative loop, the results of that, into an A/B test environment, and then hopefully into production. And so a part of that is the importance of evals, and I'll get onto that in a second. But I'm going to pass it over first to Joe to talk about some stuff that we did for Intercom.
Yeah, so I think this is a good segue in what Alex was describing. So for those of you who don't know, Intercom is an AI customer service platform. They have an AI agent called Finn. By many measures, it's the best in the market, and it's a pretty competitive market. So they had their product out for, I think, about a year or so. And when we spoke to them, they shared where they wanted to go, where they saw the futures of like customer support and agents. And based on some of the capabilities of our model, we felt that we could have a pretty good impact on these metrics. And so what we started with was the Applied AI lead met with their data science team, and we ran a quick 2-week sprint. We took their hardest prompt for Finn, and we compared it against a prompt that we helped them sort of figure out with Claude. And they saw really good results after the first 2 weeks. So much so we went on this sort of sprint of about 2 months where we were basically fine-tuning and optimizing all of their prompts to get the best performance out of Claude. At the end of this, they're able to look at all their benchmarks and see that Anthropic was outperforming the current LLM. It's also worth noting that they do a resolution-based pricing model. So there's an incentive for everyone for the model to be really helpful and help customers solve problems and not be like a deflection machine where it's like, we've probably all experienced them before. And so at the end of this 2 months, they decided to move forward with Anthropic. They launched it. You can read about it. It's called Finn 2. And I think just some of the metrics are really like mind-blowing, like can solve up to 86% of customer support volume, 51% out of the box. Our support team thought about lots of different options, and they actually adopted Fin as well, and they saw very similar resolution rates, but also making it more human. So I think with our model, there's a much more of a human element to it, so they could do like adjustment of the tone, answer length, and then it was also really good at doing policy awareness, so like refund policy, for instance. So unlocking some new capabilities. And we're thrilled to be partnering with them as they sort of, I think, march forward as a leader in this space.
Yeah, on a kind of separate note, one of the things I've seen recently is Claude on Twitter acting as some sort of therapist for a lot of people, and I always find that an entertaining example of like its character being expressed.
Yeah.
Cool, so let's get on to some best practices and mistakes that we see in the field on the go-to-market team. So firstly, testing and evaluation. I'm sure those two words have been mentioned a lot today and probably tomorrow too. There's some typical common mistakes that we see customers struggling with. So the first one is they build a really robust workflow. They spent like a bunch of time building some architecture out. And then they're like, okay, now we need to evaluate it. Like, let's build some evals. That's not really how it should work in practice, because your evals are actually the thing that directs you towards a perfect outcome, right? You can't build a whole workflow without evals probably from the get-go or very shortly after. And so, sometimes customers, as a result of struggling with data problems, might not be able to design their evals. You could use Claude to clean that up, do data reconciliation. Or they're just trusting the vibes too much. Maybe they run a couple queries, they're like, hey, it looks good, right? Are they really testing that on a representative sample though? Like, do you have enough samples to say that the thing that you're looking at is statistically significant? And or are you gonna run 100 things when it actually goes into prod, and then there's gonna be like loads of outliers because you didn't actually predict correctly what the customer is gonna ask of the model, for example. So I challenge you to think about your use cases as this sort of latent space, right? Let's take this kind of chart here on the left-hand side of the slide, right? As you explore the latent space with different functions that you can apply to the model, let's say prompt engineering, prompt caching, stuff like that, you're basically moving your kind of position in that latent space around between attractor states, And eventually you want to find an optimized point, but you don't really know where that is, right? Like if you're changing an instruction, you don't know how the attention mechanism of the transformer is gonna eventually result in some different outcome that might not be performant. And so the only way you can truly know that is empirically, and that's through evaluations. And so I think that's why evaluations are so important, and a lot of people just don't understand that soon enough. In many ways, I actually tell customers, evals are your intellectual property. Like if you want to be competitive in a space, you need to be able to outcompete people by navigating that latent space and finding the attractor state faster than anyone else. And so part of how you do that is, well, firstly, setting up some sort of telemetry to backtest. Ideally, that architecture is set up in advance, but you should invest in it. Designing representative text cases. So let's say you're working on that customer support agent eval. You might have a kid come on your website, let's say you're building it for, and might ask some crazy question like, how do I kill a zombie in Minecraft? Like, it's totally unrelated to your product. That's still probable, and so you should probably include silly examples like that in your eval set to make sure that your model is actually approaching the response in an appropriate way, or rerouting the question, et cetera. Cool. Moving on to the next one. Identifying metrics. So a lot of the time, there's this intelligence, cost, latency, triangle of trade-offs that people are trying to move in between. And most organizations can optimize for one or two of those things, but it's very difficult to meet three, at least right now. But realistically, that balance should be defined in advance, and you should know that for your specific use case, you're going to make a trade-off between those things. So let's say a customer support use case again. You care about your customer getting response within 10 seconds, right? More than 10 seconds, I think there's been research done on this. The customer's likely gonna just log off the page, and then they won't get the response, and then they'll probably complain about your product to their friends, right? Whereas if you're looking at a financial research analyst agent, you probably don't care that it works for 10 minutes to come up with the actual response to your question, because the decision being made after that is very important. It's an allocation of capital, for example. And so the stakes and time sensitivity of the decision should really drive your optimization choices. And maybe more instruction sets lead to longer latency but higher performance, et cetera. The other thing is UX could be important, right? So again, on that customer support agent, because we spoke about intercom, you could have different ways of circumventing that 10-second to 15 seconds. Specifically, you could add like a little thinking box that bounces around. You could send the customer to another web page in the meantime, have them read something, right? Like, there's loads of ways to distract and kind of push on those boundaries, but you still need to know what that important indicator is, and you need to optimize accordingly. Finally, fine-tuning. So a lot of people, I go into these calls and they're like, oh, we want to do fine-tuning. I'm like, oh, here we go again. Fine-tuning is not a silver bullet. So it comes at a cost, and most people aren't aware of that cost. The cost is generally you're doing brain surgery on the model, and thus there can be kind of limitations to its reasoning in other fields outside of the thing you're fine-tuning towards. So my encouragement is try other approaches first, right? Most people, they don't even have their eval set when they're trying to do fine-tuning, right? They need to have a clear success criteria in advance. And it's like, only if we can't get that in our specific intelligence domain do we then do fine-tuning. Don't try to boil the ocean in advance. The difference in fine-tuned capabilities and the wide variance of which failure versus success looks like in fine-tuning land means that you should be able to justify the cost of fine-tuning and the effort of doing it, right? Getting a team, fine-tuning, working with us, for example, you should be able to justify that difference. And so in terms of best practices, you don't want to let fine-tuning slow you down, right? You don't want to say, oh, I'm only going to convert this language model use case if we can actually finally fine-tune our model. It's like, no, pursue it, and then realize that you need to do fine-tuning, and then you can just sub in the fine-tuned model. And then explore other methods first. And there are loads of different methods that are Anthropic, as well as other companies are working on these days, and I just wanted to flash up a few of them as we wrap things up here. And so I'm not going to go through all of these, but alongside just base prompt engineering, which granted is very important, there are loads of different features or architectures that will change the success of your use case drastically. So for example, you might not need to sacrifice on intelligence of your model in order to speed it up by removing instructions, if you can just leverage prompt caching and have a 90% reduction in cost and a 50% increase in speed, right? Or contextual retrieval will drastically improve the performance of your retrieval mechanisms, and thus you feed the information to the model more effectively, and thus it has less of a time processing all the instruction set that you've given it. So there are quite a few things that you can apply here, and some of them are even out of the box, like citations. And then there are also architectural decisions, like agentic architectures. Barry, my colleague who's speaking tomorrow, will have a lot to say on that. But that pretty much does it. Thank you so much for your time. We'll be in the theater level lounge after this chat for follow-up questions. Anything else from you, Joe?
No, thank you so much.
Cool.
Cheers.
Ladies and gentlemen, please welcome back to the stage your MC for the Leadership Track Session Day, Peter Humphrey.
All right, folks, thank you again to Alexander and Joe for all their insights into applied AI with Claude. Anthropic is truly up to a lot of amazing things. Who's using Claude on a pretty frequent basis? I'll speak for myself. Okay, great, we got a lot of them. So it's been a pretty exciting afternoon. We've had case studies. We've talked about evaluation frameworks. We've talked about observability with agents, and we talked about self-managed AI infrastructure. That one I was particularly kind of interested in. And of course, Anthropic. Thanks again to Alexander and Joe. So we're going to take a 30-minute break before sessions continue right here at 4 p.m. And again, as before, if you want to discuss Meet the Speakers or talk about birds of a feather, like-minded topics from the last block of sessions, just go find the speakers at one of the 3 Q&A areas. Again, one here on the theater level, one at the very bottom of the stairs, right at the landing, and then another one tucked underneath, hidden away behind the stairs. Take some of this time during the break to stop in at the Sponsor Expo. There are more coffee and snacks. Again, our sponsors have some pretty amazing products, technology, and services to help you on your journey. See you back here at 4 o'clock. Thank you very much.
Ladies and gentlemen, please join me in welcoming to the stage your MC for the Leadership Track Session Day, Peter Humphrey.
All right, folks. Thanks. Welcome back again. You only have to see me one more time. You've made it to the home stretch. It's getting real. We are almost there. That said, our last sprint of sessions is a little shorter, just to take it easy on you, but it's no less exciting. We're going to have people speaking about AI and hiring, one of my favorite topics. I'm really excited for this talk from Heath. He's got some yummy data that I think you're going to like. And then, of course, we have other speakers speaking about building AI platform teams and org structure. And then we're going to finish off with retrieval, augmented generation, and data pipelines from a very special distinguished speaker. With that, please join me, put your hands together, and welcome Heath Black, Managing Director at SignalFire. Thank you.
Hi, everyone. I'm Heath Black. I'm the Managing Director of Product at SignalFire. And let's actually take a quick step back and ask, why am I here? So before I got involved in tech, I actually went and got a master's in Irish literature, of all things. Both of my sons are named after Irish writers. And you're going to see how this actually weaves into the presentation a little bit later. When you get a degree like Irish literature, you have to get creative in how you actually use it. In 2009, I got involved in some startups, and I helped ship the first ever conversational chatbot at a company called Chirpify. I then went and worked at a company called IMSI, where we were trying to build a Reddit competitor, but a lot nicer. And then I actually went and joined Reddit, where I worked on experimental business lines and trust and safety tools. And I followed that experience up by going to Meta, where I shipped Meta's first assistant. It was called M. It lived within Messenger. And then I was the first product manager on the AI assistant for their Ray-Ban glasses. But now I serve as the managing director of product at SignalFire. So what does SignalFire do? I like to say that SignalFire is actually the first VC built like a tech company. And what I mean by that is the same way that you all go out and interview customers to figure out whether you're building the right thing for them before you ship your product. SignalFire interviewed 500 founders to understand the things that keep them up at night and make them bang their head against the wall all day. We then built AI and ML tools and our portfolio success teams entirely around those problems, going to market, recruiting, building your leadership skills, and the ability to launch your product. But today, we're actually here to talk about some things that we've learned from our proprietary AI/ML platform, Beacon. Beacon tracks over 650 million employees, 80 million companies, and 200 million open source projects. And with all of that information, we build a variety of proprietary ranking systems and market insights that we can then use to power our firm so that we can move at startup speed, but then also to support the companies that we invest in. Today's focus, we're going to be using some of the data from Beacon to figure out how to filter the right people, to find them in the right locations, to nail the right timing, and then finally, to close them with the right narrative. So let's first start with filters. When I think about recruiting, I think about it in terms of like, what filters would I apply to the people that are on my team and that I want on my team? Beacon gives people the tools to apply these filters as they search. But the reality is, if you don't know what filters you need to apply, you're not going to find the right people. So here's some interesting trends that we've seen that change how we filter. Over the past decade or so, we've seen a stark decredentialization in AI. AI startups are hiring more engineers without PhDs or prestigious schooling than ever before. In 2015, 27% of engineer hires were from top schools, and 16% had PhDs. In 2023, those numbers were 15% and 7%. This is about a 50% decline for both of these numbers over that period of time. And you're probably saying, that doesn't sound right. What about for things like research scientists? They've got to have PhDs, right? And you're not entirely wrong. About 40% of research scientists have advanced degrees. Now, this is not PhDs, it's simply advanced degrees. And even still, it makes up less than half of the people that serve in research scientist roles today. From my standpoint, this isn't too surprising because there's been a slight shift in the market since 2015. In 2015, we were really focused on the kind of ML research side of things, the foundational side of things, whereas today, a lot of the work is about applying that to the real-world usage of that model. It's ML ops, product, like software experience. It's understanding how users interact with the thing that you're building. And with the shift from credentials, we've also seen this really interesting people mobility over this period of time. If you look on the left side here, historically, a lot of the AI talent was centered on these companies, the Googles, the Ubers, the Metas, the Apples. And over this period of time, they've shifted to 9 companies that we call the AIV League. The companies on the right here have seen a massive concentration of talent over this period of time. It's really interesting because we generated this last year. Shortly after that, Inflection was acquired. So one of the key things that I want us to take away from here is that the market is constantly moving. So we have to constantly be assessing where that market is shifting. And the interesting thing as well is that all the companies on the left side of the screen are now fighting viciously to get people from the right side of the screen rather than the other way around. But one of the key things is not just knowing where people are going. It's about where they're coming from. This graph shows you net employee movement between different AIV League companies, so to speak. As you can see at the top, OpenAI has a positive flow of people from DeepMind, whereas Cohere actually has a negative trend. Knowing where people come from and where they're going is essential in ensuring that you are filtering for the right people as you look for people, building out your teams. So the takeaway here is that work experience has always been important, but it now far surpasses education in terms of the main aspect that you should be looking at here. Don't just rely on the credentials that someone has. You should instead look at the body of work that they've compiled. For new workers, you can still look at their body of work. What are their open source contributions? What have they built outside of class? The reality is experience and what you're building matters more than where you get a degree. Secondly, you should be asking yourself, do I need a PhD researcher for the role that I'm hiring? Or will a really awesome engineer with experience suffice? And then the third is that you should actually consider removing academic requirements from your job postings, or maybe making them soft, so to speak, because this will ensure that your top of funnel is getting the people that have the experience you need more so than the education. Now let's talk about the next aspect, which is location. I'm sure many of you have seen the debates on Twitter that San Francisco is clearly dead. And so we wanted to know, is it? Interestingly, the answer is no, it's not dead. San Francisco makes up about 29% of all startup engineers. Now, this is slightly down from highs of 2013 when it was at 33%, but it's upticking again since 2021. New York and Seattle have also been pretty impressive as they've both doubled the market share of engineers that they have over that period of time. If we were to zoom out and look at big tech, 50% of big tech engineers still reside in the San Francisco Bay Area. But what about AI specifically? Well, San Francisco is still leading the pack. 35% of all engineers in AI reside within San Francisco. Seattle makes up about 22%, New York makes up about 10%, so San Francisco makes up more than both of those cities combined. But if you actually look at this slide and compare it with the data that I showed in the previous slide, you'll see that these markets are all punching well above their weight in terms of AI hiring and AI talent. Where they had a smaller number in the previous slide, they have a much larger number in this one. So the talent is concentrating in these three key markets today. Now, this isn't terribly surprising for me because San Francisco makes up nearly 38% of all early stage funding into AI startups. And the interesting thing about this is that San Francisco only has 26% of all early stage funding in the United States total. So not only is San Francisco punching above its weight in terms of AI talent, it's punching above its weight in terms of the funding that is going to AI companies today. So the takeaway here is that Twitter doesn't determine whether a market is dead. Data does. Location still matters, even in a highly distributed world that we live in today. San Francisco, Seattle, and New York are the premier locations for AI talent today. And so your job is to watch the location and funding markets to see where talent and capital is flowing as another way to filter and find the right people. Now let's talk about timing. Finding the right person has as much to do with time as it does talent. At the airport on the way here, it was a mere matter of minutes that separated me catching my flight or sitting in the lobby sad like Charlie Brown. A fraction of a second is the difference between a home run to right field or a foul ball in the bleachers. For me, timing means two different things. First, it means finding people when they are most likely to leave. Secondly, it means finding people that really are going to have a penchant to join a company at your stage and up-level your team for where you are today. So let's talk about timing. We analyzed some of those AIV League companies to see their retention rates. If you're on this slide, I'm sorry if the information offends you at all. But Anthropic is leading the pack with about a 66% four-year retention rate, while Perplexity hovers around 44% or so, 43%. This is just a small slice of the world as is constantly changing. But the reality is, understanding retention helps you know when you're likely to be able to get someone to answer that message that you send to them. It effectively creates a poachability score, so to speak, of your ability to land that person. But in addition to retention, we actually studied the behavior of different generations. They act differently. In 2023, nearly 27% of all Gen Z left their job. If you compare this with Gen X, that's actually more than 2 times as much as Gen X. And if you were to look at the fact that within 4 years after graduating, Gen Z has about 2.2 jobs, whereas Gen X has 1.1. And so some of this has to do with the fact that Gen Z is actually getting promoted at a slower rate. Some of it might be causing those slower promotions. Some of it has to do with the layoff market that took place over that period of time. But if you ask me, a lot of it has to come down to the penchant for people to take risk and bet on themselves. Gen Z likes that risk. But it's not just retention, and it's not just the generation you were born into. You need to know when people work at different companies. Being on the New York Knicks in 1973 is very different from being on the New York Knicks in 2018. One of those teams held up a championship trophy, and the other team had the worst record in their franchise's history. So at SignalFire, we built this cool tool. We call it historical composition. And it actually shows all of the startups that we invest in a snapshot of the companies that they admire at different points in time? What did their org structure look like at that point in time? Who were the sales leaders that took them from 1 million to 10 million? Who were the first 3 engineers on their team when they shipped that key product that I'm trying to beat now? These things are going to help you identify the risk profile people have. Are they going to join a company at your stage? It's going to help you understand the motivations that they have, but it's also going to help you understand whether they're a potential 10x hire, which you need to make in order to take your company to the next stage. So the takeaway here is that you have to understand timing, both from an outreach and an impact standpoint. You should know when your competitors or the companies that you admire most are likely to lose other people. You should track the people that work at those companies' profiles to see whether there are changes made to it over that period of time. Studying the patterns of different generations or segments of the population will help you understand how they change jobs. And finally, you need to know when people join and leave companies, because that will help you identify your 10Xers and help you identify people that are likely to join a company at your stage. Now, this is where I finally get to use that literature degree, narrative. One of my favorite writers, Kurt Vonnegut, has this awesome visualization for the shape of stories. If you look at the bottom left here, on the x-axis you have beginning and end, and on the y-axis you have ill fortune leading up to good fortune. So the bottom left here is Franz Kafka's Metamorphosis. Gregor Samsa wakes up a bug, and everything goes downhill from there. On the top right, you have a man walking down the street, and he falls into a pothole. But then he works his way out. But my favorite's Cinderella. She's on the bottom right over here. Things start pretty crummy for her. Her sisters are evil. She has to do a bunch of work. Then some magic happens, and she gets invited to this ball, meets a beautiful man, they fall in love, and then what happens? The clock strikes 12. She falls off a cliff, but then through a series of fortunate events, things lead to eternal bliss. Now, I'm not telling you that you need to preach the depths of despair that your company is in or has gone through, but you do need to understand the triumphs that you've had, why you are where you are today, where your arc is going. The reason for that is because historically, pay and equity were the 2 components that we use for narrative, but we can't rely on those solely anymore. Why? From November 2022 to November 2024, we saw a 1.6% increase in the average tech salary and a precipitous decline in the amount of equity granted. But I have some really bad news for the folks in this room. It's even worse for AI. AI engineers are the hot ticket for this year. They command a 5% salary premium and 10 to 20% equity premium over other engineering roles. So what was already expensive is getting even more expensive for us. So if we rely our entire narrative on that, we're relying on things that we might not be able to afford. So salary as a sole selling point has got to go. Equity was that other thing that we used to dangle to get people to buy into what we were doing as a company. But we've seen a precipitous decline in the amount of people that are exercising vested shares. In Q2 of 2024, 33% of people exercised the shares that they had vested. This is down from 55% a couple of years earlier. A lot of this is driven by concerns over valuations that might be a little bit too high, concerns about the cost of liquid capital to exercise these shares, and concerns about the market shifting, which it does every 3 weeks in AI. Equity can't be the only other thing that we're relying on. We have to get to a point where we're not just focusing on money and equity. We have to have things like a close-knit environment with working with the founders, collaborative teams, speed and the lack of friction to actually get stuff done, a big mission, the ability to grow your mind and your career opportunities, markets that are exploding and solving complex problems. You need to understand what all these things are for your company in order to not rely wholeheartedly on salary and equity as a narrative. So to summarize, in a world where so many companies are fishing in the same engineering pond. Recruiting data can give you an edge. These are just a few examples, but in the same way that you use data to build your product, both your models and the kind of analysis of that product, you should be assessing data to build your team. Your team is your most valuable product that you have. What we've seen is that decredentialization is happening, so you need to filter accordingly. Location still matters, so watch where people move. Data can help you identify the right time to reach out to people, and it can help you identify the right time that people have been at different companies. And all of this is going to help you craft a better narrative. So if you can filter, if you can time, if you can find the right location, and you can have a good narrative, you're going to do a much better job. If you're on the other side of the coin and you're actually looking for work, you should know where the people that you admire go, not just the companies, but the space. You should watch how long they stay there. This will help you know how they're treated, whether they think the space is going to be fruitful. And then finally, you should know what you want in that arc of your career. I'll be out in the lobby a little bit later. Thanks for your time.
Our next presenter is Engineering Manager for Generative AI at LinkedIn, presenting insights from building their Gen AI platform. Please join me in welcoming to the stage Xiaofeng Wang.
All right. Good afternoon, everyone. It's my pleasure here to share our journey on building out LinkedIn's Gen AI platform. My name is Xiaofeng Wang, Edge Manager of Gen AI Foundation. Let me try it one more time. Cool. In today's talk, I'd like to first share our journey on building out this platform, especially on why we're building it, how we build it, and what we're building it. After that, we will talk about some thought process on why this platform is critical for today's agent world. Hopefully, after that, you agree with me. This is a critical component in your company, and you also want to build this team. I want to share some tips on how to build such a team, how to hire for such a team. Towards the end, we will share some key takeaways and lessons learned. Before we dive into this application platform journey, I think it's important to first talk about the Gen AI product experience, because that's essentially what our platform is supporting for. Back in 2023, LinkedIn launched the first formal Gen AI feature called collaborative articles. This is a kind of straightforward Gen AI feature if we are thinking in today's standard, because it's a very simple prompt in, string out type of application. We leverage GPT-4 model to create the long content articles on the platform and invite our members to comment on it. At this stage, our team helped to build some key components behind the scene, including the gateway to centralize the access to the model, some Python notebook for the prompt engineering. But at this time, we actually have two different tech stacks to serve the experience. In the online phase, we use Java, and in the backend, we use Python. We wouldn't call this as a platform at this time. Very soon, we realized there are some limitations for this simple approach. Especially, it lacks the capability to inject our rich data into the product experience. Then, in the mid-2023, we started to develop the second generation of the Gen AI product. Internally, we call it Copilot or Coach. Here, we're showing one popular such experience on LinkedIn right now. Basically, it looks at your profile and the job description, and then use some RAG process to give you personalized recommendation on if you are a good fit to the job. At this time, we started to build some platform capability. Specifically, in the center of our platform, we built the Python SDK on top of the popular LangChain framework to orchestrate LLM calls. And it also provides the key value to integrate with our large-scale infrastructure in this SDK. So our developers can easily assemble an application. We started to unify the tech stack at this stage because we realized it's really costly to transfer the Python prompt into the Java world, not to mention the error during this process. We started to invest on the prompt management or prompt source of truth. This is a submodule at this stage to help developers to version their prompt and to provide some structure around their meta prompt. The most important piece I'd like to call out here is conversational memory. This is infrastructure to help to keep track of the LLM interactions and the retrieval content, and then inject those content into the final product. It will help us to build this kind of conversational bot. Now, zooming to this year, actually in the last year, we launched our first ever real multi-agent system called LinkedIn Hire Assistant. This is a multi-agent system to help our recruiters to do their work efficiently. Especially, it automates several tedious tasks normally recruiters need to do manually, like post the job and evaluate hundreds of candidates, then reach out to them. Our platform also started to evolve into the agent platform. From the framework side, we extend the support of the Python SDK into a more large-scale distributed agent orchestration layer. It will handle the distributed agent execution and also handle the more complicated scenarios like retry logic and traffic shift. For folks who build agent, I think you probably know the skills or APIs are one key aspect of the agent because we expect this agent to perform some action. One investment we did at this time is around the skill registry. Basically, we have a set of tools to help our developers to publish their API into this centralized skill registry. This skill registry can handle the skill discovery problem, skill invocation problem. So in your application, it's actually very easy to call the API to perform some task. Another key component we invest at this stage is on the memory. In addition to the conversational memory, we extend its capability into the experiential memory. Essentially, it's a memory storage to extract and analyze and infer the contextual knowledge from the interaction between the agent and our user. We also organize this memory into different layers, including the working memory, long-term memory, collective memories. This can help our agent to be aware of the surrounding content. Lastly, at this time, we also realize the observability is super important because agent, one key aspect to define agent is autonomous, right? Because agent can decide what API they can call, what LLM they need to call. So it's actually very hard to predict its behavior. So we started to invest on the observability. Particularly, we built our in-house solution on top of the hotel to keep track very low-level granularity of the telemetry data. So we can use this data to replay the agent call. And we also add an extra layer of the analytics on top of it. So we can use that to guide the future optimization of our agent systems. Let's put together all the components we build for this platform. We can classify them into 4 layers, basically, including the orchestration, prompt engineering, tools and the skills invocation, content, and the memory management. Of course, that's not everything in the LinkedIn GenAI ecosystem. In addition, we have our sister teams to build out the modeling layer, like fine-tune the open source models, responsible AI layers to make sure the agent is behave according to our policy and the standard, and also the AI platform or machine learning infrastructure team to host those models. The key value proposition for this GenAI platform is actually to be the unified interface for this complex ecosystem. So our developers don't need to necessarily understand all those individual bugs when they build their application. Instead, they can leverage our platform to quickly access to this entire ecosystem. For example, in our SDK, the developer can just switch one parameter in the one line of the code to switch from the OpenAI model to our on-prem model. Of course, they still need to do the prompt engineering, but that reduces a lot of the complexity on the infrastructure integration phase. Last but the most important is because of this is a centralized platform, it provides a place to enforce the best practice and governance. So we can make sure our developers are building the applications efficiently, but also responsibly. As you can see from our journey, we actually started to build this platform piece by piece, and then this platform started to emerge. If we take one step back and think, do we really need this platform at this time? Especially there are lots of vendor product on this space. Shall we buy it, build it, and why do we need to buy it or build it? Here are some thoughts. The short answer is yes. The reason behind it is we feel like GenAI is a totally different new AI systems compared to the traditional AI systems. So in the traditional AI systems, there's a clear cutoff between the AI model optimization phase and the model serving phase. So AI engineers and the product engineers can operate in two different tech stacks. They usually don't need to work on the same code base. But in the GenAI systems, what we're seeing is this line between the optimization phase and the serving phase disappear. Basically, everyone is an AI engineer who can optimize the overall system performance. This actually creates the new challenge of the tooling and the best practice in the company. Essentially, we think these GenAI systems or agent systems is a compound AI system. Here, we borrow the definition from Berkeley AI Research Lab. A compound AI system can be defined as a system which tackles AI tasks using multiple interacting components, including multiple calls to model, retrievers, or external tools. As you can see, this is actually skewed across AI engineer and product engineer. And I believe this GenAI app platform is trying to bridge this gap. To summarize, we believe this platform is critical for your success, mainly because it can bridge the skill gaps between those two group engineers. Okay. Let's say if you want to build this platform in your company and how to hire it is a frequent question I heard. I basically look into my great engineering team and extract all the key qualifiers from those top engineers. And I put all the qualifications here. The ideal candidate in this team is a strong software engineer who can build infrastructure integration. They have a good developer PM skills to design the interface. Ideally, they have the AI and the data science background to understand the latest techniques. They are the people who can learn from the latest techniques, but at the same time, they are hands-on. Unfortunately, it's really hard to get those candidates. If you get them, it's probably worth more than a unicorn. Realistically, we are making multiple trade-offs in the hiring. Here are some principles we follow, and it's actually working pretty well. I want to share here. In terms of the core skills, we usually prioritize the stronger software engineering skills over the AI expertise. This might be controversial, but we can discuss if you're interested. Second is, instead of hiring for experience or degrees, we hire for the potential. Because this field is evolving so fast, most of the experience might be outdated. In case you won't be able to find a single engineer with all the qualifications we're showing here, The way we are solving this problem is to hire a diversified team. So for example, in our team, we have some full stack software engineers, we have data scientists, we have AI engineers and data engineers. We also have fresh grads from the top research university, and also some people from the startup background. And then we put them together into the project. What we've seen is, based on those collaboration, those strong engineers start to pick up new skills in the project. And very soon, they started to grow into these ideal candidates. Lastly is, want to emphasize is the critical thinking. One constant topic in our team meeting is no matter what we're building right now, it will be outdated within a year, or even less than 6 months. So we consistently evaluate the latest open source package, talking with vendors, and deprecate our solution more proactively. Cool. Let's talk about, say, some key takeaways, especially on the tech stack choice. If possible, we strongly recommend Python. We started with Java and Python. There's some back and forth of the debate internally, but finally we picked Python, and I think that's the right choice, especially most research and open source are in this space. Based on our experience, it's also scalable. In terms of the key components you want to build in this platform, the first one is a prompt source of truth. Prompt in some way is like traditional model parameters. You want to have a really robust systems to version control your prompt. This is really, really critical for the operational stability. You don't want to accidentally add it to your prompt in production and see some really side effect. Second key component is on the memory. I think in today's today's talk, someone already talked about it. Memory is a really key component to inject your rich data into the agent experience. Lastly, in the agent era, one key new component we are building is on the uplifting our APIs into skills which can be called from the agent easily. So you can build some surrounding tooling and infrastructure to support this need. All right, let's talk about how to scale this solution and get it adopted. From our experience, instead of trying to build this full-fledged platform at the beginning, try to solve immediate need. For example, we started with a simple Python library to support orchestration. Then we started to grow into all the components we're seeing here. Second is focus on the infrastructure and the scalable solution. At LinkedIn, we actually have a pretty good success story by leveraging our messaging infrastructure to be as a memory layer. It's both cost efficient and scalable. Lastly is focus on the developer experience. By the end of the day, this platform is trying to help developers to be as productive as possible. Their adoption is a key for the success. If you can design this platform, please focus on how to align your technology with their existing workflow. So it will ease adoption and be more successful. We actually have lots of low-level details on the technical side. If you are interested, please check out our engineering blog post on LinkedIn by Karthik, Sandeep, and myself. With that, thank you for your attention. And if you are having more questions, happy to answer that after the talk. Thank you.
Ladies and gentlemen, please welcome to the stage the CEO and co-founder of Contextual AI, Dawa Kila.
Hi, folks. Thanks for being here. I'm the last talk for today. My name is Dawa Kila. I'm the CEO at Contextual AI, and I'm here to talk to you about RAG in production, RAG agents specifically. And I'll share some of the lessons that I've learned. So my background is in AI research, but after that, I became the CEO of an AI company focused on enterprise. So I thought I would share some of my learnings with you in the hope that that's useful. So if you look at enterprise AI, if you work in this space, you probably noticed that there's a huge opportunity ahead of us, right? Everybody wants to grab that opportunity. There's these huge numbers flying around. $4.4 trillion is the estimated added value to the global economy, according to McKinsey. So we have this giant opportunity. But at the same time, if you actually look at what's happening in enterprises, you see a lot of frustration. It's probably even true for some of the people in the audience right here. If you're a VP of AI, then you're probably under some pressure right now. It's like, where's the ROI? We're investing all this money in AI, but where is it actually leading us to? Are we getting something out of this? So Forbes has this interesting study where they showed that only 1 in 4 businesses actually get value from AI. So why is that happening, right? It feels a bit like a paradox. So to explain it, we can look at a paradox that might be familiar to you. It's something called Moravec's paradox. It's from robotics. And in robotics, they were very surprised when they found out that it's actually much easier to beat humans at chess than to have a robot that can vacuum clean your house or have a self-driving car. So the paradox here is really that things that seem hard are actually much easier for computers than you would expect, and things that seem easy actually turn out to be much harder, right? So there's something very similar happening right now in enterprise AI specifically, and this is around context. So on the one hand, we have these amazing language models, right? That's why we're all here, basically, because we see this revolution happening right in front of our eyes. So language models can generate code much better than most humans. They can solve mathematical problems much better than most of us here can do, and we're pretty smart. So it's really amazing what they can do. But one of the things that they really still struggle with, and that's one of the things that as humans we are very good at, sort of without effort, is putting things in the right context, right? So as humans, we build on our expertise, we build on our intuition that we've developed over the years, especially if we're a specialist. This is something that is very easy for us to do, is to put something in the right context and in the right situation so that you can make sense of the information or the problem that you're solving. So I would argue that this is really the key observation, this context paradox for unlocking ROI with AI. And the reason for that is that where we are right now here is in the bottom left, right? So we're mostly focused on convenience. We have general purpose assistants. They're very useful. Mostly if you're lazy, they help you sort of solve your problems faster. But where you really want to get to is differentiated value. If you're an enterprise, it's nice that you can make things more convenient. You probably can make people more efficient and more productive. That's great. But where you want to get to is this business transformation ideal, right? That's what all the CEOs are probably telling you as a VP of AI, like, I want to change my entire business. How am I going to do that? So getting to that differentiated value, that's where you want to get to. But the problem is that the higher you go on that axis, the further you go on the context axis. So the better you need to be at handling the context that exists within your enterprise. So what should we do about that? So that observation is really why I started the company that I'm currently the CEO of, Contextual AI. And we started this 2 years ago to try to help bridge this gap. And we've learned some lessons along the way that I thought I would share with you in the hope that they're also useful for you. So the first observation is really that language models are awesome, but often they're only 20% of a much bigger system. So if you have an enterprise AI deployment, usually that means it's a RAG system. So I think everybody here probably has heard of RAG. RAG is something that I originally pioneered with my team at Facebook AI Research when I was there. So RAG is really kind of the standard way that you get GenAI to work on your data. So what happens very often these days is a new language model comes out. Everybody goes, whoa, new language model, it's great. Everybody starts to think just about the language model, but very few people actually think about the system around the language model. And that system needs to solve the problem, right? So you can have a relatively mediocre language model, but an amazing RAG pipeline around it. And that's going to be much better than an amazing language model with a terrible RAG pipeline around it. So the basic observation here, or the lesson, is that you should be thinking about systems, not about models. The model is only a small part of the system, and the system is the thing that solves the problem. The next observation is that if you're in an enterprise, expertise is really your fuel, right? So one of the things that you want to be able to do as an enterprise is unlock all of that expertise. So you have all of this institutional knowledge in your company. How do you get it out? So one way to try to do that is using these generalist, kind of general purpose assistants, but it's very hard to get them to match the expertise of people in your company. So ideally what you want to do is to specialize so that you can capture that expertise much better. So at my company, we call this specialization over AGI. AGI is great. There are lots of use cases for it. If you really want to solve a very difficult problem that is very domain specific, where you understand the use case, you want to specialize for it, and you'll get much further. So that's, I guess, pretty counterintuitive if you look at the sort of broader interests, right? Most people are much more excited about AGI, but solving real problems is much easier with specialization. The next lesson is, at an enterprise scale is your moat. So if you think about what a company really is a company maybe it's people? Probably a little bit, right? But over time, what the company really is, or what makes a company is its data, because even people are transient, right? So the data that a company owns, that is the company in the long term. So now, as an enterprise, you need to think how you can unlock all of that potential, right? And so one of the big issues that we see a lot is that enterprises think that you need to scrub the data and clean it and invest a lot of time in making your data accessible with AI. But what you really want to do is make sure that AI can work on your noisy data at scale. And doing that is incredibly difficult, but if you succeed in doing that, that's how you get to differentiated value. Right? That's how you get that moat, because the data makes your company, and so that data is really your moat. One observation, and this is really a hard truth that we've learned, and I think that many of you might have learned already, or that you're about to find out if you're earlier in your journey, is that pilots are very easy. Building a demo is not very difficult these days, right? If you want to build a RAG system, you take one of the frameworks, you put in some documents, you have a working solution, it's great. You give it to your 10 users, they all tell you it's fantastic. And then you show it to the CEO, and he says, okay, we're going to fire half the customer support team, and we're going to replace them with AI. And we're going to do that in 3 months. And now you're on the hook for productionizing something that is actually much, much harder. Right? So getting this to work at tens of thousands or hundreds of thousands or millions of documents, you can't do that with any existing tools that are out there on the open source market. It's very, very difficult to do that. Making this scale to thousands of users is very hard. Making it work for lots of different use cases. If you're an enterprise, maybe you have 20,000 different use cases that you want to cover. So how do you scale if that's the problem that you're solving? And then there's, of course, enterprise requirements around security and compliance. So bridging that gap is much harder than you think, and the right way to deal with that is to really focus on production from day one. So don't design for the pilot, design for production, and that can save you a lot of time. And that brings me to the next observation, is that speed is really much more important than perfection. What we see in terms of production rollouts of RAG agents, it's all about speed. And what that means is you need to give it to your users relatively early, real users, not sort of testers who are kind of friendly. You want to give it to real users to get their feedback. You want to do that early. It doesn't have to be perfect. It just needs to be barely functional. And if you do that, then you can hill climb to actually get to this level where it's good enough. If you don't do that and you wait too long and then you try to design something that is perfect, it's going to be very hard to bridge that gap from pilot to production. So iteration is really the key to a lot of successful production AI deployments in enterprises. Next observation is related to this too, which is that if you want your engineers to be fast, and if you want to follow that speed maxim I just talked about, then you don't want them working on boring stuff. Sounds kind of obvious, but it turns out that engineers are working on a lot of very boring stuff. And so one of the things that they have to worry about, for example, is what is the optimal chunking strategy for my RAG system? And it's different for every use case, and it's different for every framework. And then they have to think about what the right prompt is, or really basic things that ideally they don't have to think about too much, because you really want your engineers to think about how am I going to deliver business value, right? How do I make sure I have this differentiated value and that I'm actually better than my competitors? So make sure that your engineers spend time on the things that matter and not on the chunking strategy or things that can be abstracted away very well these days by state-of-the-art platforms for RAG agents. Next one is about making AI easy to consume. So what I mean by that is we actually see this happen quite often where companies have GenAI running in production. And then the next question I often ask them is, okay, how many people are actually using it? And surprisingly often the answer is 0. Almost nobody's actually using it. They did all this work, but they had to make sure it came through sort of model risk and teams like that. So it was really like kneecapped almost, and now it's barely useful. So that's one scenario. Or very often people just don't actually know how to use the technology. So it really is a journey that you are on. And the easier you can make your solutions to consume, the better it is. And what that means for most enterprises is not just thinking about your enterprise data and how you make AI work on it, but also how you integrate it into their workflows. So the closer you can integrate it into a workflow that already exists in your enterprise, the more successful you're going to be with real production usage. Next one is related to the previous one as well, where it's really about getting usage. It's about sort of being sticky. And so this sounds maybe a little obvious, but the quicker you can wow users or get this sort of spark where they suddenly get it, this for me as a CEO of an AI company, that's really the special moment when people suddenly go like, wow, I didn't know that it could do this. So you can try to design your experiences for onboarding users around this observation too, right? So where they get to the wow as quickly as possible. So for us, we had this really nice example with someone at Qualcomm. So we're running in production globally with Qualcomm with thousands of customer engineers. And one of them became so happy when they found this document. It was 7 years old. It was hidden away somewhere. They didn't know it existed. They had all these questions, and they just never knew what the answers were. And suddenly, because they asked our system, they got these answers. And like their world was never the same again after that. So these are the small wins sort of that really matter for evangelizing production in AI. So that brings me to the penultimate learning, which is that it's not even really about accuracy anymore. So accuracy is almost table stakes, right? So I think as AI practitioners, we probably know that getting 100% accuracy is very hard, if not impossible. Getting 95% accuracy, maybe you can get there, or 90%. But what enterprises are thinking about much more these days is, what about the missing 5%? Or what about the missing 10%? How do I deal with the things that might go wrong, right? So there's a minimum requirement for accuracy, but beyond that, it's really about inaccuracy. And the way to deal with that is through observability. So you want to be very careful with how you evaluate these systems. You want to be very careful with making sure you have proper audit trails, especially if you work in a regulated industry. This is incredibly important, right? Making sure that you have an audit trail that says, this is why I generated this answer. It's because I found it here in this document. Basic things like that. So attribution, essentially, in a RAG system actually becomes very, very important for dealing with the inaccuracies. And similarly, what you can do is you can check the claims that your system generates. So do a lot of post-processing to ensure that you have proper attributions that you can really back up as evidence. Struggling with the clicker a bit. So final one that I want to end on, and this sounds maybe a little bit cheesy, but it really is true, is be ambitious. We actually see a lot of projects fail, not because people are aiming too high, but because people are aiming too low, where folks are going like, I have GenAI running in production, and then what does it do? It answers basic questions about who your 401k provider is, or how many days of vacation I get. Like, that's not really where the ROI of AI is, right? So you want to aim for really ambitious things where if you solve them, you actually have ROI, and you don't just have a gimmick that people don't really use anyway. So try to be ambitious, because we really live in special times. We have the astronaut here on the slide. So I think it was a pretty special time to be alive during the moon landing and when all of that happened, right? We're in a similar moment right now where AI is really going to change everything. It's going to change our entire society in the next couple of years. And so you have an opportunity, being in the role that you're in, to really affect that change in society yourself. So be ambitious when you do that, and don't aim for the low-hanging, easy fruit. Aim for the sky. So that's really what my lessons were for you here. This context paradox is not going away. But by understanding these lessons that I shared with you, hopefully you can turn some of these challenges that we see everywhere in enterprise AI into opportunities for yourself. So it's really build better systems, think about systems, not models. Focus on your expertise and specialize for it. Don't settle for general solutions. Specialize for the expertise that you have in your company and be ambitious, and then you'll be very successful. Thank you.
Ladies and gentlemen, please welcome back to the stage your MC for the Leadership Track Session Day, Peter Humphrey.
Woo! We did it. Thank you, everyone. And thank you, Dawe, for your insights into retrieval augmented generation. I mean, it's such an important part of this ongoing quest that we're all on for AI accuracy and relevance. I think in particular, I don't know if everyone saw the Google announcements in the last couple days about like 1 billion input tokens. So a really great session. I was pretty riveted on that one. It's been a pretty whirlwind afternoon, folks. We did topics like AI hiring. I thought Heath's session was great. So much good data there. Team building, case studies at LinkedIn, and of course, just now, retrieval augmented generation with Dawe. If you want to meet up with the speakers, again, same thing as before. There are those 3 Q&A lounges. One's here on the theater level, 2 downstairs, one at the bottom of the stairs, the other one tucked under. So that's a good place to go to chat with birds of a feather, people that want to talk, if you want to talk about topics from this afternoon. That'll be kind of going on for the speakers will be there for like the first 30 minutes of the reception, and then, enjoy some social time, some drinks, and have some fun. Quick reminder regarding brunch tomorrow. For those of you that don't have a bundle pass, so for security reasons, we are not reprinting badges. Sorry. So if you have a bundle pass and you are joining us tomorrow, please remember, put your badge in your bag. Don't toss it. Keep it with you tonight. Hang it on your front doorknob. Whatever it is that's going to help you remember it as you walk out the hotel room tomorrow. So that's it. You did it. Thank you so much for sticking with us today. That is a wrap. It's on to the after party at the expo. Like I said, we'll have some drinks and, of course, products, technology, and services from our sponsors. So please stop by and chat with them. Have a wonderful evening. Thank you for being here. And we'll see you tomorrow for the engineering track.